Hello, very good morning, students. Welcome to BYJU'S exam prep. Good morning, all of you. Very good morning. I think all good. Hello, good morning. Very good morning, guys. Sorry for that delay. Actually, there was a window update, so it took at least 5 minutes to update my system. Okay. Very good morning. Yes, let me check. I think all good. Okay. Good morning, students. Good morning. Hello, Abhi. Hello, Faninder. Good morning. How are you all? Good. Let me keep it over here. Yes. Very good morning, Harikesh. Good morning. All right. So today we're gonna start with the next subject, that is industrial engineering, and we'll be completing the entire industrial in one go. Okay. Definitely it's slightly mathematical subject, so we'll be taking some problems in between the topics only so that you can have better understanding. Okay. Very good morning, Shreyas. Good morning. Good morning. Good morning, all of you. Please do let me know all my audio and video all good, all perfect. Please write the comment section. Yes, everyone. Good morning. Very good morning. All right. Chaliye. Let's begin the session, right? And I hope so slowly the students will be joining and we'll be having a great session. It will be a lengthy, at least 7 to 8 hours will be the length of the session. We'll be going in a moderate speed, not too slow, not too quick, because I want you guys to have a quick revision of the entire subject. Okay. Abhi 7 hours, 7.5 hours will be the maximum duration that we're expecting for this particular session. Lakshmi, good morning. Very good morning, all of you. Okay. Okay, fine. Chaliye. So let's begin the session. I think it's all good. All good with audio and video, right? All perfect. Okay, all set. Chaliye, so let's begin with the session. And I hope so everything will be good, fine, perfect, right? Let me check my end also. Yeah. Okay, so I will be sharing the complete PDF along with my handwritten also will on my Telegram channel. That is you are seeing on the screen, right? And definitely, if you have any doubt or difficulty, you can do post me there only on the Telegram channel, right? Along with this, Rakesh sir will be coming up live on 17th of Jan for 2025 aspirant, those who are planning for 2025. Great. Now, I hope so you have already have this particular schedule along with you. Till last class, we are having like machine design is being completed, right? Today industrial and tomorrow we'll be having the engineering mechanics. So this way, entire different subjects, entire mechanical engineering will be completed in one go till 20th of January. And after 20th of January, like I think from 22nd of Jan, you are having mathematics and aptitude marathon sessions is being planned. So please do attend that also because that is also important. Definitely 30 marks you'll be getting from those mathematics and aptitude. Okay, good morning, Vinay. Very good morning. Very good morning. Okay. On every class title at the bottom, you are having one link that you can see on the screen also, right? This one. I hope so you are able to see. Let me check. I think I'm coming in front of the camera. Okay, 1 second. Yeah, this particular link that you are seeing, by clicking on this link, you will be having one-on-one counseling session for all the aspirants, those who are having any doubt or difficulty, or those who want any guidance from our expertise. You can click on this link and you can have one-on-one session with our expertise. That could be faculties also, right? But you have to click on this and you can have one-on-one counseling with our counselors also, right? Okay, now mock test plays a very vital role. I hope so everyone is taking the benefit of this free mock test which is being given by BYJU'S exam prep, right? Definitely it's very important to attempt multiple mock tests and try to analyze the results. That's very important and interesting. Yes. Yes, happy Sankranti to all of you. Happy Pongal also. Happy your in different states we're having different festivals, right? So I wish you all a very happy festival to all my dear students and try to take that positivity in your preparation and try to get the best outcome that will be your 2024 gate. Okay. Chaliye. Right. Okay, Mishra, no, it's not like this. Lot many PSUs are already given their notification. So if you have given your best in your last at least 6 7 months, definitely you'll be getting the results out of it. Okay. No, I'm again repeating. If you are giving your best, if you are studying really hard, definitely there are lot many opportunities in government sector, specifically in mechanical branch or in civil branch, the core sectors, right? So it's not like this. If you need to have any software knowledge to get into BHEL or ONGC, you need to have the technical aspect, because ultimately whenever there is any maintenance breakdown, whenever there is any technical fault, no software is going to help you out. It will be your brain, your concept that will be helping you out. Okay, fine. Chaliye. So let's begin with the first topic, that is PERT and CPM. We'll be starting with one by one different topics. Okay, why I have taken this PERT and CPM? Because this is a very important, and almost every year or alternate years we are expecting question from this topic. It's a scoring one also, and it's an important also from any examination perspective. That could be GATE or any other examination. Okay, so shall we begin? Yes, right, everyone, please do let me know. 1 second, guys, please do let me know. All good? Yes, all set. Okay. Sir, how to give a mock test in BYJU'S exam prep? Semi, actually, in the description only, na, there is one link in the bottom of my video. There's one more like description. In that case, there is a direct link where you can attempt the mock test. Okay. All set. Okay, chalo. And let's maintain this energy level till the evening, right? So let's begin with the first topic, that is PERT and CPM. So before understanding PERT and CPM individually, let us understand what is the basic difference between PERT and CPM. Okay, fine. Okay, let's quickly have I need response from your end also. What is the major difference between PERT and CPM? Anyone? Yes. Yes, quickly. PERT and CPM. Basically, if I talk about PERT analysis, it's a probabilistic approach. It's a probabilistic approach, and CPM is a deterministic approach. Now, what is the meaning of this word probabilistic or deterministic, right? Probabilistic means basically in PERT analysis, we don't know actually what will be the completion time of an activity, right? Now, let us suppose I have to do a welding operation. Now, because welding is being done since several years, so we know what will be the exact completion time for completing a set of welding. But let us suppose if you are doing welding for the first time, right? So in that case, I won't be having that exact idea what will be the completion time, right? So whenever we are dealing with those activities which is being done for the first or only few number of times that particular activity is being executed, so there we are basically applying the PERT analysis, right? So that is the reason we are calling it as a probabilistic approach and CPM as a deterministic approach, right? Because PERT analysis is a probabilistic approach, so we will be using three different time estimates. Three different time estimates will be used in the PERT analysis. In CPM analysis, we will be using a single time estimate that will be having only one completion time, one activity completion time. Okay, one activity completion time, right? Okay, now what is the meaning of this word three time estimates? Now, if I talk about PERT analysis, we are discussing every activity we will be having three different time of completion. What do we call this three different type of completion? We'll be having a optimistic time, we'll be having a most likely time, and we'll be having a pessimistic time. We'll be discussing this individually one by one, what is optimistic, what is most likely, and what is pessimistic. Okay, and in case of CPM, because we know what will be the exact completion time, so there we won't be having any different time estimate. We'll be having one activity, we'll be having a single completion time. Okay, fine. So can anyone who can tell me where we are actually using this PERT and CPM? What is the basic applications or where we are using this? Anyone? Yes, in the comment section. Shreyas, Paninder, Abhi, where we are using this PERT and CPM individually. If I talk about PERT analysis, we are using normally in R&D sector. Why we are using in R&D sector? That is research and development. Because in R&D sectors, we don't know the exact completion time. Okay, We don't know the exact completion time. That is the reason we are applying the PERT analysis in that particular sector. But if I talk about CPM analysis, we are using in construction management because we know what will be the exact completion of an activity. So basically we are doing to optimize our project completion time in case by using the CPM. Okay, exactly. Very good. Very good. Everyone, I think everyone knows about the practical applications of PERT and CPM. Perfect. Okay, so let's start with first one, that is PERT. Then we'll be taking the CPM, and in CPM we'll be talking about the crashing of a activity in order to optimize the project completion time. Okay, so we'll be discussing this in one by one different manner. So let us first start with the first one, that is PERT analysis. In PERT analysis, already we have stated we are having three different time estimates. We are having three different time estimates. Okay, fine. That is your optimistic time, the most likely time, and the pessimistic time. Now, what is the meaning of this word optimistic time? Anyone who can tell me? What is the meaning of this word optimistic time? What is the meaning of this word most likely time? And what is the meaning of this word pessimistic time? Yes. Anyone? What is the meaning of these three time estimates: optimistic, most likely, and pessimistic? Now let us suppose I'm having an activity A. Having an activity A. Now in order to complete an activity A, all the condition is in our favor. Okay, all the condition is in our favor. So that particular time we call it as the optimistic time, right? That means everything that condition that is required to complete an activity A is in the favorable condition. Okay, fine. Let us suppose if you are taking the opposite scenario, if all the condition to complete activity K is not in our favor. Let us suppose you are doing welding operation. Okay, so whenever you are doing welding operation, the machine that you're using is in the worst condition. There's a voltage fluctuation going on. The welder who is welding, who is completing the welding operation is the worst welder that you are getting. So definitely that is a worst scenario that is being required to complete an activity. So that particular condition we call it as the pessimistic time. Okay, fine. And in between the optimistic and pessimistic time, we are having one time we call it as most likely time, which is basically a time required to complete an activity under normal condition. Normal condition means some condition will be in our favor, some condition will not be in our favor. Okay, so can anyone who can tell me which will be having the least magnitude? Which will be having the minimum magnitude? Anyone? Yes. Among optimistic, most likely, and pessimistic, which will be having the minimum most magnitude? Definitely, because optimistic time is the time in which every condition is in our favor. So definitely I'll be completing that activity in the least possible time. So I can say this is the minimum most magnitude, this is the maximum most magnitude, and this is in between. Most likely is in between optimistic and pessimistic, because sometimes what happens in problems, they won't be giving you this is optimistic or pessimistic or most likely. They'll be giving you there are three time estimates for an activity is, let us suppose 5, 8, and 12. Okay, so definitely by looking at the magnitude only, you'll be able to understand this is your optimistic time, this is your pessimistic time, and this is your most likely time. Okay, is this clear? Right. Now, because this is a probabilistic approach, PERT analysis we already have seen, which is program evaluation, review, and technique. This is a probabilistic approach. So definitely we need to follow some distribution. So it is being observed that in case of PERT analysis, the activity is following the beta distribution. The activities are following the beta distribution. If you try to plot the beta curve, right, then we will be getting a curve something like this. Okay, let me draw it over here. Yeah, 1 second. Where is that? If I try to draw the curve over here, we are having the probability of completion. Here we're having the time estimates, right? We'll be having the optimistic time, we'll be having the pessimistic time over here. We'll be having the pessimistic time, and the curve will be something like this. Okay, and in between we'll be having the most likely time. Okay, TM, the most likely time. Now over here because whenever we are talking about any activity A, B, C or D, we always want a single time estimate or single time of completion. We won't be every time we'll be talking about like if this is in the favorable condition, then the time required to complete an activity is 8 minutes, sometimes 12 minutes. So overall, we need to have a single estimated completion time, which we denote it as TE. Small t, that is a expected completion time of an activity. Expected completion time of an activity. Okay, fine. So TE is basically resembling you about what is the expected completion time of an activity. Because this is following a beta distribution, so by taking the help of the mathematical approach, we can say TE is equal to the optimistic time plus 4 time of most likely plus pessimistic time divided by 6. Okay, this, by using this formulation, I will be able to calculate what is the approximate expected completion time to complete an activity, because we will be dealing with 3 different time estimates for different activities. Okay, so it's very important to have a single completion time of an activity. So for calculating that single time estimate, we are using this relation which is coming from the beta distribution curve, right? So normally this TE value is somewhere near about to the TM only. It is somewhere near about to the TM only, right? Okay, let us take one example so that we are having better clarity. Let us suppose I'm having let us suppose I'm having a particular 6 activities, right? Now here, if I can say that there are 3 different time estimates. This is your optimistic time, this is your most likely time, and this is the pessimistic time, right? So if I want to calculate what is the expected completion time of an activity for activity 1 and 2, can you tell me what will be that? Anyone? What will be the expected completion time? It's quite easy. Then we have to use a simple formulation. TE is equal to the optimistic time plus 4 times of most likely plus pessimistic time divided by 6, right? So it will be what you have to do, you have to multiply 4 on this. So 1 plus 4 plus 7, that will be 12 divided by 6, that is 2. It will be equal to 2. I'll be writing the direct value. You have to cross check by using this formulation. Okay, right? Fine, you have to multiply 4 times. So 1 plus 4, 5, 5 plus 7 is 12, by 6 is 2. So it will be 16 plus 8, that will be 24. 24 by 6 is 4, right? Very good fun in there. This will be your 10 plus 8, 16, that will be 2, right? Exactly. 4 plus 2, 6, that will be 1. 20 plus 36, that is equal to 6. This is 10 plus 24, 20 plus 10, that is exactly 30, that is equal to 5. And last one is your 143. Let me check. This will be 16. 16 plus 8. This will be 3, I think. Na? This will be 3. Or not this one. This one will be 16 plus 8, 24, 424. This will be 8 plus 10, 18. This will be 3. Third one. Third row will be 3, right? Exactly. Okay, and the last one is 42, 7. Clear? Are we getting this one? 2, 4, 3, 1, 6, 5, 7. Please do cross check everyone. Harikesh, yes, correct. Thank you for that. You have to help me out in the calculations, right? Because in between we'll be having some calculations, in between lengthy calculations. For that you have to help me out. Okay, perfect. 1657. Very good, shares. So this way I have calculated for every activity what is the expected completion time. All set, right? Now once you have calculated this, next is you have to understand what is the meaning of the critical path. Okay, and before understanding the critical path, we have to understand one more thing, that is we call it as your standard deviation. Standard deviation, okay, of an activity. And what is the variance of an activity? Acha, can anyone who can tell me what is the meaning of this word variance? What is the meaning of this word variance? Anyone? What do we imply by this word variance? Anyone? Yes. Variance is basically, let us suppose I'm having a variance of a larger magnitude. That simply means the uncertainty of completed an activity is too high. Okay. Variance is basically telling us about the concept of uncertainty. Okay. Not the difference heavy, exact word will be uncertainty. Correct, Faninder? The more the magnitude of the variance, the more will be the uncertainty in the completion of an activity. Okay, then how we can calculate an variance of an activity? We can say the difference of TP, that is pessimistic time minus optimistic time, divided by 6 whole square. This is basically the variance value. Okay, by taking the formulation, the pessimistic time minus optimistic time divided by 6 whole square will be giving you the variance of a particular activity. Let us take an example. Let us suppose I'm having an optimistic time. There are two activities. Okay, let me take it in this particular example. Let's suppose that we're having an activity A and we're having an activity B, right? The optimistic time for activity A is, let us suppose, 2, and for B is also 2. The pessimistic time for this is 10. For this is, let us suppose, it is equal to 100, or let's say like it is 50. Okay, the most likely time, let us suppose it is somewhere around 7, and the most likely time is somewhere around, let us suppose, 30. Okay, so here you can see that when everything is in our favor, the activity A will be completed in 2 minutes. Okay, and when everything is against the favor, the activity will be completed in 10 minutes. So we will be always be having the completion of an activity ranging between 2 to 7. That means the variation is from 2 to 7. In the case number B, what is happening? When everything is in our favorable condition, the activity will be completed in 2 minutes. When everything is against the favor, it will be completed in 50 minutes. So here we can say the range we will be getting, it will be too high. That means here we can say the uncertainty to complete activity B will be higher as compared to that of activity A. Is this clear? Understood? What is the physical significance of this word variance? Variance basically tells us about what is the uncertainty, because here we can have sometimes 31, sometimes we can have the completion time to be 22, 23, 24. We are having a large set of values, right? In this case, we are having a small set of range in which the activity will be completed. So definitely we can say here the uncertainty is less. Here we can say the uncertainty is less. We will be quite sure that the activity will be completed between 2 to 10 only. But here the activity will be completed between 2 to 50. So here the uncertainty level is too high, right? So by taking the formulation of this, we can say variance of an activity is equal to TP minus TO, because it will be giving us the range, divided by 6 whole square. And what is the standard deviation? It is under root of variance. Okay, that is equal to TP minus TO divided by 6. TP minus TO divided by 6. This is, I'm talking about our activity. Okay, please make sure we are now only discussing about activity. After that, we'll be talking about project. Right? Now, we have seen that for individual activity, we have done an analysis. We have done that every activity might be having 3 different time estimates, which is following a beta distribution, and it can we can calculate an exact completion time, or we can say estimated completion time of an activity by using a simple formulation, that is TP plus 4 times of TM plus TO divided by 6. Right? Now, we whenever we are talking about from a broader perspective, we are always talking about a combination of different activities. Okay, let us suppose if you are talking about construction of a building. So whenever you are constructing a building, right, so there we are talking about different activities. We have to lay foundation, we have to bring the raw materials, we have to have your pouring activity. Different activities are there. We have to do the concreting also, right? So here different activities is being entire project is being broken down into different activities, right? So here we have to now understand what is the meaning of this word project. Project is basically, here we'll be having a combination of different activities. Combination of different activities, right? And it's very important to have this analysis. The reason being, till date we are using this particular concept in the different industries also, like PERT and CPM analysis. Like many, if you later on, let's suppose after 10-15 years of your job, if you're planning to do some management courses, there the management students, the MBA graduate is studying this scheduling, this PERT CPM, right? The linear programming is also being studied in different graduates, MBA graduates. So it's a, we can say it's a management subject where you are using, the main objective is basically to optimize anything. Okay, the PERT and CPM is also being used to optimize our project completion time, right? So we know that project is a combination of different activities, and activities analysis we have done. We are having the standard deviation of an activity, we are having the variance of an activity, we are having the estimated completion time of an activity. Now we have to talk about from the project perspective, where we'll be having lot many combination of activities. Like we have taken this example. In this example, we have seen activity 1, 2, 1, 3, 1, 4. These by the combination from the starting of activity 1 till the end of this 6, we are calling it as a completion of project. We can say 1 is resembling about the start of project, right? And 6 is resembling about the end of project. The project is completed, right? And in between this 1 to 6, we are having a lot many different activities. Some activities will be done in a parallel way, that means simultaneously it will be done. Some activities must be done in a series way. Series way means unless and until this activity is completed, you cannot start the next activity. Okay, fine. So this way we have to understand. Now for completing any project, we have to ensure that every activity that is being associated with that particular project should be completed. Okay, for analyzing this, we have to now understand a very important concept. We call it as critical path. Now, what is the meaning of this word critical path? Anyone have any idea about what is the meaning of this word critical path? You might have heard about this particular terminology. What is the meaning of this word critical path? Anyone? Yes, Pujita, Harikesh. Longest time taking path. Okay, Fanidar is saying longest time taking path. Exactly. I can say that it is the longest time taking path in the network diagram, in the network. Okay, or we can say it like this also, it is the minimum time to complete the project, right? Longest time, or we can call it as maximum time consuming. Consuming path. Exactly, very good. Now we are on one end we are saying it as longest time or maximum time, and on the other end we are calling it as a minimum time. It is quite opposite nature. So is that both the statement correct, or only one statement is correct? Yes, because we always have a perception that either it will be maximum or it will be minimum, right? So tell me, is this particular both the statement correct, or only one statement is correct? Both are correct. Very good. Now, whenever I'm talking about the maximum time consuming, I'm talking about from the network diagram, from the pathway, right? Whenever I'm talking about minimum time, that I'm talking about from the project completion perspective. Both are correct. This one, both are correct. It's not only one is correct. Both are giving me the same resemblance. Okay, so now let us understand what is a critical path. Okay, and how an activity is being denoted, right? Because there are two representation in any network diagram. We can have an activity on node or event on node. Okay, like normally we are using a simple representation. Let us suppose we are having activity A. Let us suppose I'm having activity A, right? and we are calling it as this is your activity on arrow. We call it as activity on arrow, AOA terminology. Let's say it is taking 5 minutes. So this is a way of representing an activity A which is taking 5 minutes to complete, and it is going from event 1. This we call it as event. This we call it as event, or we can call it as node. Okay. Event basically tells about the start or an end of an activity. Okay, it is only the representation, that's it. It is not taking any resources to complete. If I say start of the class, so we are not taking any resources, we are just starting the class. Delivering the lecture is an activity. Okay, fine. Speaking is an activity, but start to speak is just a representation of an starting of an activity. Clear? Okay, now the question is how we can identify a critical path. Let us take a very basic example. Let us suppose I'm having a project which is taking 4 activities. Let's say 1, 2, 2, 3, something like this. I'm taking a very basic example. Let us suppose I'm having activity A, activity B, activity C, and activity D. Right? There are 4 different activities, and now if I say if I want to start activity B, which activity must be completed? Can you tell me? By looking at this network diagram, if I want to start activity B, shall I need to complete C also, or only completion of A is sufficient enough? By looking at the network diagram, can you tell me? It's quite obvious that whenever I'm talking about activity B, start of an activity is represented by node 2 or event 2. And event 2 is telling us about the completion of activity A. Okay, so once activity A is completed, then we can start activity B. But if I talk about activity D, both B and C activity must be completed, then only we can start activity D. Okay, is this clear? Right? So let us suppose I'm taking some time estimates. Let's say I've just calculated by using this term, this particular formulation, that is TO plus 4 times of TM plus TP divided by 6. I've used the formulation. I'm getting, let us suppose this is 2, this is 6, this is let us suppose 7, and this is 5. Okay. So can you tell me what will be the critical path? What will be the critical path? Yes. How we can identify? There are 2 ways to identify critical path. First of all, we'll be talking about an easy way, the short technique, the which you will definitely you have to use in the examination. Okay. So let us suppose I'm starting with this one, A, B, and D. A, B, D is an critical activity. Very good. We'll be starting from 0. Now, to reach node 2, right, we are having only one pathway. So 0 plus 2 is 2, right? 2 plus 6 is 8. Now, to reach event 3, there are 2 pathways. Either you can go from A to B, or you can directly go from 1 to 3, that is through C. So if you are going with activity C, we are taking 7, right? If you remember what was critical path, it is the longest time taking path. So I will be getting the highest time, that is 8, by using the pathway that is A and B, right? Okay. And when this activity E will be event E will be started, the event 3 will be started, then activity D will be completed on 4. So 8 plus 4 is 12. So I can say capital TE is basically telling about the minimum time to complete a project. Time to complete the project, and that is equal to 12. Let us suppose I'm taking it as days, 12 days. Ajay, might be 5 o'clock, 4 or 5. It depends upon your response. The more easily you are able to understand, the more quickly we'll be able to cover. Okay, fine. Now you'll be saying that, and it is being denoted by double arrows. Critical path is always resembled by double arrows. So my question is, oh sorry, 8 plus 5 is 12, 13. Yes, thank you, 13. 13. I was actually adding 7 plus 5. My question is, sir, we can complete in 12 days. Like if I am taking 7 plus 5 is 12. Let us suppose I'm taking 12. Definitely 12 is lesser than that of 13. But if I try to take activity C into consideration, that is 7 plus 5, that is 12. So will I be able to complete activity B? Because to complete activity A and B, I have to take 8 days, right? If I'm taking only 7th day, so by 7th day, activity B won't be completed. Let us suppose after 7th day, if you're starting activity D, you cannot start. Why? Because activity B is still requires one more day to complete. That is the reason we are calling it as the longest time taking path is basically your critical path, right? And why we are calling it as critical path? Because why we are calling it as critical path? Anyone? Why we are calling this to be the critical path, that is A, B and D. A, B and D. Why we are calling this to be critical path? And why we are calling this A, B and D are the critical activities? Anyone who can tell me? Because let us suppose, exactly, very good, very good. Vinay is absolutely correct. Why we are calling A, B and D as the critical activities? Because there is no provision of dealing that activity. If you try to delay, let us suppose I'm dealing activity B by 1 day. Let us suppose I'm changing from 6 to 7, right? I'm changing from 6 to 7. My entire completion time will be increased by 1 day. You can cross check. If I'm changing the B value from 6 to 7, then the project minimum time to complete the project will be increased to 14 days, right? And that is the reason in any construction, even in power plant, in real life, in power plant, whenever we are having the construction phase of any power plant, normally the boiler area and your boiler area and your crusher part, where we are having the crushing house, these two are normally the critical activities. Normally they are lying in the critical pathway. Okay, rest all the activities might you can have some delay, but normally the most critical activity in the entire power plant is the boiler area. All right, you cannot have any provision to delaying in activities. Let us suppose if you want to delay activity C by 1 day, no problem, I can delay activity C by 1 day. Even if you are completing in 8 days, right, still the project will be completed in 13 days only. There is no change in the completion time. And why we are using this? I can send some of the resources to activity B so that I can complete activity B or A on time. That is the reason to allocate the resources. For the reallocation of the resources, we are using this PERT analysis in reality. Okay, it's not on paper for examination perspective. It's basically from real life application, because sometimes in some interviews, in PSU interviews specifically, they were going to ask you something related to the industrial engineering. You have to know what is the practical application of this. Okay, fine. Is this clear? Right. So we have understood how to identify the critical path. We have understood how to identify the minimum time to complete the project, which we are denoting as capital T. Now, PERT analysis was a probabilistic approach. Just now we have seen, and here, if I talk about the project completion, basically it is following a normal distribution curve. It is following a normal distribution curve. Now, if I try to plot, I hope so everyone knows what is a normal distribution curve. We call it as a bell curve. We call it as a bell curve also. Okay. So this is the center line is basically capital T. That is the minimum time to complete the project or expected completion time, right? And by using the your critical path analysis, we have identified that capital T is coming out to be 13 days, right? This is the minimum time to complete the project. But let us suppose if I want to complete the project in 15 days, right? Minimum time that is being required by using the PERT analysis, we are getting 13 days. But let us suppose if I want to complete the project in 15 days, what will be the probability of completing the project? That analysis is basically being used in the PERT analysis. Okay, fine. So let us suppose I'm using one more time estimate, time, that is TS, that is we call it as schedule time. Okay, what is schedule time? That means the time which we are taking to complete a project. Let us suppose capital T was 13 days, right? And if you want to complete that particular project in 15 days, then capital TS will be equal to 15. Okay, because it is following the normal distribution curve. Now, I hope so you know about this bell curve, right? Let us suppose I'm taking this TS value somewhere around here. Okay, I'm taking a rough value that TS is coming somewhere around here. So what is this area under this normal distribution curve or the bell curve telling us about? It is about a concept of standard normal variate. Okay. Yes, Neeraj, it is being included. I'll be taking one question on crashing also. Okay. Crashing model, I'll be taking one question also so that you can have a better clarity. Right. Now, coming back to this. Now, Z is basically, it is purely mathematical. It's nothing related to industrial engineering. Now, whatever I'm discussing right now, that standard normal variate, standard deviation, it's completely mathematical, right? So, I'll be using the concept in our PERT analysis, right? So, Z resembles the standard normal variate, and there is one table. By looking at the particular table, if you see that table, let's say I'm taking Z equal to 0. If I'm getting Z equal to 0, I'll be getting 0.5. That means the probability of Z equal to 0, we are getting 50%. That means if you calculate the value of Z, then the probability of completing that particular project will be 50%. That means I have to identify one formulation to calculate the value of Z. Once the Z value is calculated, I will be seeing this table and I'll be able to calculate the answer. Now it's very tedious task to remember all these values, because Z is equal to 0, Z equal to 0.01, Z equal to 0.02, Z equal to 0.03, or Z equal to 0.1. So it is a very difficult task to remember the entire set of values. So we'll be only remembering one or two values. Okay, two values more than sufficient enough, and by using that two values, I will be able to identify other set of values also. Let us suppose I'm taking probability of Z equal to 1. Okay, it is being seen that probability Z equal to 1 is approximately equal to 83.4. We can take it as 84%, near about to 84%. If I take probability of Z equal to 2, near about to 98%. Okay, fine. We'll be understanding this from the graphical perspective also. Let us suppose if I'm taking Z is equal to 0. Let us suppose I'm taking Z equal to 0. Now, standard normal variate, because I need to have some relations to calculate the value of Z in terms of the PERT notations. So it is being seen that Z is equal to the difference of the schedule time minus the expected completion time divided by the standard deviation of the critical path. This is the way to calculate the value of standard normal variate. TS value will be given in the question. TE we can calculate by using the critical path. Now, the question is how we can calculate the standard deviation of the critical path. Standard deviation of critical path. Okay, so it is being seen that, let's suppose I'm taking the same example, 1, 3, 2 and 4. I'm taking the same set of example that we were having A, B, C or D, right? And we were having this as a critical path. Okay, so I can say the standard deviation of the critical path will be equal to under root of sigma A square plus sigma B square plus sigma D square. We'll be taking the summation of the variance of all the critical activities. I can say the standard deviation of the critical path is equal to under root of summation of variance of all critical activities. Okay, is this clear? I have to add, because what is variance? The square of the standard deviation, and we know what will be sigma, that is equal to TP minus TO divided by 6 for all the different activities. For all different activities, we can easily calculate what is the standard deviation, and to calculate the standard deviation of the entire path or the entire critical path, we have to only take the summation of the variance of only the critical activities. That's it. Non-critical activities I won't be taking. So once I'm getting the value of Z, I can just cross check with this particular table and I can get the value. Normally you will be getting near about from 0, 1, 2, or sometimes you will be getting value of let us suppose Z is equal to -1 also. Okay, now let me take one table. Let me draw the table and let us try to understand what is this table actually means. This is capital T, right? We have seen that Z is equal to TS minus TE divided by the standard deviation of the entire project. I can say that TS is equal to TE plus Z into sigma. Yes, we can write it like this also. Now, if I say if Z is equal to 0, what is the meaning of this? To place Z equal to 0 in this particular formulation, and you tell me what is the relation between TS and TE. If you put Z equal to 0, can we say TS is exactly equal to TE? That it will be coming exactly at the center line? Yes. And if you try to take the area under the curve, the left hand side of this, okay, that is nothing but only 50% of the area will be covered, and that is the reason the probability of Z equal to 0 is equal to 50%. That means if you want to complete the project in 13 days, the probability of completing is only 50%. There is only 50% chances that this example that we have taken, this example, if you want to complete this project in 13 days, the chances of completing the project is only 50%. There's 50-50 chances only, right? Okay. Now, tell me one thing. If I try to take, let us suppose Z equal to 1, then TS will be equal to TE plus sigma, right? That means slightly more than that of TE, somewhere around here. Now, if I try to take the area under this curve, it will be more than that of 50, right? And it is being observed that when you are taking probability of Z equal to 1, it will somewhere around 84%. Somewhere around 84%. That is more than that of 50. Let us suppose I'm taking this as Z is equal to 1, this is Z equal to 0. If I take Z equal to 2, then the area under the curve will be more increased, right? Okay, it is somewhere around 98%. Let us suppose I'm taking Z equal to -1. Now, the best part of normal distribution curve is it is having the exact mirror image. It is having the exact mirror. If I taking Z equal to -1, it is somewhere around here. Z is equal to -1 will be somewhere around here. Okay. And it is being observed that if I want to calculate the probability of Z is equal to -1, that is simply 1 minus probability of Z equal to 1, that is exactly 16%. If I'm taking Z equal to 1 as 84. That simply means you don't have to remember the entire set of values. If I want to calculate probability of Z equal to -1, that is nothing but the complementary of this, that is 16%. If I want to calculate Z equal to -2, that is exactly or approximately equal to 2%. So this way you can easily able to calculate the probability of completing this project only by knowing the standard normal variable. Now let us come back to this particular example and let us calculate what is the completion time or minimum time to complete the project, and then we'll be taking some examples where we'll be calculating the project completion probability by having some schedule time. Okay, so let us draw the network diagram by only seeing this table. Can we draw the network diagram? Okay, so let me now remove this. Now let us try to draw the network diagram over here only, and you have to tell me what is the critical path. Okay, so this is 1 2 1 3 1 4. Okay, so we are having 1 2 1 3 1 4, 1 2 1 3 1 4, then we are having 2 5 3 5, 2 5 3 5. Let's do 1. 2 to 5 and 3 to 5. Then we're having 4 to 6 and 5 to 6. Yes. Are we having something like this network diagram? Okay, let us try to write the time. 1, 2 is 4, 1, 2 is 2, 1, 3 is 4, 1, 4 is 3, 2, 5 is 1, 3, 5 is 6, 4, 6 is 5, and 5, 6 is 7. Okay, clear? So by this way we have completed our network diagram. Yes, anyone having any doubt that how we are? Okay, so Faninder has also calculated what is the critical path and the minimum time to complete the project. Very good. So this is 0, this is 4, this is 4 plus 6 is 10, this is 2, 2 plus 3 is 2 plus 1 is 3, this is 3, this is 10, 10 plus 17, 17. Yes. So are we having 1, 3, 5, 6? 1, 3, 5, 6 is the critical path. Please do check. Yes, very good, Abhishek. 17 is the completion time. That means capital TE we have calculated, that is equal to 17. Okay, that means out of all the different activities, only 1, 3, 3, 5 and 5, 6 is the critical activity. Right? That means there should not be any delay in these 3 different activities, and we always need to represent the critical activities by double arrows. Important for ESC conventional. GATE mein to chalega because they are not checking how you are calculating. Okay. Right. Now, if I want to calculate what is the standard deviation of this particular project, can you tell me what will be the standard deviation of the project? So in order to calculate the standard deviation of the project, we have to take the variance. We have to calculate the variance or the standard deviation of only the critical activities. So only we are having these 3 critical activities. So try to calculate the variance or the standard deviation. Let's calculate the standard deviation. That is equal to TP minus TO divided by 6. Okay. So this is 7 minus 1 by 6. That is 6 by 6 is 1. Right. This is 14 minus 2, that is 12, 12 by 6 is 2, and 15 minus 3, that is 12, 12 by 6 is 2. So we are getting 1, 2, 2, 1, 3, 3. 1 second. 1, 2, 2. So this is 1 square plus 2 square plus 2 square. This is 4 plus 4, 8 plus 1, 9. So root of 9, that is equal to 3. Exactly. We are getting the standard deviation of the complete project is equal to 3 days. The estimated time of completion that we are getting is, how much we are getting? That is 17 days. We are getting that to be 17 days. Okay, fine. So can you tell me, if the schedule time is 17 days, what is the probability of completing the project in 17 days? Anyone? First question that you can expect. What is the probability of completing this project in 17 days? 50%. Sir, Z is equal to TS minus TE by sigma. Place it, you are getting Z equal to 0, that is 50%. Answer is 50%. If they're asking you what is the probability of completing the activity in 20 days, of completing the project in 20 days, anyone? What is the probability of completing this project in 20 days? Just you only have to place in this particular formulation, right? Then you can calculate. Yes. Z is equal to 20 minus 17 by 3, that is equal to 1, that is 84%. Okay, so this way you can calculate what is the probability of completing the project in the different time estimates. Okay, Is this clear? Is this clear? Yes. Perfect. Very easy to understand. Okay, this completes your PERT analysis. This completes your PERT analysis. In PERT analysis, we are having only this much. Okay, now let's talk about the next one, that is critical path method, which we got as CPM. Now in CPM, we know that every activity will be having an exact completion. We won't be having any this one your different time estimates. Okay, we won't be having any different time estimates. We will only having one exact completion time of the different activities. So what's the difference between PERT and CPM? What is the analysis is different? If I say in PERT analysis, the only difference that we are having is the calculation of the time estimates. After that, once you are doing the analysis of the PERT, your critical path is entirely same. Okay. In this case, the main application of using the critical path method is to identify the critical activities and try to crash them in order to optimize our project completion. Okay, here the crashing will be the primary objective in critical path. In PERT analysis, the crashing is nowhere being discussed. The reason being, there we are talking about the probabilistic term. There we are not sure that the project will be completed in 15 days or 16 days or 17 days. Here we know the project will be completed in 17 days. But if I want to complete the project in 15 days, what should be my next step? That is the objective of using the critical path. Okay, fine. Is this clear? So here also, if I talk about critical path, there are two ways to identify the critical pathway. Okay, basically it's the same only which we are discussed, identifying the critical path, same only, but the conventional way is we have to go for forward pass computation, right? We have to go for forward pass computation, and then we have to go for the backward pass computation. Right. What is forward pass and backward pass computation? Let us try to understand. I'm taking the same example. Let's suppose this is activity 1. Sorry, event 1, event 2, event 3. Right. Then we are having event number 4. Then this one. We are having A, B, C, and D. Right. It was 2, 5, 6, and 5. Okay, I'm taking almost same set of examples so that we can understand what is the major difference between these two, right? Okay, so this is 0. Now, what is forward pass? Forward pass is basically whenever we are going with in the forward direction from the start to the end, we always have to take the highest possible values. I think we are already doing that only. Okay, so in order to reach from 0 to in order to reach event number 2, there is only one pathway. So 0 plus 2 is 2. 2 plus 5 is 7. Okay, right? Now if I want to go from this pathway, we'll be having 6. So if whenever we are going in the forward direction, we always take the maximum value in the forward. Okay, in the forward direction, in the forward pass, we take the maximum value in the front direction, which we call it as the earliest start time and the earliest finish time. Let's say there's an activity I, there's an event I and event J. There's an activity A, there's an estimation time. So EI, EJ. What is EI and EJ? EJ is basically your early finish time, EI is the early start time, right? And EJ will be equal to the maximum of all EI plus TIJ value. What is the meaning of this? Now to reach node number 3, there are two pathways. I can go from A, B, and we can go from directly from C. Now whenever I'm going from A, B, I'm getting the value to be 7. When I'm going from C, I'm getting 6. I have to take the maximum force. So I'll be selecting 7 as the final number. Okay, so that is your forward pass, right? Okay, so 7 plus 5 is 12. 7 plus 5 is 12, right? Now this is we called as forward pass. Now we have to go for backward pass. What is backward pass? Let's say this is Li and this is Lj. We start from the end. So 12 minus 5 is 7. 7 minus 5 is 2. 2 minus 2 is 0. 7 minus 6 is 1. So whenever I am going with the backward pass, I have to take the minimum of all Ej minus Tij. Okay, that means whenever I'm reaching the backward direction, I have only need to select the minimum most value. Like if I have to talk about the node number 1, there are two pathways to reach node number. Either we can go from B to A, or I can directly go from C. Right? If I'm going from C, I'm getting the value to be 1. If I'm going from B to A, I'm getting the value to be 0. So always need to take the minimum value in the backward pass computation. Okay. Okay, fine. So in the forward pass, we have to take the maximum value. In the backward pass, we have to take the minimum value. So basically, it is the same thing which we have discussed. Now it's slightly in a advanced way. In a, we can say in conventional, we need to proceed like this: the forward pass and the backward pass, right? So what is the major advantage of using this forward and backward pass? The major advantage is we can calculate we can identify or understand the concept of float. Okay, we'll be discussing what is float in the later on stages. Float or slack. Okay, but before that you need to understand what is the meaning of backward and forward pass computation. I hope so now this is clear. In the forward pass, we have to take the maximum of all the values. In the backward pass computation, we have to take the minimum of all the values. All clear? Right? Now let us try to understand the concept of crashing that we were discussing. Like some students are having doubts, or what is the meaning of this word crashing? Now, what is the meaning of this word crashing? Let us try to understand, then we'll be able to have a better understanding. Okay. Now, let us talk about the word crashing. Let us suppose I'm having activity A, B, C, and D. There are 4 activities. Among this, only A and D are the critical activities. I'm taking a rough example. There are total 4 activities in the entire project. And among this, A and D are the critical activities, B and C are non-critical activities. So I'm taking as non-circle. Okay, fine. Now, and it is taking 10 days. The particular project is taking 10 days to complete. If I want to complete this project in 9 days, if I want to complete the project in 9 days, so definitely I have to allocate more resources. Let us suppose activity A is individually taking, let's suppose 3 days to complete. Okay. So if I want to complete activity A in 2 days or even in 1 day, I have to allocate more resources. More resources means I have to hire more persons. I have to purchase more machines. I have to have more raw materials. Yes. So by investing more resources, I can crash my activity so that my entire project is being crashed. Is this clear? Right? Normally it is taking 10 days. Normally the project is taking 10 days to complete. Now if I want to complete this project in 9 days, I have to crash down an activity so that my entire project is being crashed down. Right? Now my question is, which activity will be preferring to crash? A critical activity or a non-critical activity? Which activity we will be preferring to crash? Yes, anyone? A critical or a non-critical? Why critical? Yes, Abhi is saying critical. Why critical? If I'm taking the same example, let us suppose, what was that example? A. 1, 2. Why critical? My question is, why I have to go for critical? Let me draw it. Critical is correct, but my question is, why only critical? Why non-critical? Exactly. Okay, let us suppose this is the critical pathway. A, B, and D is a critical path. Exactly. Why only critical path? Because if I'm saying this is 2, this is 5, this is 5, this is 12, this is 5. Okay. If you are, let us suppose if you are decreasing uh, activity B by 1 day, that means I'm decreasing by 1 day, I'm changing from 5 to 4. What will happen? My project will be completed by 11 days. Yes, can we say like this? If I'm changing the duration of activity B from 5 to 4, then what is happening? My project will be decreased by 1 day, and that is the reason we are crashing critical activity. Let us suppose if I'm crashing activity C from 5 to 4, what will happen? Is my project is decreasing from 12 to 1? If I try to crash activity C from 5 to 4 and keeping rest all same, is my project duration is being decreased from 12 to 1? Answer is no. You can cross check. 0, 0 plus 2, 2 plus 5 is 7, this is 4, so I'll be taking the longest time, taking 5 plus 7, 7 plus 5 is still 12. I'm completing the activity in 12 days. I'm allocating more resources to activity C which is not required. That means I was not having that knowledge to allocate the resources. I was not having the conceptual clarity that where I have to reallocate the resources, right? So you have to reallocate the resources only to the critical activities, because that will be deciding the project completion time. By altering the critical activities time duration, my project duration will be altered. Clear? That is the reason whenever I'm talking about crashing an activity, I will be selecting a critical activity only. Non-critical activity will not be touched. Clear? Hai? Understood the meaning of crashing? Right? So in order to, let us suppose if I want to decrease the project to be completed in 11 days, I'll be selecting either A, B or D. I'll be crashing by 1 day. Okay, let us suppose if I'm taking activity B and changing from 5 to 4, now I am able to crash my project by 1 day from 12 to 11. From 12 to 11, I can easily now can cross check. 2 plus 4 is 6, 6 plus 5 is 11. Okay, clear? Fine. Done everyone? Yes. Neeraj, clear? By crashing activity B by 1 day, I'm changing it to 4. Hai? Perfect. Chalo, perfect. Now, in crashing, because why we are doing this crashing? Anyone having any idea? Why we are doing this crashing? That's the best part. Even though we are crashing, my critical path is still remaining the same. That is not our intention. Intention is the completion of the project. Initially, we were completing in 12 days. Now we are completing the project in 11 days. So definitely that is our best part. Okay. Now, what is the basic meaning of this word crashing? I can do crashing n number of times, but we are not doing like this. Crashing means to optimize the cost of the project at the expense of reducing the time. For knowing it better way, let us try to understand. In crashing or in any project, there are two different costs that we always be included. One is the direct cost and second is the indirect cost. Indirect cost. Achha, what's the major difference between direct and indirect? Direct cost is basically, it is that cost that is being directly associated in completing the project. That includes, we can say, the machinery cost, that includes the raw material cost, okay, that includes include your expenses which is required to complete a project, right? What is an indirect cost? Indirect cost is something which is not directly related, but indirectly it is having slight impact on the completion of the project, not directly related. Okay, Indirect cost is something like whenever we are talking about the allowances, okay, whenever we are talking about allowances, so that particular cost is called as the indirect cost, which is not directly associated with the completion of the project. Let us take one example. If I talk about direct cost, it is a cost that is directly involved in the completion of an activity, that is directly been included, right? But if I talk about indirect cost, indirect cost is not directly been involved, but it is required for the timely or the safe completion. Let us take an example. You are doing the welding operation. Exactly. Let us suppose we are doing the welding operation. In the welding operation, the machine, the payment of the welder, that is being included, that is directly related with the direct cost. Indirect cost will be somewhere like the daily expenses, the food cost, the daily allowances that we are getting. Okay, so that is not we can say the cleanliness, the cost that is required to clean that floor area. Okay, so this is not a compulsory, but that is, we can say, that is an essential element to complete a project for the timely and the safe completion. That is called as the indirect cost. Okay, fine, very good. It includes your material cost, the labor cost, the cost of the machine, the equipment, that is basically included in the direct cost. To understand it more appropriately, let us understand from the graphical perspective. If I say the direct cost, if I talk about the direct cost, okay, let us suppose on the y-axis I am taking cost, and on the x-axis I am taking time. If I am completing activity, if I am completing an activity in normal time, so it will be taking a lesser cost. So we are having, let us suppose this is your normal time Tn, and corresponding to this I am having a normal cost, that is Cn. Now if I try to crash down, let's say that I'm taking about or talking about an activity A, it is being completing in 10 days, right? And it is taking, let's suppose, 100 rupees. It is taking rupees 100. Now if I want to crash down this activity by 8 days, that means I'm completing in 4 days. Let's suppose I'm crashing by 6 days. So I'm completing in 4 days. So definitely the now cost required to complete this activity will be more than 100 or less than 100. Yes. If I am completing this activity A, normally it is taking 10 days to complete and it is taking 100 rupees to complete this activity A. But now if I try to complete this activity A in 4 days, so will I be taking more than 100 or less than 100? Quickly. Will it be taking more than 100 or less than 100? Sir, obviously, now I have to, let us suppose initially there was only one person and one machine which was doing this operation, right? So now I have to hire, more persons, right? More machines I have to purchase so that I can complete this activity A in 4 days. So definitely it will be taking more than that of the normal. So let's say this is your point. Now there is one approximation that we are doing is, normally in reality this particular will be a curve. In reality this, if I try to join, it will be somewhere like curve. But we are taking a linear approximation. We are saying that okay, it is almost having a straight line. Almost we are having a straight line. Right? So can we calculate the slope of this curve? So it's quite easy. The slope of this curve will be equal to the crash cost minus the normal cost divided by the normal time minus the crash time. And believe me, this question was asked, this formulation was asked in GATE examination for 1 marks. I don't know why they have asked. It's a very easy question. This will be called as the cost time slope. The cost time slope. Okay. What is the significance of this? Let us try to understand what is the significance of this cost time slope. Then we'll be able to have a better understanding of this direct cost. Okay, I'm taking that example. Let us suppose normally it is taking, I'm taking the same value. Normally it is taking 10 days to complete, and the normal cost is rupees 100. Okay, it is taking rupees 100. Now, if I try to complete this in 4 days, right, it is taking 6, na? 6. Let us take it as 160. हाँ, ठीक है. Okay, fine, right? So can you tell me what will be the cost time slope? What will be the cost time slope? If you are completing this in 10 days, it is taking 100 rupees. If you are completing in 4 days, it is taking 160 rupees. So the cost time slope will be the cost time slope will be equal to 160 minus 100 divided by 10 minus 4, that is equal to 10. What's the meaning of this? Anyone who can tell me? What's the meaning of this? The meaning of this is, if you are crashing this activity A by 1 day, it gonna cost me additional 10 rupees. It is gonna cost me additional 10 rupees. Okay. Let us suppose if I say, if I'm completing this activity in 9 days, so can you tell me what will be the total direct cost? If I'm completing this in 9 days, can you tell me what will be the total direct cost? Anyone? The total direct cost will be 100, will always be there, plus per day. This is per day, right? So 1 into 10. So it will be costing me 110 rupees. It will be costing me 110 rupees because I am crashing this activity from 10 to 9. Normally it is taking 10 days. Normally it is taking 10 days. Now I'm completing this activity in 9 days. So definitely it is gonna cost me 110 rupees. Is this clear? Right? Okay, can you tell me, if I'm completing in 7 days, what will be the direct cost? If I'm completing this in 7 days, what will be the new total direct cost? Let us see who's gonna give me the answer. Anyone? Very good fun in that. It will be 130 rupees. 100 plus, what is the cost time slope? That is 10. We are crashing by 3 days. So this will be 130 rupees. 130. 130. Not 170 abhi. Very good. Very good. It will be 130. Acha, use the same formulation. Tell me, if you are completing in 4 days, what will be the direct cost? If you are completing in 4 days, normally it is 10 days. So 4 days means 6 days of crashing. So 100 plus 6 into 10, what we are getting? 160, right? And are we having the same crash cost which is given in the question? In 4 days, it must be taking 160 and I'm getting the same value. Is this clear? So cost time slope is gonna help me to calculate the direct cost, because the more you are able to crash the activity, the more the cost will be increasing. Is this clear, everyone? Understood the concept of direct cost? Hai na? No problem. Because many students do have this doubt, sir, crashing is very difficult. It is not at all difficult, it's very easy. Okay, now let us talk about the indirect cost. Now let us talk about the indirect cost. Indirect cost. Okay, what is indirect cost? Now just now we have seen this is an essential one, but not the we can say not the essential component to complete an activity. It is not mandatory, but it is required for the timely and the safely completion to complete an activity. Like the daily allowances. Okay, let us suppose in total I require rupees 150 is required per day. This is the indirect cost. Okay, every day it is gonna cost me rupees 150 on daily basis if I am uh, taking the indirect cost. It includes all the allowances, all the miscellaneous charges, the taxes, everything. Okay, fine. Now, if I talk about the same example, I was completing activity A in 10 days, right? So can I say the total indirect cost will be how much? Sir, 150 into 10, that is rupees 1500. Yes, right. So if you are crashing this activity A by 1 day, that means if you are completing in 9 days, okay, or let us suppose if you are completing in 8 days, then your new indirect cost will be equal to 150 into 8. Yes, 150 into 8, that will be simply 1200 rupees. Yes, 1200. Okay, that means by crashing 2 days, can you tell me how much amount we are able to save from indirect cost perspective? By crashing, by that means by reducing from 10 to 8 days, how much I have saved? Sir, I have saved, if I try to do difference, it is I have saved rupees 300 is being saved. Yes, let us, because while doing crashing, whenever we are doing crashing, direct cost is always gonna increase. Okay, if you are doing crashing, the direct cost is always gonna increase and indirect cost is always gonna decrease. So in order to optimize, because there is one concept of total cost. What is total cost? That is equal to the summation of direct cost plus indirect cost. Okay, total cost is equal to the summation of direct plus indirect, right? So one parameter is increasing, second parameter is decreasing. So let us suppose after crashing, overall the total cost, if it is decreasing, so that is in our benefit. If I say the total cost is equal to direct plus indirect. Okay, so if I try to crash, let us suppose I am crashing. After crashing, your direct cost is going to decrease and indirect cost is being increased. Oh, sorry, opposite way. The direct cost is being increased and indirect cost is being decreased, right? So let us suppose after crashing, the total cost, because the decrement of the total cost was more, so total cost is being decreased. So is that a beneficial way? Like if I say, if I'm completing in 10 days, the total cost is rupees 1000, let's say 700. Let us suppose I'm taking a rough example. After crashing, after whenever completing in 9 days, the total cost is equal to 1600. So that is much more beneficial. Sorry guys, that is much more beneficial. That means I'm completing the project, I'm completing in 9 days and my total cost is also being decreased. That is a beneficial, double benefit. Okay, that is the reason we are doing the crashing in a CPM analysis. That is the reason we are doing crashing in the critical path method. That's the main objective of using the critical path. Okay, good morning, good morning. Understood? Fine. So now let's do one example so as to understand how we can do the crashing operation in this particular question. Okay, question is like this. Normally if you're getting question, it will be coming like this. The following table gives the data on the normal time, normal cost, crash time and crash cost to reduce the project by 2 days. How much additional cost I have to how cost reduce the project by 2 days? How much cost I have to add in order to reduce a project by 2 days? That is a question. Now, whenever you're getting question like this, first of all, you have to draw the network diagram. Okay, fine. And network, once you are drawing the network diagram, you have to use a normal time, right? So on the left hand side, you are able to see there are different activities 1, 2, 1, 3, 2, 4, 2, 5, 3, 4 and 4, 5. Try to draw the network diagram. Let's try to draw the network diagram over here only. 1, 3, 1, 2, 2, 4, 4, 5, 2, 4, 4, 5 and 3, 4, something like this. Enough, everyone? So can you tell me what will be the critical path? Because initially we won't be doing any crashing. Only we have to draw the network diagram and identify the critical path. Okay. So 1, 2 is 8. 1, 3 is 4. 2, 4 is 2. 2, 5 is 10. Achha, this one 2, 5 also. 2, 4 and 4, 5. Two, 4, 2, 5, 4, 5 and 3, 4. Yes. Now okay. 1, 2, 1, 3, 2, 4, 2, 5, 3, 4, 4, 5. 1, 2, 1, 3, 2, 4 is 2. 3, 4 is 5. And 4, 5 is 3. And 2, 5 is 10. Chalo. 1, 2, 5. Quickly. What is the critical path you are getting? Anyone who has identified? What is the critical path? Yes, yes. 1, 2, 5. Okay. 1, 2, 5. Okay, 18. 1, 2, 5, 18. Perfect. Let's try to identify the critical path. 0, this is 4, this is 8, this is 9 plus 5, 10, this is 13, 18. So I think we are getting 1, 2, 5. Okay. 1, 2, 5 is the critical path. 1, 2, 5 and capital D is equal to 18 is the critical path, right? 18 days. Very good. Perfect. So we only need to crash the critical activities that already we have seen, because if you are crashing critical activities, then only my project will be altered. If you are crashing non-critical activities, it won't be helping out in any way. Okay, so you always need to crash at the critical activities only, right? So now among all the different activities, only 1, 2 and 2, 5 are the critical activities. Rest all are the non-critical activities. And we always need to crash activities which are critical activities. Now among 1, 2 and 2, 5, I need to identify which has to be crashed. So we have to see, we have to identify the cost slope. We have to identify the cost slope. What is cost slope? Cost slope already we have seen. Cost slope, that is equal to your crash cost minus normal cost minus divided by normal time minus crash time. So let's identify 200 minus 100 is 100. 100 by 2 is 50. This is 400 minus 100 is 300. 300 by this is 60. Yes. Please do see, are we having 50 and 60 are the two different, exactly. But no need to calculate the entire different cost law, because here we have to identify only we have to crash by 2 days. Okay, fine. Now among 1, 2 and 2, 5, if I'm crashing activity 1, 2 by 1 day, it is gonna cost me 50 rupees. Okay, and if I'm crashing activity 2, 5 by 1 day, it is gonna cost me 60 rupees. So my question is, which activity are we gonna crash among 1, 2 and 2, 5? Both, if you are crashing activity 2, 5 by 1 day, it's gonna cost me 60, and if I'm crashing activity 1, 2 by 1 day, it is gonna cost me 50 rupees. So definitely I'll be crashing that activity which is having a least cost law. Very good, Abhishek. Dekho, I'm having this pen, right? There is Amazon and Flipkart. If I'm purchasing from Amazon, it is gonna cost me 50 rupees. If I'm purchasing from Flipkart, it will cost me 60 rupees. Same product. So it is better now. I'll be purchasing from Amazon because it is from the same product. If I'm getting from 50 rupees, so it is better only. So same logic we can apply over here. If I'm crashing activity 1, 2 by 1 day, it is gonna cost me 50 rupees. So I'll be selecting activity 1, 2. Okay. So if I crash activity 1, 2 by 1 day, so tell me, is my project is gonna decrease by 1 day? Yes, sir. It will be decreased from 18 to 70. But now we have to check one thing. Next step is what is the new critical path? Okay, let me draw this diagram over here also. 1, 3, 4, 5, 1, 2, 2, 4 and 2, 5. Okay, so we are having this as 8, this is 4, this is 5, this is 3, this is 10, this is 2, this is 8. Okay, fine, and this was the critical path, I think. Now what I'm doing is I am crashing activity 1, 2 by 1 day, right? So now it is being decreased to 70. Now tell me, what is the new critical path? What is the new critical path? Quickly. Now I have to identify by taking activity 1 to duration, by taking activity 1 to duration from 8 to 7, what is the new critical path? Is it still the same? Let's try to identify. This is 0 plus 4, 4 plus 5 is 9, 7, 7 plus 2 is still 9, 9 plus 3 is 12. We are having still same, still we are having the same, exactly, right? So now you have to tell me among 1, 2 and 2, 5, it is having 50 and this is 60. Which activity will be selecting differently? Again, I'll be selecting activity 1, 2. Again, I'll be selecting activity 1, 2 and be crashing by 1 more day. So if I crash activity 1, 2 by 2 days, I can crash the project completion time from 18 days to 16 days. Yes or no? If I'm able to crash activity 1, 2 by 2 days, I'm able to crash project from 8, but you don't have to always crash directly by 2 days. You have to always check after crashing by 1 day, you have to cross check additionally. Okay, fine. So now they are asking you what is the cost to reduce the project duration by 2 days. So now if I want to crash this by 2 days, so 50 rupees for 1 day, so 50 into 2, so it is gonna cost me rupees 100. Answer is option A, and you have to mark it and you have to proceed. And in the gate examination, you usually will be getting not the lengthy questions in the gate examinations, slight conceptual based problem will be coming. Okay, fine. So additional, how much you have to pay? That is rupees 100. Exactly. So option A is a correct answer. Understood? Crashing is done. Clear? Okay. So now let's talk about the concept of float. Sir, what about 2.5? It will be saying that that way only, because it is taking 60 rupees. It's same thing. The same product is gonna cost me 50 and 60 rupees. So it is better now. I'll be purchasing in 50 rupees. The same product I'm getting. It's not like this. The product is being having a more quality if you're paying 60. No, it's the same thing, right? Okay, so definitely I'll be always selecting the that activity, that critical activity which is having the minimum cost time slope. Clear? Because even if you're crashing activity 2.5 by 1 day, the project will be decreased by 1 day, but it's gonna cost me 60 rupees. So I won't be preferring that. If I'm having 50 rupees with me per day crash course, I'll be selecting that only. Okay. Let us suppose in future, if you're having any question where you're having the cost time slopes to be same, then you can select any activity. There's no any specific criteria for that. Okay. If Amazon and Flipkart is showing me the same product, same price, so it's better you can take any activity, we can say platform. It's all good, right? Okay, chalo. So now let's talk about the next very interesting and important concept, that is we call it as float. Okay, normally direct straight away question is being coming from this topic also. Not frequently, but if they're asking, the question is very easy to understand. Now, what is a float? Yes, anyone who can tell me what is float, or sometimes we can call it as slack also. Basically, float and slack both are having the same meaning, right? Float we are using in CPM, that is critical path analysis, and slack we are using in PERT analysis, but the basic understanding or basic meaning is entirely same. Now my question is, what is float? Float is means that how much duration an activity can be delayed so that my project completion time is not being changed. Float of an activity basically means that how much my activity can be delayed so that my project completion time is not being altered. Let us take one example. 1, 2, 3, 4 and 5. I'm taking one example like this, and you gonna first of all tell me what is a critical path. I'm taking random values. Okay, I've taken a random value, so you have to tell me what is a critical path. First step is identify the critical path quickly. I think it won't be taking much time to identify critical path now, because now we have seen at least 2-3 examples, minimum 2-3 examples to identify the critical path. Quickly, I've taken a random values, so you guys gonna help me out. Exactly, very good, shares. 2 plus 1 is 3, this is 4, 2 plus 6 is 8, 4 plus 4 is 8, 5 is 13. Are we getting 2 critical paths? Yes. Okay. The maximum time, so we're having this one. The values were all random, right? Not luckily we are getting 2. So we're having 2 critical paths in this particular example. We are having 1, 2, 4, 5 and 1, 3, 4, 5 as a critical path. Okay, we are having 1, 2, 4, 5 and 1, 3, 4, 5 as a critical paths that we are getting this particular question. Okay, right? Fine. 1, 2, 4, 5 and 1, 3, 4, 5 are the 3 critical paths. Right? Now, tell me one thing. If I delay activity D. Okay. If I delay activity D by 1 day, is my project completion time is gonna change? Quickly. If I'm delaying activity D, because we're having almost all the activities except D, we're having the critical activity. Let us try to change the value so that I will be getting only one critical path. Okay, let's do one thing. Let us try to change this value from 6 to let us take it as 3. Now, okay. So we are having now one critical path. 1, 3, 4, 5. So that we can understand. Right. Now let's try to understand. If I try to increase the duration of activity C from 3 to 4, is my project duration changing from 13 to 14? Tell me. Answer is a big no, because activity C is not a critical activity, and if I'm delaying by 1 day, my project completion time won't be altered. Okay, fine. So let us do one thing. Let us do the forward and backward pass computation to have a better analysis. Let us do one thing. If I try to take the backward pass, so this is 13. 13 plus 5 is 8. 18. 8 plus 4 is 4. 4 minus 4 is 0. 8 minus 3 is we can say 5, and 4 minus 1 is 3. So in the backward pass, we always take the minimum value. So I'll be taking 3, right? 3 minus 2 is 1. So this. So if I try to see every activity, we have done the forward and the backward pass, right? Okay. Now, if I try to take any activity ij, let us try to understand in a general perspective. That is ei, ej, li, lj. Okay. Lj is basically, what is this particular meaning of this? This is basically having, let's say for activity E, I'm taking activity E. Okay, I'm taking activity E, which is 3 to 4. We're having 8, 8, 4, 4. So this values basically means it is the last day that must be completed. That before this, the activity must be completed. Now, if I here to visualize, this is the minimum day that that activity must be completed. This is the maximum possible day the activity must be completed. Both are same. Why? Because there is no provision of any delaying. The minimum and the maximum values are both same. That is the reason activity E is a critical path. You can clearly see activity is a critical path. Okay. But if I try to see activity C, or if I take activity A, if I'm taking activity A, it is going from 1 to 2. This is 2, this is 3, this is 0, this is 0. So if I try to visualize, if you are starting from day 0, the minimum time that must be completed is in 2 days. If I want to delay by 1 day also, no problem. The last day to complete activity is 3 days. I can easily delay this activity by 3 days. Okay, fine. Is this clear? Understood? So activity A, because this is a provision of delaying without altering the project completion, though I can say activity A is a non-critical activity. So in order to calculate the float of any activities, there are different classifications or category that we have to understand. So under float, there are 3 categories or 3 different types of floats. There are 3 types of floats that we need to understand. First one is the total float. We are having total float, which will be denoting it as TF. Then we are having the free float, that we are denoting as FF. The third one is the independent float, that we are denoting it as IF. Okay, fine. There is one more, we call it as interference. In one of the ESC paper, I think last year or last year, they have asked about what is interference float. That is nothing but the difference between total float and free float. Okay, fine. Let us try to understand what is the meaning of total float, free float, and independent float. Let us talk about the first one, that is total float. What is total float? It is the maximum time that is we can delay an activity without changing the project completion time. Okay, the total float is the difference between the maximum time available and the actual time required for the completion of an activity. Let us take an example. If I say there's an activity A which is taking, let us suppose, 3 days to complete, and it is going from IJ. Let's say this is EI, LI, EJ, and LJ. Let's say this value is 2, this is 3, this is 5, and this is 8. Let us suppose I'm taking a rough example. So total float can be calculated as LJ minus EI minus TIJ. That means I can say 8 minus 2 minus 3, that is equal to 3. What's the meaning of this? What is the meaning of this particular number? This number states that I can delay activity A by 3 days, and if I'm delaying by 3 more days, my project still will not be having any changes. That is the basic meaning of total float. Okay, that is the maximum time that is available with me to the actual time required for the completion of the project. That is basically the meaning of the total float. Right? So let us take one example. Let us suppose I'm having 1, 2, 3, and 4. Okay, I'm taking A, B, C, and D. Let's say this is 3, this is 5, this is 2, and this is 2. Right? Let us try to identify the critical paths. We're having 0, this is 3, 3 plus 5 is 8, 8 plus 2 is 10, 3 plus 2 is 5, this is 10, this is 8, this is 3, this is 0. Okay, the critical path is A, B, and C. A, B, C, the critical path. 1, 2, 1, 2, 3, 4 is a critical path, right? Okay, 1, 2, 3, 4 is the critical path, right? Now, if I want to take activity D, is going from 2 to 4, taking 2 duration, this is 3, this is 3, this is 10, this is 10, right? So this is your EI, this is your LI, this is your LI, EJ, and this is your LJ. So what will be total float? This is your TIJ, the duration of an activity. Total float is equal to LJ. We have to go for cross calculation. LJ minus EI minus TIJ. Okay. If we try to place it, this will be 10 minus 3 minus 2, that is equal to 5. That means I can delay activity D by 5 more days and my project completion time will still be 10. You can cross check. You can cross check over here. If I'm changing this activity from 2 to, let us suppose I'm adding plus 4, that is 6. Okay, if I'm changing from 2 to 6, that means I'm adding plus 4. So is my activity duration changing from 10 to 14? Please check. If I'm changing this activity duration from D equal to 2 to D equal to 6, still it is being completed in 10 days, right? Okay, let us suppose I'm adding plus 5. 2 plus 5, that is 7. Okay, so still if I'm adding plus 5, you can see still it is being completed in 10 days. Still my project completion time is being unaltered. But as soon as I'm adding plus 5 to D, now D is also have become a critical path, because 3 plus 7, 10. Now D is also under the critical path. Now if you add further plus 1, that means if you're adding by plus 6 in total, the project duration will be altered by +1 days. Is this clear? Okay, fine. So total float is basically helping us to identify by how much duration a project must or can be delayed so that my project completion time is not being altered. Let us take activity B also. Let us take an example of activity B. Even though activity B is a critical path, it should be having a total float of 0, but let us cross check. This is duration is 5, 3, 3, 8, 8. So total float will be equal to, let me use it over here. Acha, it is not visible kya? 1 second guys. Total float will be equal to 8 minus 3 minus 5, that is equal to 0. That means there is no provision of delaying an activity, and that is the reason it is a critical activity. That is the reason activity B is a critical activity. Okay, right? That is the reason activity B is a critical activity, and that is the meaning of the concept of float or total float. Clear? Understood? Anyone having any doubt in this? The concept of total float? Okay, now let us talk about the second definition, second perspective, that is free float, that is FF. What is a free float? It means that by how much duration an activity can be delayed so that its subsequent activities early start time is not being altered. Okay, that means if I say by how much duration activity B can be delayed so that my subsequent activity early start time is not being altered. That is the meaning of the free float. Let us take one example. Let us take one example. 1, 2, 3, 4, and 5. Let's say this is A2, B3, C2, D2, E4. Or let me take it as 4, 5, 6, 8, 10. Chalo, tell me what is the critical path, and then we'll be calculating what is the free float. Zero, 2, 2 plus 3 is 5, 5 plus 2 is 7, 7 plus 4 is 11, it is 12. Okay, are we getting AD as a critical path? Yes. 1, 2, 5 or AD as a critical pathway. Okay, so how we can calculate a free float? How we can calculate the free float? Let's say we are having any activity whose duration is Tij. This is early start time EI, Li is the latest start time, Ej is the early finish time, and Lj is the latest finish time, right? So free float can be calculated as the Ej minus EI. 1 second. Ej minus EI minus Dij. That means you have to subtract the upper values. A way to remember, in total float we were subtracting the cross value, in free float we have to subtract the upper values. Okay, now let us take one example. Now for that we have to go for forward and backward pass computation. This is 12, 12 plus 4 is 8, 8 plus, minus 2 is 6, 6 minus 3 is 3, 12 minus 10 is 2, 0. Let us calculate what is the free float of activity B. Can we calculate what is the free float of activity B? Let's calculate activity B free float. Taking 3 na, 2, 3, 2, 2, 5, 6, 2, 2, 5, 6. Okay, First of all, tell me what is the total float, and then we have to tell me what is the free float. Quickly, what is the total float and what is the free float? What is the total float and what? And I'll be taking the difference of that also. I'll be taking the difference of. Okay, total float is 6 minus 2 minus 3, that is equal to 1. Free float 5 minus 2 minus 3, that is equal to 0. Now what is the meaning of this is, now coming back to this, activity B can be delayed by only 1 day so that my project completion time is not being delayed. That is the concept of total float. Okay, what is free float? If I try to delay activity B by 1 day, let's say if I make it as 4, so my early start time of activity C will be changed to 6. You can cross check. If I make it 4, so it will be 2 plus 4 is 6. It will be changed to 6. So this must not be changed. Okay. So there is no provision of altering or delaying the completion time of activity B, because if you are delaying by 1 day, my early start time of activity C is being altered. It's being changed. Is this clear? Okay. Fine. Right? So that is the concept of free float. Now let's go with the last one, that is independent float, that is denoted as IF. Okay. Independent float is basically by how much duration an activity can be delayed such that its preceding or previous latest finish time is not being altered. Okay. That means when all the preceding activities are completed as late as possible, all the succeeding activities are started as early as possible. Meaning of this is by how much duration an activity can be delayed such that its preceding or previous earliest finish time is not being changed. So I can say that how we can calculate this. This is I to J, this is Tij, this is Ei, Li, Ej or Lj. So the independent float is, we have to take the bottom values, that is Lj minus Li minus Tij. Okay, it is rarely being asked. In the GATE examination, max to max they are going to ask you is in total float, or worst scenario free float. Independent float, I think till date ESC may they are asking you, in GATE examination they are not at all asking. But yes, you need to understand because you never know. If you see HPCL, the industrial weightage has been increased. ISRO, they are not asking industrial question, but they have asked industrial. So we can expect good questions from industrial engineering in the GATE examination. Seeing the trend of the current PSU examination, so we can expect a good question. Not like too many questions, but yes, a standard 4 marks or 5 marks is a standard weightage of industrial engineering. Then in that case, you can expect one question from the PERT CPM. Okay, fine. So we can now calculate the independent float of this. Let's calculate independent float of activity B. So it will be 6 minus 2 minus 3, that is equal to 1. That means I can delay activity B by 1 day. My preceding activity still will be completed in 2 days. Preceding is A, activity's early finish time is 2 only. It will be completed in 2 days only. If I try to change it 4, 6 minus 4, still it is coming out to be 2. Is this clear? Understood? Done? So that is the concept of independent float. So this completes your PERT and CPM. We have discussed in very smooth, very slowly. There is nothing additional we have to take. Okay, fine. So now we'll be entering to the next topic. Fine. So this completes your PERT and CPM. PERT CPM completed. So there are like 6 to 7 topics are there. 6 to 7 topics. We'll be completing each and every one in detail, so that in between only we'll be taking problems so that you are having better understanding. Okay. Fine. So now let's start with the next topic, an interesting and easy, a very small topic, that is break-even analysis. I have seen that in many PSUs they have asked question from break-even analysis, right? And normally in gate examination, if they're gonna ask you, they're gonna ask you only for 1 marks, because this topic is very small and very easy. Okay. Now break-even analysis, I hope so you know about this particular topic, because this is the one of the most easiest and the most smallest topic. Now, where we're using this break-even analysis, it is a tool which a production manager, normally this break-even tool, we call it as in every production plant, we are always coming across this break-even point. Okay. Now, my question is, why this break-even point is so essential? Anyone? What is this break-even point implies to you? This break-even point is giving us an information that how much I need to manufacture so that at least I will be having a zero loss condition. Exactly. Correct, Negi. Break even basically tells us about how much I need to manufacture so that I am at a zero profit, zero loss condition. Okay. Even though I'm not getting any profit, at least I'm not getting any loss also. Any industry, any manufacturing industry, they are always working on this break-even point, and they always set a target much higher than that of break-even point. Exactly. Okay, fine. And it's a very important tool which every production manager is using. Why is using? So that he can forecast how much profit or loss will be incurred in future. Okay, it's a very important tool. It's not like it's there in the syllabus, that is why we're studying. It is being used in different plants, in different production units, where there's a we can analyze the potential profit or loss which is happening in the future. Let us suppose daily basis, if you are manufacturing 10 units per day. Okay, let us suppose there is a production plant and daily we are manufacturing 10 units per day. On that particular ratio, if we are proceeding for the next 1 month, how much profit or how much loss will be incurred? Let us suppose if you are manufacturing 10 units per day and you are getting a loss of some value. So I will try to increase to 20 units per day, and then I'll be analyzing how much profit we are getting. Okay, and this way we are able to analyze how much profit or how much loss will be incurred by understanding the volume of production. So break even is somewhere between somewhere the main objective of using break even is to talk about the optimized sales value, because normally we are using this in sales perspective or in the production perspective. Okay, how much sales is being done or how much production is being done in order to get profit or loss. So break even analysis is a tool which any production manager or any sales executives, they are using in order to understand or forecast what could be the potential profit or loss that will be incurred in future. Okay, fine. Now, before understanding the break-even analysis, there are some terminology that we need to understand. Then we'll be proceeding towards break-even analysis. The first and the foremost is the different types of costs will be there, because ultimately we are talking with respect to the revenue perspective, with respect to the cost. Like, okay, we are not talking about some percentage, we are talking about in exact real value of what will be the total expenditure, what will be the total revenue, and how much profit I can incur. Okay, so under this we have to understand the first one is the fixed cost. Okay, fine. The first one that we need to understand is the fixed cost, because total cost is the total expenditure that we are paying, right? That was in order to produce certain number of units, and it is a sum of fixed and the variable cost. Okay, total cost is nothing but how much you are paying or what is the total expenditure in manufacturing X units of production, right? So total cost is further divided in two categories. One is fixed cost, second is variable cost. Let us understand what is fixed cost. Anyone who can tell me what is fixed cost? A very easy one. What is a fixed cost? Fixed cost is basically, even if you're manufacturing 1 unit, even if you're manufacturing 1000 units in 1 day, I have to pay the same amount of money. That means it is independent of volume of production. It is independent of sales. That is basically we call it as a fixed cost. Like we can say the rent of a machine, building rent, perfect. Okay. Let us suppose you are purchasing a machine on rent basis, on daily rent basis. So even though let us suppose it's on Sunday and the machine is kept stationary, right? It's a Sunday and machine is kept stationary. So definitely is from the person from where you are purchasing that particular machine, he definitely gonna take that per day charges also. Even though if you're not manufacturing anything, still you have to pay its rent. Okay, so that is basically included in the fixed cost. Okay, machine cost, the rent, or your charges, administration cost, which is independent of the, it is basically, in short I can say, it is independent of volume production. Volume of production. Okay, that means if I try to plot a graph between fixed cost and volume of production, it will be having a constant value. Okay, it will be having a constant value. On the other hand, we are having one more cost we call it as variable cost. It is directly proportional to the volume production. Variable cost is directly proportional to the volume of production, right? Volume of production. Okay, so variable costs are those costs which are directly with the level of the output, and definitely the more you are gonna increase the volume production, the more you have to pay. Best example is your raw material cost, electricity bill. If you are running the machine for continuously 1 hour or 2 hours, the electricity bill you have to pay. Okay, the direct fuel, direct labor means basically you are taking the more labors into working, so definitely you have to pay more amount of money as a salary. So raw materials, direct labor, fuel, revenue related to costs such as commission, these are basically coming under the variable cost, and it is directly proportional to the volume production, right? So I can say that the variable cost, that is VC, or we can call it as capital V, variable cost, which is denoted as capital V, that is equal to small v into x, where small v resembles the variable cost per unit for 1 unit, and x is the number of units or volume production, volume of production, right? So I can say the total expenditure or total cost is equal to fixed price plus variable cost. Fixed price plus variable cost. And if I try to plot the total cost, this is fixed price, right? This is variable cost. So in total, I can say this will be the total cost. This portion is the fixed cost. This portion is the variable cost. If you try to add these two, we'll be getting the total cost. Is this clear? Right? This is the total expenditure. That means how much you are paying to manufacture X units. Okay, right? Perfect. Now, once you have done with the total cost that you are paying, now you have to take that how much you are getting, right? Let us suppose you are manufacturing this pen, you will be definitely selling, you will be having one selling price, or you will be having one revenue. And after that only you will be able to calculate the total profit. So if I want to calculate the total sales or revenue, right, that is noted as capital S. So capital S is equal to small s into x, where small s resembles the selling price per unit, and x is the volume production. Here one assumption that we are doing is how much you are manufacturing, that much of amount you are also selling. It's not like this. Let's suppose if you are manufacturing 100 units and there's some defective of 5 units and you are only selling 95. It's not like this. Only one assumption that we have to analyze is how much you are manufacturing, the same it will be you will be selling, right? That is the main we can say assumption. The second assumption that we have to assume is the variable cost and the selling price are having a linear proportional with the volume of production. It's not a hyperbolic, it's not a parabolic, it will be having a linear variation. Okay, so I can say the total sales will be equal to total cost plus profit. Can I say like this? It's basic aptitude related problem. Right? How much you are paying is equal to or minus how much you are spending. The difference of that will be equal to profit. Okay. Let us suppose if total cost is more than that of total sales. What's the meaning of that? If total expenditure is more than that of total revenue, what's the meaning of that? Anyone who can tell me? What would be the state of condition of for that particular firm? If total cost is more than that of total sale, that means we are having a negative profit. Negative profit means ultimately we are talking about losses. Okay, ultimately we are talking about losses. Is this clear? Right? Exactly. Right? Or we can rewrite this equation something like this also. This is F plus V plus profit. Okay. This is a generalized condition. Now, if I want to identify what is a break-even point, what is a break-even point, which we call as BEP. Okay, what is break-even point? It is a condition of no profit, no loss condition. No profit, no loss condition. Okay, that means your P will be equal to 0. That means capital S is equal to capital TC, or small s into x is equal to capital F plus small v into x, or x is equal to F upon small s minus small v. So this is basically, we call it as the break even point. That means this much should be or must be the volume of production so that I will be having no loss condition, no profit or even no loss condition. Okay, so if I want to analyze from the graphical perspective, if I try to plot a curve between the cost and the volume production, on the x-axis, y-axis we are having cost, and this is your volume of production. So this one is the total cost, right? And if I try to plot on this one, this will be the total sales. Okay, and this point where the total cost is exactly equal to total sale, this is basically we call it as the break-even point. This is break-even point or BEP. Okay, this is your break-even point. Is this clear? Understood, everyone? Kundan, Shreyas, Savi, quickly do let me know. Acha, tell me one thing. If you are having, let us suppose your, let's say I'm taking condition number 1, total cost is more than that of sales. What's the meaning of this? If your total cost is more than that of sales, that means a total cost more than sales, that means I'm talking about this region. Total cost is more than that of sales. So can we say that is a loss condition? That means whenever I am having the volume of production less, less than that of break-even point, I'm talking about a loss condition. Okay, and whenever I'm talking about when the sales is more than that of total cost, that means more than that of break-even point. This is sales, this is sales value, and this is the total cost, right? So it is definitely more. So I can say this condition or this in which it is more than that of break-even point, this is a profit condition. And between this loss and profit, there is one point where there is no profit, no loss condition. We call it as break-even point. And every industry always try to have the targets more than that of break-even point. Every industry. The reason means, let us suppose if you're having the break even point to be 40 units, and if you're giving 40 units as a target, so definitely what will happen, if by any chance, if any on one day, if they're not able to meet the target, definitely will be going into loss condition. So always what we do, we try to take a margin. Okay, let us suppose I'm taking X units I am manufacturing, slightly more than that of the break even point. So this is basically, we call it as the margin of safety. This is basically, we call it as a margin of safety. Margin of safety in units. Okay, margin of safety in units. Is this clear? Which we denoted as MOS. Right? Okay. Can you tell me what will be the margin of safety in sales? हाँ ठीक है. Okay. 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 Done. I think that is all good. हाँ अब ठीक है. Okay. Fine. So I can say that margin of safety. Now, if I want to calculate what is the margin of safety in sales, I can say this is the volume production. Corresponding to this, we are having this as a sales value, and this is the break even point. Okay, right? This is at break even point, and this is the sale value. So margin of safety in rupees, we can say that is S at X minus S at break even point. Clear? Sales at X, sales at X, this is sales at break even point. This difference is called as margin of safety in sales. That means in rupees, one is in units or volume production. Right? Okay, this is the main like we can say the gist of break-even analysis, BEP. That's the main in break-even analysis. Clear? Done? Acha, one more thing that sometimes they're gonna ask you is from the angle of incidence. One more nomenclature that we have to understand, that is angle of or incidence angle. Not angle of incidence, we can say incidence angle. Incidence angle. That is theta. Okay, now this is incidence angle or angle of incidence, that is theta. Now what is the significance of this theta? If your angle of incidence is having a larger magnitude, what will be the meaning of this? Can you tell me? If your theta value is having a larger magnitude, what is the meaning of that? Do we attain break even point quicker or after larger volume production? Let us suppose I'm taking one example. I'm taking one example like this. This is volume of production, and this is your cost or sales, because I'm taking both on the y-axis. Quicker, very good, very good. Let's say this is the total cost. Okay, and there are two feasibilities. I'm selling a product at some sales value, that is S1. Okay, and secondly I'm selling one more at some other sales value. Let's say this is S2. That means same product, this is a two provision. Let's say S1, I'm selling at cost of rupees 10 per unit. Okay, and in the second scenario, I'm selling at a cost of rupees 20 per unit. Okay, so definitely if I'm selling a product at a higher price, I will be able to attain break even point quicker or at earlier stage. This is the break even point for the second example. This is the break even point for the first, if I'm taking the selling price to be 10 units. So definitely if I'm increasing the selling price, I will be attaining the profit quicker. That means at lower volume production, I will be attaining the break even point. Okay, and it is clearly visible that if I say this is theta 1 and this is theta 2, so theta 2 is more than that of theta 1. That means the angle of incidence or incidence angle, if you are increasing by increasing the selling price, the break even point, the x break even point, or I can say the x for the second scenario, the break even point will be less than that of x break even point for the first. And it is always beneficial if you are attaining the break even point on at a quicker phase. If you are getting break even point quickly, that is the best way to increase the profit for any product in any industry. Clear? Understood? Break even analysis, break even point. Done. The angle of it, because sometimes if they can ask you, you have to know what is a margin of safety, what is the incidence angle, right? Let's say they are asking for 1 mass. If you increase in the incidence angle in a break even chart, and this particular chart or graph we call it as break even chart. Okay, this we call it as break even chart. Okay, fine. Is this clear? Understood, everyone? Okay. In break-even analysis, there is one more concept that we need to understand, that is the profit volume graph. Okay, there's one more analysis that we have to understand, that is the profit volume graph. We call it as PV curve. Anyone who have any idea what is profit to volume ratio or profit to volume graph? Yes. Anyone? Profit to volume graph, basically it is equal to the ratio of the contribution margin to the volume of sales. That means the profit to volume ratio is equal to the contribution margin by the volume of sales. Okay, a capital S, right? Okay, let me write it over here. Let me see it is there or not. Okay, exactly. What is contribution margin? Contribution margin is equal to the difference of sales minus the variable cost. It is the total sales minus the total variable cost. That difference we call it as contribution margin, and I can rewrite this as S minus V by S. Okay. So what is the basic meaning of this curve and why we are using this? Basically, you might have seen that some industries are dealing with multiple products. Can you give me some examples where a company name is same but they are dealing with multiple products? Any example where a same company is dealing with beauty product also, food item also, or essential items also? Any example? Like we are having one example of Nestle, ITC, very good. Tata, we are having Tata Motors, we are having Tata Steel, है ना? Exactly, very good. We are having Nestle, we are having HUL, है ना? Hindustan Unilever Limited, right? So let's say I'm taking an example of Nestle. So in Nestle, we are having different products, chocolate also, ketchup also, coffee also, right? So whenever an industry is dealing with multiple products, so they won't be plotting for different products the different break even chart and try to analyze. No, if I'm having a single chart By looking at the single chart, I need to visualize which product is making more profit and which product is making more loss. So whenever whenever an industry or organization is dealing with multiple products, they are using the concept of the profit volume graph. Okay, so this particular is basically used whenever we are dealing with multi-product. Okay, and this ratio will always remains constant for a product. For a product, it always remains, this profit to volume graph is always remains constant. Let us take one example. I'm taking for a first of all single product, then we're going for multi products. Okay. The profit to volume graph is, let us suppose, something like this. This is volume and this is profit. Okay, this is profit. This is 0. Now this is negative profit. This is loss. So can you tell me, if I want to write in our known nomenclature, what do we call this particular intercept in this graph? Anyone? In the known nomenclature that we have seen, like S, F, V, or total cost, or profit, or loss, can you tell me what do we call this intercept? Tell me one thing. If volume of production is equal to 0, do we have any cost? If volume of production is equal to 0, do we have any cost? Anyone? We already know that, sir, S is equal to total cost plus profit, or S is equal to F plus V plus P. Yes? Fixed cost. Very good, Harikesh. Absolutely correct. If there is no volume of production, if I try to rewrite this expression, Sx is equal to F plus Vx plus P. If x equal to 0, can we say P is equal to minus F? That means if there is no volume of production, the fixed cost that we are having is the loss that will be incurred by any organization, and this is basically the negative profit, that is F. Exactly, that is a fixed cost. The negative intercept on the y-axis is the maximum loss that will be incurred when there is no volume production, that is, we call it as a fixed cost. And slowly when you are increasing volume production, there will be a point where there will be no profit, no loss, that is a break-even point. And beyond this, we'll be having the profit condition. Okay, beyond this, we'll be having the profit condition. Is this clear? Right. Fine. Now, my question is, let us suppose I'm having this for product number 1. Okay. I'm having one more product, suppose like this. Let me have something like this. Let's say this is product number 2. This is, I'm talking about your Maggie, and we were having multiple products, like we are having Maggie, and I'm talking about coffee. So which is making more profitable business, coffee or Maggie? Which is more profitable? If you see this profit to volume graph, which is more profitable, coffee or Maggie? See the graph and tell me. Coffee. Perfect. Obviously, sir, coffee. Why it is coffee? The reason being, we are able to get the break-even point quicker. We are getting the break-even point quicker as compared to that of Maggie's. That means coffee is more profitable business. I have to concentrate on Maggie because the profit is not that too high. So I have to reallocate some resources. Coffee is making profit. You don't have to decrease the resources. If possible, if you are increasing resources, I'll be getting more profit. So coffee is more profitable business as compared to Maggi, and this way, by only seeing the profit to volume graph, we can say we are getting more profit. I can say one more thing, profit to volume, if you try to take the slope also, if you take the angle also, the more the slope of profit to volume, the more will be the profit. Okay, and what is P by V? That is nothing but the slope of this curve. And more the slope, more will be beneficial, more will be the profit. Is this clear? Exactly. Theta 2 is more than that of theta 1. That simply means we are getting more profit as compared to other products. And this ratio will be same. This particular line is a straight line, right? So this particular slope is same, and that is the reason P by V value is always remaining the same for a particular product. And what is P by V? We can calculate by contribution margin, that is S minus V by S. S minus V by S. Okay, clear? Acha, I'll be writing one expression. You have to tell me whether this expression is correct or not. Profit to volume is equal to S minus V by S, or S, or that is equal to F plus P by S. Can I write it like this? Please do check. Can I write this expression like this? We can easily write, sir, S is equal to F plus V plus P, or S minus V is equal to F plus V. So I can rewrite the profit to volume by taking the addition of fixed price plus profit by the sales price or total sales. Okay, and we know that for a particular product, let's say at X1 we are having S1 minus V1 by S1 is equal to, this is at X2, S2 minus V2 by S2, that is equal to F by S breakeven. Can I write it like this? Yes. One resembles for, and this is for only a single product. This is for a particular product. Okay. This is for a particular product, right? At X1, we are having S1 and V1. At X2, we are having S2 and V2. And at break-even point, I have not written any value of P. Is this correct or incorrect? Do I need to write P value? No need to write, because at break-even point, profit is equal to 0. So we can simply say it is equal to fixed price by the total sales at break-even point. That is the reason I have not written over here. I can write it like this also. F plus P1 by S1 is equal to F plus P2 by S2 is equal to F by break-even point. I can write it like this also. Okay, clear? Understood? Because it is having no profit, that is the reason I have not written anything at this one. And this ratio will always remain same for a particular product, that we've already seen. For a particular product, this ratio, for Maggi, this value is constant, this theta value is same, right? If I say for coffee, this or product 2, this theta value is same, that is the reason P by V ratio is not gonna change at any point of time, and that is the reason we are saying this ratio always remains constant for a particular product. Okay, very important statement. This ratio, profit to volume ratio, will always be remaining same for a particular product. It won't be having any change in the value. Okay, clear? Profit to volume graph. This is all about the concept of break-even analysis. Done? Okay. Now let's talk about. No, this is total sales. If I want to write for per unit, I can write it like this. I can say S1 minus V1 by S1. I can rewrite this as S1 minus small v1 by small s1 also, because x1 will be cancelled out. It will be S1 x1 minus V1 x1 by S1 x1. I can rewrite like this also. Okay, and what is capital S minus capital V? That is equal to contribution margin. This difference is called as contribution margin, and small s minus small v is equal to, only we can call it as contribution. Okay, so we can say profit to volume graph is equal to the ratio of contribution by unit selling price. These are for same product, for same product only, same product at different volume of production. Okay, that's a written, I've written x1, x2 and BEP. Clear, Harikesh? It's not different product. I'm writing for a same product only, a different volume of production. Clear? This 1 and 2 is basically resembling you about the different volume production. It's not different product. Definitely different product will be having different values, different profit to volume ratio. If both are having same, then definitely that will be two parallel lines. If profit to volumes value, if it is same, then we are having two parallel lines. That simply means both are giving me the same output. Okay, fine. Is this clear? So we have completed two topics, PERT CPM, we have completed break-even analysis. Now we are entering to the next topic, the most important, right, slightly lengthy one, that is the inventory. Right, now let's talk about the next very interesting and important topic, that is inventory. Okay, so shall we begin the inventory one? Fine. Yes, okay. Fine. Now, what do you mean by inventory? Everyone will be saying the stock in hand. It's written on the screen. Inventory is stock in hand, and inventory is an important topic. And again, repeating, if you're planning to give GATE examination this year, there are two must topics from GATE examiner perspective. One is PERT CPM. Second is inventory. These are very important. You should not be skipping up these two topics. Rest topics are also important, but by seeing the latest 3 years of pattern, inventory से question आता है ना? चलो. Inventory can be termed as stock in hand at any given point of time, which is held for purpose for later use or sell. Let us take one example. Let us suppose I'm having, one second. Everyone is eating roti, everyone is eating roti, right? Let us suppose I'm having a sack of 10 kg, 10 kg atta is there with me. I went to a shop, I purchased a 10 kg atta, and from there I've taken a 2 scoops of atta and I've made a dough. I made a dough, right? Okay, and I'm making chapatis and storing into hot case. Okay, I'm storing into hot case for eating purpose. So tell me, among this one, 2, I'm taking this as a combination as 3, because making chapati and storing into hot case, I'm taking it as same example. So among these 3, which one will be considered as an inventory? Which one will be considered as an inventory? Only 1, only 2, only 3, or 1 and 3, or 2 and 3, or 1, 2, 3? Which will be considered as an inventory? Okay, 1. Okay. Farinder is saying 1, 2, 3. Pujita is saying 1, 2, 3. Okay. Pakka? Sure. 1, 2 and 3. Can we log that answer? Exactly correct. 1, 2 and 3. All 3 will be considered as inventory. Have you seen whenever you are going home? Let's suppose I'm presuming that you are staying in hostel. Okay, when you go home because festival season is going on. So when in the kitchen, when your mom or anyone is making chapatis, let us suppose after that some dough is being left out. We are not throwing dough, right? We will be keeping that dough in our fridge and we can use this for later use. Sometimes what happens, we made some chapatis and you were not were hungry, so there are some chapatis being left in the hot case. So that is also be considered as a inventory, because we can consume that particular raw chapatis after 2-3 hours or after one day. So I can say all these three will be considered as an inventory, right? All these three will be considered as inventory because we can use this particular item for later use, for selling or for purchasing, or definitely for any kind of expenditures. We can definitely go for this, and this is considered as an inventory. All these three will be, not only the item which the raw material that we are keeping is not an inventory, even the raw material, the semi-finished product, even the finished product, all these three will be considered, will be categorized under the inventory. Is this clear? Because some students always have this perception that the raw material means inventory. No, raw material, semi-finished product, and sometimes the finished product is considered as a inventory. Okay, fine. So whenever we are dealing with inventory, I told you in industrial engineering, we are dealing with optimization. We are always talking about high profit. We are talking about low losses. Okay, we are always trying to optimize our approach. Okay, if I'm talking about per CPM, if I'm talking about break-even analysis, even though if I'm talking about your inventory also, we are dealing with the optimization only, right? So wherever we are talking about optimization, we are talking about industrial engineering. Please make sure that, or whenever we are talking about industrial engineering, back of the mind, you have to always keep in mind about optimizing our answer, or optimizing our resources, or maximizing the profit. So inventory is also being used to increase the profit by decreasing the total cost. So definitely some cost factor is being included. So in inventory, there are different costs which is being included. We are having like your purchase cost, we are having your ordering cost, we are having holding cost, we are having the stock out cost, okay, or shortage cost. So if I say inventory, we are having different type of costs: purchase, ordering or setup cost, holding or carrying cost, or shortage or stock out cost. Let us discuss one by one. What is this purchase cost? What is this ordering, holding or shortage? The first one is purchase cost. What is purchase cost? It's quite easy to understand. Let us suppose there is a pen that I need to purchase and is costing me ₹5. Okay, I want to purchase 100 units. Then what will be the purchase cost? What is the purchase cost? For purchasing one pen, it will be costing me ₹5. I want to purchase 100 pens. Sir, very easy. 5 into 100, ₹500 will be the purchase cost, right? Purchase cost will be quite easy. 5 into 100. Or I can say, if I want to generalize this, capital D into C is the purchase cost. What is capital D? What is capital C? Okay, capital D is your annual demand, right? That is units per year, and capital C is your unit price, unit cost or unit price, that is rupees per unit, rupees per unit. Okay, annual means I'm talking about per year. Okay, unit cost or unit price means per unit what is the total cost. Okay, fine. So it is a cost of purchasing inventory. It depends upon the quantity or the bulk purchase, right? Okay, it depends upon the unit price. That's it. It depends upon how much you require and how much unit price we are having. So that is a purchase cost. Now let us go for the second one. That is ordering cost. That is denoted as OC. Now what is ordering cost? Now whenever you are ordering, let's say on Zomato, you are ordering some food. So apart from the MRP, there are some additional costs this gonna charge. Sometimes they're gonna charge delivery charges. They will be having some platform fee. Nowadays I'm seeing they are charging something like platform fee 2 rupees or 5 rupees, right? They'll be charging some taxes also, right? So ordering cost is basically, apart from its actual price, whatever additional charge they are charging in order to have that timely and the safe delivery of your item, that is we called as the ordering cost. Exactly, GST also. Okay, so when the inventory is purchased from outside, the cost associated with bringing up the inventory within the system, that means how much additional cost you have to pay apart from that purchase cost. 500 rupees you are already paying. You are paying 500 rupees to purchase that 100 units of pen. Apart from this, let us suppose you are paying 50 rupees additional in order to have, or to bring that particular item in your system. That includes your delivery cost, that includes the insurance cost, that includes your transportation cost, everything, that is documentation cost, everything that we are having. Okay, exactly, we are having like if you are going to restaurant, we are having 2.5 SGST and 2.5 CGST, and 5% total GST you are paying whenever you are going outside to any restaurants. Okay, fine. Is this clear? So whatever cost we are having, cost of tender, processing cost, communication cost, inspection, transportation, that all the cost that is being included, that's we called as the ordering cost. I hope so you know what is a tendering cost or cost of tender. You might have seen that whenever a government project is being, if you want to have some contractors for the government project, they offer tenders. Okay, so the minimum tender that is being given by some organization, that particular organization will be getting the project. Okay, that is called as tendering. So the documentation that is being done, the cost that is being included, that is we called as cost of tender. So how we can identify or calculate the ordering cost? Now let us suppose if I say in an year you are having 10 orders you are placing. Okay, let us suppose you are placing 10 orders and every order is costing me 50 rupees. Every time you are placing the order, it is costing me 50 rupees, and annually you are having 10 orders per year. So can you tell me what is the annual ordering cost? Annual ordering cost, see this particular values, because we will be able to understand from the values perspective. Yes, you are placing 10 orders in an year and every order is taking 50 rupees. Can we say 50 into 10, 500 rupees will be your total annual ordering cost, or we can say this is number of orders. Okay, number of order into cost per order, which we are denoted as capital M and into CO. This is your ordering cost, annual ordering cost, right? Now how to calculate number of orders? Let's take one more example, then we'll be having one second, there is no blank slides. Yeah, okay. Now let's say annual demand is 1000 units. 1000 units per year is the annual demand, right? And every time, let's suppose Q resembles your order size. Order size, that means every time you are ordering this much of amount. Let's say you are ordering 50 units or 250 units every time you are placing the order. So can you tell me what will be the number of orders that you have to place? That is capital N. If capital D resembles the annual demand, Q resembles the order size, right, which is 250 units. So you have to place 4 times, then only you will be able to fulfill our annual demand. है ना? 1000 by 250. 1000 by 250, that is 4. You have to place 4 times this order, then only you will be able to fulfill the annual demand. That is capital D by capital Q. This is basically the number of orders. Now if I place it over here, now if I try to place it over here, I can say that capital D by capital Q into CO, this is your ordering cost. Okay, right? Capital D by capital Q into CO, this is your ordering cost. Fine, clear hai? Chalo, next one. Now sometimes what happens is, you are not procuring the products from outside, you are manufacturing the products inside the system. Let's say best example is tires. Okay, if I take the example of Tata Motors, okay, so Tata Motors is not manufacturing the tires in house, they are procuring the tires from outside. They're procuring from either from MRF or Apollo tire, okay, or JK tires, right? So they are not manufacturing, they are procuring the tires from outside, and they are directly they are installing to their vehicles, right? Okay, but let us suppose Tata Motors had decided that they will be manufacturing the tires in house. So if they are manufacturing the tires in house, so definitely there will be some additional cost they will be, because now they are not ordering from outside. So ordering cost concept won't be coming. Now we'll be having the concept of setup cost. Okay, what will be the setup cost? Setup cost will be, you need to have some machineries, you need to have certain raw materials will be required, you need to have some workers also, right? You need to have some equipments in order to manufacture that tires in house. So that will be considered as a setup cost. So in this case, when the inventory is being manufactured in house, in that particular scenario, will be considered as a setup cost. Okay, it won't be having any ordering cost. But if you try to visualize, if I say setup cost, that is SC, setup cost is equal to number of times I have to make the setup, number of setup, because not every time will be running the production of tires. We'll be manufacturing the tires for, let's say, 1 or 15 or 20 days, then we'll be taking a break, then again we'll be manufacturing 15 or 20 days, because every day tire manufacturing won't be required. Okay, because let's say every day if you're able to manufacture 1,000 tires or lakhs of tires, so you take a break of, let's say, 10-15 days, then you can again set up your next cycle. Okay, so setup cost is equal to number of setup into cost per setup. So are we not able to visualize that it is something similar to the ordering cost? Okay, so setup cost is also equal to number of setup, that is N, into the cost per setup, I'm taking it as CO. So this is nothing but D by Q. Here Q is not the order size, Q is every time how much I'm manufacturing. Let us suppose in total I require 1,000 units per year, or this much of tires is required. In every setup, this is your we can say setup size. Every setup how much you are able to manufacture. So that is equal to, let us suppose I'm taking this as 500 units in every setup I'm manufacturing. So can you tell me how many times I have to make this setup? I have to make only 2 times. So I can say D by Q into CO, this is nothing but setup cost. Okay, so ordering cost and setup cost is almost having the same formulation, and definitely you won't be having setup cost and ordering cost to be coming simultaneously. Either will be having the setup cost or ordering cost. That is the reason I have taken the same type of formulation, so that try to minimize the number of variables in order to have a better understanding. Okay, fine. Either will be having setup cost or will be having the ordering cost, and that is the reason if you try to visualize, I have written ordering or setup cost. Right? Fine. Is this clear? The next one is holding or carrying cost. Right? Now definitely it's not like this. If you are if you want to at your home, if you want to cook rice, you are not going daily outside and purchasing the rice, like I want 200 grams or 150 gram of rice. Okay, and next day again you are going and purchasing 150 gram of rice. You are not doing like this. You will be purchasing in bulk, like you'll be purchasing 5 kgs or 10 kgs of rice for a span of 10-15 days. Then again you go to the shop and you try to purchase in bulk. Okay, you won't be going every day to purchase the inventory. If you are going every day, then definitely there will be some additional resources that you have to pay. You have to go outside every day. You have to take, let's suppose you have to take a rickshaw from your home to the shop and you have to pay additional 50 rupees. So definitely that is additional cost that you have to pay, that is transportation cost. So it is gonna cost you more. So what you do, you try to purchase in bulk, and for 10-15 days it will be sufficient, and then again after 15 days you go for the next cycle. Okay, so holding cost is basically when you purchase any inventory, definitely it will be stored, right? Okay, let's take an example. Let us suppose you have planned to open a jewelry shop. Okay, you have planned to open a jewelry shop and you have purchased jewelry or diamond worth of 1 cr, 1 crore. You won't be keeping that jewelry or that diamond in a plastic box on a table like as it is like this. If you're keeping like this, someone is will be coming and will be taking that box and 1 crore will be gone. You'll be having a proper CCTV cameras, you'll be having a proper locker, you'll be having an armed rifleman. So definitely you have to pay some amount of money for that. So that particular expenses which is there to make sure that that particular inventory is stored properly, some inventory is being handled properly, we are not having any damage, the insurance, everything that is being included in order to make sure that the item, that particular inventory is stored or kept in a proper way. That particular cost we call it as a holding cost. Okay, and definitely here it depends upon time also. This particular holding cost, it depends upon the quantity and how much duration we are keeping. Let's say if I say you are storing 10 units for 100 days and 10 units for 2 days, definitely in both the scenarios different costs will be associated, right? If you are storing this pen for 2 days, storing this pen for 1 year, both cases we are having different costs will be associated. If you are increasing the duration of storage, then what will happen? The holding cost is going to increase, right? So what we'll be doing, because with the time it is gonna increase, we will be taking the average value. So that is the reason we call it as the holding cost is equal to average inventory for a period into holding cost per unit per time. What will be the formulation for this? We'll be seeing after the introduction of the models, EOQ models, then we'll be coming to this particular formulation. Okay, before that you need to have a basic understanding. Before that, ordering cost and purchase cost, already we have seen the formulation. Holding cost and shortage cost we will be able to understand once we are able to understand the graph. Okay, next one is the shortage cost. What is shortage cost? Now let us suppose you are going to any shop and some item is out of stock, right? So definitely due to this non-availability of the item, there will be some shortage, and due to shortage or loss of inventory, what will happen? There will be a loss of revenue. That particular loss of revenue we call it as a shortage or stock out cost. The shortage simply means the absence of inventory or the loss associated with not serving the customer is termed as a shortage or stock out cost. Sometimes it is done intentionally. Okay, let us suppose you are having the raw materials and it comes after every 20th day. On every 20th of the month, that particular raw material will be coming and will be refilling the stock. Let us suppose on 19th day the stock is being completed. So you're going to tell the customer that you have to wait for 1 day, then you will be getting the next particular fresh item, right? You won't be purchasing on the 19th day the next lot, paying some additional prices. You will be definitely going to say to the customer that you wait for 1 day and that particular item will be coming after a day. If that customer is willing to wait for 1 day, it's okay. If he is not willing to wait for 1 day, he will be purchasing that item from another shop. So that is a loss that is being inculcated due to the non-availability of the inventory, and that is basically we call it as a shortage or stock out. If the shortage is for a longer duration, then can we see that the shortage cost will be high? If you're having this pen, if it is shortage for 1 day, the same pen is out of stock for 1 month, definitely the shortage cost for 1 month will be very high. So are we having some similar resemblance as that of the holding cost? In holding cost also, if you want to hold for one day, if you want to hold for 1 month, if you want to hold for 1 month, you have to pay a high amount of money. Similarly, in this case also, if you want, if there is a shortage of this particular pen for one particular month, it is going to have a larger amount. So we are always having a similarity between shortage and stock out cost, right? And if you try to visualize, almost we are having the same formulation. It is the average number of unit being short into shortage cost per unit per time. If you see over here, this is average inventory for a period into holding cost per unit time. Almost we are having the same formulation, but the meaning is entirely different. Meaning is entirely different. It's not having the same meaning. One is related to holding that inventory. Second is related to when there is no or absence of inventory, or there is inventory is not present. Okay, fine. Is this clear? Now, once you had understood this particular different types of costs, here we are having two different types of your inventory models. We are having deterministic and probabilistic model. Okay, deterministic means, again, deterministic means exact values. We are not having any variation. So here we can say your demand rate and lead time is fixed. Demand rate and lead time remains fixed with respect to, okay, it's constant. What is a demand rate? Demand rate means, which is basically denoted as small d. We will be taking one example to understand this. It is normally taken as per weekly demand or per day demand. Let's say if we're having 3650 units is required per year. This is the annual demand. So can we say what is the daily demand? What will be the daily demand? That will be 10 units per day. Can we say? So this particular daily demand, we call it as demand rate. Because in 1 year we know there is a 365 days. If you want to convert the annual demand into per day basis, that will be demanded. Or if you want to convert to per weekly basis, you have to divide by 52. If you want to divide per monthly basis, you have to divide by 12. So accordingly, you will be getting the demand rate. Okay. What is lead time? We'll be understanding lead time after a while, right? Okay. Safety stock also will be discussed in that. In probabilistic approach, it is being seen that it is something related to the real life examples, because demand rate will not be constant every day. In reality, if you see, the demand rate won't be same. If I say 10 units per day in 2023, if the entire year was 10 units per day, it's not mandatory on every day we'll be having 10 units per day. Like in 2024, might be it is 11 units or 12 units per day some days. Okay, fine. So demand rate will not be same in reality, but still we are implementing the deterministic model in our different applications. The reason being, because the variation is not that high. Let's suppose you are working in a automobile sector. Okay, you know that the daily demand is 500 cars. Suddenly the 500 cars won't be increased to 5,000, or 500 cars will be dropped down to 10 cars or 100 cars. Okay, if you're having a daily demand rate of 500 units, either we can have 498 or 502 or 505, a range will be there. So almost we can say the demand rate is almost fixed, and that is the reason we are always implementing the deterministic approach. Probabilistic approach is basically dealing with those products which is having less time, less lifespan, like we can say perishable items like flowers, fruits, vegetables, dairy products, right? If you're let's suppose you are owner of a shop and you are keeping vegetables, so vegetables won't be having a life of a month or a 10 days. You can have max to max a life of 4 days or 3 days, not more than that. So whenever we are dealing with the items where the lifespan of a product is less, there we are keeping the concept of probabilistic approach. The reason being, the demand will be changing every day basis, because the life cycle or lifespan is less. We always try to keep it in an optimized way. right? Let us suppose you are purchasing steel. Even if you're purchasing steel for either keeping the steel for a month or an year, no problem, you can definitely sell off that particular steel after in a year also. But if you are purchasing an apple today, you cannot sell that apple after 1 year, right? Then apple won't be left out, will be having that fungus, algae, everything will be present. Okay, fine. So whenever we are dealing with perishable items where the lifespan of an product is not too high, there we will be implementing the concept of probabilistic approach. Okay, and here the concept of safety stock will be very much essential, because demand rate is changing, so safety stock must be optimized, and that is the reason in probabilistic we are always dealing with a perishable items approach. And here we are talking about one static inventory model. Static inventory model. Okay, in gate examination is rarely being asked. In gate examination we are mostly dealing with deterministic approach, where we'll be having the basic EOQ model, the production model, the discount model, your shortage model. There are 4 different models in deterministic. We'll be discussing this in detail. Probabilistic, if we are having time, we'll definitely will be taking one example, or else we'll be solving the questions. I'll be taking one question from the probabilistic. Okay, static inventory, that is we are having P upon P plus L, the cumulative probability ratio. We'll be taking an example of that also. Okay, fine. So let us start with the first one, that is deterministic model. The first and very interesting, very important, that is simple EOQ. Chances are very high you will be getting question from this one. Chances are very pretty much high. You'll be getting question from simple EOQ or max to max this one. These two are rarely being asked. These two are important from the ESE examination perspective. Okay, from engineering service examination, you will be getting questions from discount model or shortage model. Okay, perfect. So shall we begin with the simple EOQ, first one? And one more thing, if you are able to understand the simple EOQ, rest all models are very easy, slightly modified version. Okay, slightly modified version. So I'll be investing more time on simple EOQ, and very less time is required to understand the rest of the models. So let's start with the first one, that is basic EOQ model. Acha, before starting this, we are using this word EOQ. What is the meaning of this word EOQ? We are using this word, na, EOQ. What is the meaning of this word? EOQ stands for economic order quantity. Let's try to take an example. Let's try to take an example, then we'll be able to have a better understanding. Now, we have seen one cost as ordering cost. Remember, we have seen one ordering cost. Okay. Now, if you are ordering more number of orders, can we say the ordering cost is going to increase? Let us suppose the total annual demand is 100 units. Okay, and there are two feasibilities. One is every time I am placing an order of 10 units, and second case, every time I am placing an order of 50 units. So which one will be which one will be having a lesser ordering cost? Ordering 50 units or ordering 10 units in one cycle on one order? Which one will be beneficial for us from ordering cost perspective? If I say over here, the number of orders will be 100 plus 10, that is equal to 10. You have to place 10 orders over here. Here you have to place 100 by 50 is 2. Only 2 orders is sufficient enough. Let us suppose cost per order is rupees 100 per order. Okay, so here you have to pay 1000 rupees. Here you have to pay only 200 rupees. So from ordering cost perspective, if you are having lesser orders, that is much more beneficial. Yes, but if you try to visualize, if you are ordering less number of time, that means in one go you are ordering a larger units. Over here you are purchasing 50 units every time. Here you are purchasing only 10 units. So definitely when you are purchasing 50 units, ordering cost will be decreased, but holding cost is going to increase. Yes, if you are decreasing the ordering cost, this will be at the expense of increasing the holding. Now you have to hold 50 units for a longer duration. In the previous scenario, if you are procuring 10 units, you only have to hold 10 units for a lesser duration, right? So definitely ordering cost decrease, holding cost increase. But if you are taking the vice versa, if you're trying to decrease the your holding cost, your ordering cost is going to increase. So in between this, I have to make one ordering or order cycle or order number of units being order size, so that my overall cost will be minimum. That particular order size, when the ordering cost or when the total cost will be minimum, this is total cost, okay? When the total cost will be minimum, that order size we call it as the economic order quantity. Okay, that is one second. That is we called as the economic order quantity, where the total cost associated will be minimum. Because if you are increasing the order size, what is happening? You are decreasing the ordering cost, but you are increasing the holding cost. Okay, if you are taking the opposite scenario, if you are increasing the number of orders, you are increasing the ordering cost, but you are decreasing the holding cost. So both are basically inversely proportional to the order size, and this is the reason we have to have some optimization, and that is your economic order quantity. Okay, that is your economic order quantity. Is this clear? Right. So now let's talk about the first one, that is EOQ, basic EOQ model. The first one, that is basic EOQ model, also known as Harris-Wilson model, because these were the two persons which have given us the concept of this model, Harris-Wilson model. And also we can call it as infinite replenishment model. Okay, let us try to discuss one by one. Okay, now if you try to if you are, let me draw one diagram, then we'll be taking that diagram which is already there in the, on the y-axis I am taking the order size or inventory. We can call it as inventory size or order size, both are having the same meaning, inventory. Okay, and on the y-axis we are having the time. Let us suppose you have procured Q order. You have Q order with you. This is Q, right? And with the time this inventory will be consumed. With the time the inventory will be, this is linear, okay, straight line, and there will be a point when the inventory will be becoming zero. There will be a point where we'll be having a maximum inventory, and with that time it will be slowly decreasing in linear way and we'll be getting a zero inventory. Then next order will be coming, next slot will be coming, then the same proceed, then same will be going and will be coming zero, next order cycle, right? So this way we are able to design a basic EOQ model. This line indicates the level of inventory. This line, this red line indicates the level of inventory. This is your at a consumption rate or a demand rate of D. D is the demand rate or consumption rate. Let me write it over here. D is the demand rate or consumption rate. We'll be taking example from mathematical perspective. Consumption rate. Okay, fine. Right? If you see, this is the maximum inventory level. Okay, maximum inventory level. This is the demand rate, which we call it as small d. Okay, fine, small d, right? This is the maximum inventory. This is Q max. Now let us suppose, let's take one example from numerical perspective. You are ordering, let's say 10 units every time. 10 units is being ordered every time, and the consumption rate is 2 units per day. Okay, see, try to visualize. Every time you are procuring 10 units per order and the consumption rate is 2 units per day. So can you tell me one particular lot size will be there with me for how much duration? That means before the next lot, how much will be the total time taken to complete this to 0? 5 days? Yes, that means one order will be there with me, or cycle time of one order will be 5 days. Yes, this is, we call it as the cycle time. This is, we call it as a cycle time, that is TC, denoted as TC. Okay, right? That means if on Monday, if you are getting the order in morning 10 o'clock, then after 5 days the next lot will be coming. That is, one lot is having a cycle time of 5 days, and this will be constant throughout the year. Throughout the year it will be constant, it won't be changing. Okay, it will be constant throughout the, it's not like this after 5 days next cycle will be 6 days, then 7 days, because we are dealing with deterministic model, and deterministic model, the demand rate is constant, annual demand is constant, so we won't be having any variations. Okay, fine. Is this clear? Now tell me one thing, what is the, okay, one more thing. After 2 days, how much level of inventory is there with me? Tell me, after 2 days, how much inventory is there with me? Can anyone who can tell me? After 2 days, there are total 5 days is a cycle time. My question is, after 2 days, how much inventory will be there? 6 or 8? Try to see the example, try to see the values. 6 units or 8 units? 6, sure. देखो, daily consumption rate is 2 units. After 2 days, we have consumed 4 units. 10 units is with me, 4 units be consumed, so we are left out with 6 units. So can we say after 2 days, this I am taking this as 2 days, I will be left out with how much inventory? Sir, I will be left out with 6 inventory, 6 units. Sir, how we can calculate? Can we say this is D, this is your, let us suppose I am taking it as Tx. The duration is being left out. This is 2 days, so left out duration is how much? If this is 2 days, left out duration will be 3 days. So 3 into D, 3 into D, 3 into 2, 6 will be the units. I can say this is T into X, or Qx is equal to Tx into D. Can I write it like this? For any, if I want to calculate what is the inventory at any point of time, how much time is being left out with me into the demand rate will be giving you the inventory cycle. Okay, Tx into D will be giving you the inventory level. Right? Is this clear? Okay, fine. Acha, tell me one thing. On 5th day, at the end of the 5th day, how much inventory is there with me? At the end of the 5th day, how much inventory is there with me? At the end of the 5th day, how much inventory is there with me? 0, sure. If you try to visualize, on the end of the 5th day, the inventory is 0, but also the next inventory we have got. So can we say here the slope of this inventory time slope or inventory time curve is tending to infinity? Because there is no change in time and my inventory has gone from 0 to 10 or 0 to Q. Yes? And what is Q by T? Can we say Q by T is nothing but the slope of this curve? And when there is no change in time, when there is no change in time and there is a change in inventory, can we say our slope of this inventory time is tending to infinity? And that is the reason we are calling this as infinite replenishment model. That is the reason we are calling it as, because for the same time my inventory is becoming zero and next inventory is being we got. Okay, so ideally this is an ideal situation. We won't be getting realistic. Realistic will be having zero, then slowly it will be increasing, or might be our next lot might you will be getting before reaching zero. That is a realistic case, right? But ideally this will be the scenario. That is the reason we are calling it as infinite replenishment model or infinite replenishment rate model. Clear? Fine. Understood till this point, because I'll be going very slow to inventory, because inventory is being done, then we can increase our pace, because rest all the topics are not that important. These three topics very important. LP also, linear programming also will be taking slight time. Rest all the topics are not that much essentials. Okay, fine. Chalo. Right. So now we have understood why we are calling this as infinite replenishment model. Right. Okay, let us suppose the consumption is going on, the consumption of the inventory is going on, and we have reached a point. Okay, we have reached a point. Now, definitely, if I want to have the next lot, I won't be telling my vendor that I have I have gone out of stock at 5 o'clock. At 5:01, I have to have the next lot. It is not possible. We always have to inform the vendor much before reaching the last point, so that what I'll be doing, I'll be placing the order at one point of time, so that at least I'll be getting the next order exactly at this point where I'm getting the zero inventory, right? Ideally also, if I say, if I want to have the next order to be received, I have to place the next order cycle much before reaching the zero inventory. This I have to have the order must be received at this point. So if you want to receive the order at this point, I have to place the order slightly before than this. So let us suppose this is the inventory level where I'm placing the next order is being placed. This particular level of inventory we call it as reorder point, or we can call it as reorder level. We can call it as reorder level. Okay, and the day when we are placing the order is placed, and the day when we are receiving the order, this particular time we call it as lead time. I told you I will be discussing lead time in our graphic whenever I'm discussing the graph. So lead time is nothing but the day on which, let us suppose on Monday I'm placing the order, I'm getting the order on Thursday, so I'll be calling the lead time as 4 days. Monday, Tuesday, Wednesday, Thursday, 4 days will be called as the lead time. Clear hai? If I'm placing the order on Monday morning and I'm receiving the order on Thursday evening, so 4 days will be the lead time. So that means the day on which I'm placing the order and the day on which I'm receiving the order, this duration or change in time we will call it as a lead time. And for deterministic model, the lead time will always be remaining constant. Okay. So can you tell me, is there any formulation that we can build between a reorder level, lead time and demand rate? Is there any formulation? You guys gonna tell me, because you know the concept now. Already we have taken for any order size, for any time, we have calculated the level of inventory. So can you tell me what will be the reorder level in terms of lead time and the demand rate? देखो, this is the lead time, this is the time being left out. Okay, demand rate is small d. Can we say reorder level is equal to the lead time into demand rate? Can we see like this? Reorder level is equal to lead time into demand rate. Just like if I say this is the duration of the time left out, and this is the inventory qx. So qx is equal to d into tx. Similarly, we have calculated your reorder level is equal to lead time into demand rate, or we can say, sir, it is nothing but the slope will be constant because it's a straight line. So qx by tx equal to reorder level by lead time is equal to d. We can write it like this scenario also, just like one of your friend is have given, है ना? Inventory by time, that is the slope of this curve, and that will be constant because we are having a straight blue line. You can see this is a straight line. Okay, right? And this cycle will be repeated. This is one cycle, this is second cycle, this is third cycle. This cycle will be repeated after every cycle time. Is this clear? The cycle will be repeated after every cycle. Clear? Right? So now let us try to write the different costs, and that's it. And there is one assumption also that we have to understand: the demand rate is constant, lead time is constant, and there is no shortage. In this case, there is no shortage allowed. Okay, that's the basic assumption that we are using in economic order quantity, basic EOQ model. Right? So now let's try to see the total cost. The total cost associated, that is equal to the purchase cost, ordering cost plus holding cost. Okay, or we can, this is also called as total annual cost, TAC. We can write it as TAC also. We can write it as TAC also. Okay, instead of writing TC, we can write TAC also. Okay, now what is purchase cost? We already seen that is annual demand into unit price. What is ordering cost? That is equal to your number of orders into cost per order, or we can say annual demand by order size into cost per order. Now we have to identify what is the holding cost. That is important. Now let's try to analyze the holding cost, because we are not yet understood the concept of holding cost. The concept is being discussed, but the formulation is not being discussed. Okay, now holding cost depends upon the duration of time. Okay, holding cost depends for a duration of time. Now if I want to calculate the holding cost for T time period, T means one cycle. Okay, we can say what was the holding cost formulation? Average inventory. Now for one cycle, this is one cycle, this is your one cycle. Okay, from this point to this point, one cycle, right? From this point to this point is your one cycle. So can you tell me what is the average inventory in one cycle? Can we say the maximum inventory is Q, the minimum is 0, so average inventory is Q plus 0 by 2. This is your average inventory for T period into holding cost. Holding cost per unit per time. So this is Q by 2 into CH into T, because I am calculating for T time period. Okay, I am calculating for T time period. Now T is your one cycle. This is your cycle time. Okay, so in one cycle, we can say in 1 year, how many cycles will be repeated? In 1 year, How many cycles can we say? N cycles will be repeated. If I say n is the number of orders, so this graph will be repeated n number of times. So can we say that annual holding cost that is equal to Q by 2 into CH into T into N. Okay. T into N. Now, let's try to take one example to have one very basic understanding. Now, let us suppose I'm having, let's take, I'm drawing a small diagram over here. Let's try to analyze it. Only one cycle I'll be drawing. Okay. This is Q, this is TC, and this is D. Now, let us suppose your order size is 10 units and your demand rate is 2 units per day. Then what will be the cycle time? Can you tell me? What will be the cycle time? Anyone? Anyone who can tell me what will be the cycle time? Tell me in the formulation perspective. Yes, correct. Can we say cycle time is equal to capital Q by small d in days? Yes. है ना? This much days for one cycle or one order. For one order, that is 5 days will be there for one order. Yes, everyone? है ना? Acha, if I want to convert this into year, I have to multiply it by 365. I have to multiply by 365, this one, right? So can we say it will be equal to or Q by capital D year per order? Can we write it like this? Because if we're converting the daily demand into annual demand, so that will be your capital D. If I'm converting days into year, so Q by D is equal to TC. Can we write this is in year? Yes. And what is the number of orders? We have already seen number of orders equal to D by Q. You can see over here. So T is equal to Q by D. So what is the product of N into T? What is N into T? Anyone? N into T is always equal to 1. N into T is always equal to 1. Is this clear? We have proved it. N into T is always equal to 1. So we can use it over here. N into T is equal to, so we can say annual holding cost is equal to Q by 2 into CH, where CH is the unit holding cost per time, or holding cost per unit per time. Okay. CH is the holding cost per unit per time, that is rupees per unit per year. Okay, so this way we have identified the total cost or total annual cost is equal to purchase cost plus ordering cost plus holding cost, that is a D into C plus D by Q into CO plus Q by 2 into CH. This is the total cost that is being associated, that total annual cost that is being associated for this particular inventory. Okay. Achha, tell me, out of these three costs, that is purchase, ordering and holding, which cost is depending on the inventory? Out of these three costs that we are having, which cost is depending on the inventory? Anyone? Very good. Total annual cost or total cost, both are having the same meaning. Can we say only ordering and holding, only ordering cost and holding cost is depending on inventory, right? Or we can say the total inventory cost, that is TIC, is equal to ordering cost plus holding cost, right? So if you want to calculate what is the total inventory cost or total inventory cost per year, we only have to add ordering or holding. Okay, clear? Fine. Acha, tell me what was EOQ? What was EOQ? Sir, EOQ was a point where the total cost must be minimum. है ना? What is your EOQ? EOQ is that order size. Let me write it, the definition. That order size where the total cost is minimum. What is seen PC? That is unit cost. Unit cost, unit price, already we have seen. Let me show you over here. Where is that purchase cost? Yeah, unit cost, 5 rupees per unit, 100 units we are purchasing. Clear? Okay, right. So that's the reason, please, every sequence is important. If you are skipping beach mein na, so that will be difficult. Okay, now where were we? So we know that economic order quantity is that order size with the total cost is minimum. So let us try to identify what will be the relation. So differentiate the total cost with respect to Q and make it equal to 0, right? Dekho, purchase cost is independent of this, so that will be 0. Okay. Now this is 1 upon Q, so this is minus D by Q square into CO. This is Q by CH, this is plus CH by 2 equal to 0. Rearranging the equation, will be having Q is equal to 2dCO by CH root of this. This is the order size where the total cost will be minimum, and this is basically called as economic order quantity. This is, we call it as economic order quantity, which we call it as Q star. Okay, this is basically, we call it as Q star, that is economic order quantity. Clear hai? 2dCO by CH is the economic order quantity, and whenever I am using star value or wherever you are using star, that means simply we are talking about economic order quantity, right? And if you are placing this Q star value in this, we are getting the minimum cost, hai na? So if you are taking for that minimum cost, that is T, I am taking the ICO, so TIC star is equal to your D by Q star into CO plus Q star by 2 into CH. Placing this value of Q star over here, I will be getting 2dCOCH. Sorry guys. We have to see, Faninder, we have to prove it. And total annual cost at EOQ, wherever I'm using star, that simply means EOQ. Please make sure you are having this. Wherever I'm using star, that is your this one, okay, EOQ. So this is purchase cost, or let me write it directly, D into C plus under root of 2dCOCH. This is all the formulations we are using is at EOQ. These all are at economic order quantity. If you want to write at any order size, I can say at any order size, can we write the total annual cost is simply the general formulation, that is purchase cost plus ordering cost plus the holding cost. This is the total annual cost at any order size. This is at EOQ. This is at EOQ, right? Okay, clear hai? Understood? Now, if I try to really visualize that, if you're having a larger order size, is audio and video all good? Please tell me. All good now? Acha, tell me, if you're having a larger order size, my holding cost is going to increase. If Q is increasing, holding cost is increasing, but ordering cost is decreasing. If you are having, if Q is decreasing, then holding cost is decreasing, but ordering cost is increasing. In between this only we are having the economic order quantity. In between this only we are having economic order quantity. So if you are plotting a graph between the cost versus inventory, because we are dealing with your EOQ, so I can say holding cost is equal to Q by 2 into CA, that is linearly proportional. That is your holding cost. Okay, fine. Is this clear? Now, if I try to have ordering cost, that is D by Q into CO, this is inversely proportional. So we'll be having a graph like this. This is ordering cost. So this intersection, it is being observed that this intersection point is that where we are having the economic order quantity. That means if I try to plot the graph, this will be the total addition graph. This is the total inventory cost. This is your minimum cost. This is your total inventory cost, that is at minimum. Okay, and if I try to calculate, something like this for this one, this is the total annual cost. Okay. Acha, what would be this difference? Because why I have drawn this parallel? If I try to visualize, if you are having any order size, the purchase cost is not going to have any differences, because purchase cost is only depending upon the unit price and the annual demand. So this difference is nothing but the purchase cost. That is the reason it is two parallel curves, total inventory cost and total annual cost. We are having the parallel curves. Now from here we are getting an information that when holding cost and ordering costs are exactly equal, we are getting this to be the Q star. When ordering costs and holding costs are exactly equal, we are getting this to be the Q star. Let us try to prove it. So they are saying that at economic order quantity, the ordering cost is exactly equal to holding cost. So this is D by Q into CO, that is Q by 2 into CH. Rearranging the equation, we are having Q square is equal to 2D CO by CH, or Q is equal to 2D CO by CH. So I am getting the same formulation even though the approach is different. So I can say for basic EOQ model, your ordering cost is exactly equal to holding cost at economic order quantity, and we have proved it by using the graph also. From graphical perspective also, we have proved this very easily. Is this clear? Okay, fine. Understood? Everyone? Is this clear? So this formulation that you are seeing is very important, or most important. When you will be discussing the other models also, you will be able to visualize that the same formula is being repeated again and again. Slightly additional factors will be coming, but this under root of 2D CO by CH will be coming, and I'll be proving this also. Okay, fine. So this is your basic EOQ model that we have seen. This is your total inventory cost, that is our holding cost, this is the ordering cost, and it is, we are seeing, this is your economic order quantity, this is your minimum cost that we are getting. Okay, fine. Chalo, perfect. Right, now let's talk about the second model, that is EOQ with break or discount model. We call it as discount model. We can call it as discount model. Okay, what is a discount model? In this case, what we do, you might have seen that sometimes when you go to malls, they are having, if you purchase 5 items, you will be getting 80% discount on MRP, है ना? or they'll be having like buy two at buy one get one free, or buy one at 50%, or buy two at 40%, something like this. We're having this much of. So if you are purchasing a larger items or in bulk, you will be getting we can say discount on unit price. You might have seen, है ना? You purchase 6 items, you'll be getting 80% discount. You purchase 10 items, you'll be getting 95% discount. I don't know, there will be one point will be saying that you purchase 100 items, you'll be getting almost free of cost. Okay, fine. So here we are dealing with discount model, because for few ranges your items will be having slight amount of discounts. Okay, let us suppose if you are purchasing only one item, you went to a mall, you were planning to purchase only one jeans, but by looking at that offer in the t-shirts, when you went home, you purchased 10 t-shirts. Okay, you went there to purchase one jeans, but you landed up you landed up and you purchased 10 t-shirts, because there was an offer. If you purchase 10 t-shirts, you'll be getting 90% off on MRP. So you didn't even required also, but by seeing that particular offer, you were tempted to purchase that, है? And it do happens with everyone. Me also, whenever I'm going, if I see some discount like this, definitely we will be much more eager to buy that. So let us try to understand what is this price break or discount model all about, and from there we'll be able to understand, even though if I'm giving discount, overall we will be getting more we can say profit for this. Right? Let us try to understand. Now, discount is always given. It too happens. It's not with you guys only. It do happens with us also. I go to a mall to purchase a shirt. I landed up purchasing only one shirt. I landed up purchasing 5 or 6 shirts by seeing that offer. And when I go home and see the bill, I was not planning to buy that 5 shirts. I don't know why I have purchased. And that salesman also will be saying, sir, you buy additional 2 jeans or 2 shirts, you'll be getting additional offers. You try to take that. Sometimes I've seen that if you're having 4,000 of bill, you'll be getting, you can give 100 rupees addition, you can get this product. This kind of offer is now happening nowadays. Like once I went there and the bill was somewhere around 1,800, and they said that you purchase any item of 200 additional, 2,000 bill will be there, and you can get an additional offer. So I landed up buying a perfume which was not even required also. Okay, so that definitely happens to everyone. Okay, so coming back to this discount model, what is happening is, okay, with price break or discount model, in this case what happens, we are giving discount on the unit price. We are giving discount to the unit price, like 5% or 10%, and that too only for a range. Okay, fine. Let's say I'm having from 0 to 500 units. The unit price is rupees 10. Okay, from 501 to 1000, the unit price is rupees 6. From 1001 and above, the unit price is rupees 4. So definitely over here, because there's a change in unit price, the total cost might be changing. So here we need to proceed in a very systematic way, and you will be getting that this is the minimum cost at which the order size will be optimal. Okay, fine. So let us take one example how you can have, and then I'll be coming to this particular graph, right? Let us take this example. We are having the following data for an item. The annual demand is given. One more thing. Sometimes what happens is the holding cost, the CH value, your holding cost per unit per year, sometimes they are giving in percentage of unit price. Like in this case, inventory holding rate, that is CH, they are giving you 25% of unit price. That means this is unit price, that is C. So 25% of 10 rupees or 25% of 9 rupees, that will be. So whenever they are giving the examination, they are giving percentage of any value. That means by default they are talking about the holding price, or holding price is always equal to percentage of unit price. Okay, fine. Chalo. This is the annual demand. This is the ordering cost. This is CH. The price quoted by the supplier is, they are asking you what should be the price quoted by the supplier. Acha, price quoted by the supplier is this one. They are asking what is the optimum order size in units. What should be the optimal order size? Optimal order size means the cost is minimum. How we can, they are giving you two ranges. Less than 500, unit price is 10. Greater than 500, unit price is 9. So always we start with the least unit price. This is the least unit price, right? So I can say that for the range of greater than equal to 500, having a unit price of rupees 9 per unit, can you calculate economic order quantity? Sir, this is 2D CO by CH, root of this. So this is 2 into annual demand is given as 2500. Ordering cost is given 100. CH is given how much? CH is 25% of unit price, 0.25 into 9, root of this. What we are getting? Sir, we are getting 471. Perfect. 470, approximately 471. 471.4. Yes. 471.4 units we are getting. Okay. Yes, everyone. 1 second, guys. Everyone, are we getting 471? Chalo. Right? Now, we are discussing about a range of Q greater than equal to 500 and we are getting Q sir is equal to 471. Is this a feasible range? We can take 9 rupees only for an order size of greater than equal to 500 and we are getting Q sir that is 471. So that is not a feasible. It is not feasible. It is not at all feasible. Okay. On one hand, you are saying you have to purchase 5 items, then only will be getting the discount. You are only purchasing 2 items, then how will you be getting the discount? It is not a feasible range. So once you are getting this, you have to now go for the next range. That is this one, the second range over here. That is Q less than 500. For this, the unit price is how much? Rupees 10 per unit. Right? Okay, rupees 10 per unit. Now for this, let us calculate the value of Q star. 2D CO by CH under root of this. So 2 into 2500 into CO value, how much CO? 100. CH is 25% of unit price is 10. 0.25 of 10. How much you are getting? You are getting 447.21 units. 447.21 units. Okay. Now this is feasible because we are dealing with a range of less than 500, which is a feasible range. So definitely it is a feasible. So let us try to calculate what is the total cost, because it is an EOQ, which is a feasible. So we can say this is nothing but purchase cost, that is D into C plus the total limited cost in the EOQ. So D into C plus under root of 2DCOCH. So annual demand is how much? 2500. Unit price is 10 under root of 2 into 2500 into 100 into 0.25 into 10. Okay, can you help me out with the value? How much cost we are getting? Total cost at EOQ, at the minimum cost that we are getting. Anyone? 26118 26118 rupees. Please do check, everyone. Are we getting? Shares is saying 26,118. Might be correct. I'm not sure. Yes, everyone. 26118. Farinder is also confirmed with the same value. Okay, perfect. So this is the total cost that is being associated if you are ordering 447.21 units. Right? Okay. Let us try to cross check. If you order exactly 500, what will be the total cost. That means when you are ordering exactly 500, what will be the total cost? Now, this is, do I need to use that EOQ formulation or do I need to use that any order size? Which formulation do I need to use? EOQ formulation or any order size? If I want to calculate the total cost associated with 500 units, exactly, we have to go for any order size because it is not an EOQ. We are calculating when you are placing an order of 500, which is not at all an economic order quantity. So that will be D into C plus ordering cost is D by Q into CO plus Q by 2 into CH, right? Orders, annual order is 2500. Now for this C value was how much? Rupees 9, I think. It was rupees 9, I think, yeah, rupees 9. Yeah. Into 9 plus 2500 by 500 into CO is 100 plus 500 by 2 into CH is 0.25 into 9. Okay, let's see what is the total cost for 500 units. Are we getting less than that of EOQ, more than that of EOQ? If we are getting less than that of EOQ, then this is the best order size. We are getting 23562. 23562 rupees. And definitely the total cost associated at 500 is less than the total cost that we are getting at EOQ. That is how much? 447. Right? Sir, why this happened? This basically happened because, and your final answer is 500. Answer is 5. So we can say the optimal order size will be equal to 500 units. This is your final answer. This is your final answer. Okay. Now my question is, sir, why this happened? Normally we are saying that EOQ is the minimum order size. It is only applicable for one order cost, ordering cost. Okay. If you are changing, not ordering cost, unit price. If you are changing the unit price, if you are offering some discount, then we always need to check at the threshold value. This is the threshold value. This is the threshold value. So if you try to plot the graph, what actually happened over here, let us try to understand. Cost. Sir, if TIC star is more than no, we have to go for optimal, right? We have to go for optimal order cost. Optimal order, we have to place an order for an inventory. So I am getting the least price. I'm getting the least price 23,000, right? Here we are having 26,000. I'm getting 447. Here we are getting the total cost associated with 500 is less than that of this. So that is the reason optimum order is 500. Okay. If TC star is having lesser value, then 447 will be the answer. Correct? I think Farinder has given me initially opposite way. If TC star is having a lesser value, then definitely your answer will be correct. Okay, then you have to, every time you have to cross check. That is the reason there are very less chances that discount model will be getting in the gate examination. You will be getting in either in ESC conventional, only feasibility. Okay, you have to calculate EOQ, then you have to check the value, you have to compare the value at the threshold one also. Then only you will be able to come to the conclusion that whether your answer you are getting at EOQ or at the threshold value. Okay. Now what happened is when you ordered for 10 rupees, okay, that is less than 500, something like this. Its EOQ was feasible. Let's say this is 500. Okay, and for this EOQ was 447, which was feasible range. This is, I'm talking about this one. The black color is for the first range, that is Q less than 500. Okay. Now what happened when I went for the discount? The discount will be something like this. Now for the second range, that means for this range, we were getting an EOQ at a non-feasible value, that is 471. So if I try to draw, it will be something like this. Okay, it's not linear. Fine. So it was somewhere around 471, which was not feasible. That is the reason we were not able to get that minimum. Let us suppose if this would happen, you calculated EOQ for the least one, and this you are getting 571 instead of 470. If you are getting 571, which is feasible, then no need to check anywhere else. That is the final answer. Okay. If you are getting, let's say instead of 471 you are getting 571, that is feasible. So for least price we are able to get an EOQ, that is a final. No need to check at the threshold, no need to check at anywhere else. Okay, fine. Because it was not feasible, we checked at the next cycle, then we have compared that total cost. Fine. Is this clear? So here if I try to visualize, here we are getting how much? Here we are getting 23,000, somewhere around 23k. 23k. Here we get 26k. Here we are getting 26k, right? Okay. If let us suppose, if you calculate, you can do cross check. If you calculate, if you put Q equal to 471 for this unit price, definitely it will be less than 23k. You can cross check over here, which is not feasible basically. It will be less than that of 23k. Okay, fine. Is this clear? Understood? Done. Why we are getting the final answer is 500 units. That's the final correct answer. 500 units is the final correct answer. Perfect. Very good. Okay. So this is all about the discount model that we have seen. Right? Okay. Done. Now let's proceed to the third model, that is the production model or manufacturing model. Some textbooks will be giving you manufacturing, some texts will be giving production, because here we will be manufacturing the inventory in-house. So here we won't be having ordering cost, we'll be having setup cost, but no problem, setup cost and ordering cost both are having the same meaning. Now let's complete production, then we'll be going for lunch break. Let's complete production. It hardly take 20-25 minutes. Then at 2:30 we'll be giving you a lunch break. Then we'll be completing the next set of from shortage, then forecasting, queuing model, transportation, LPP, very important, linear programming. Then after that I'll be giving you 15 minutes break. Then transportation assignment, right, this way. Okay, production model. In this case, what happens? The inventory is not being procured from outside. We are manufacturing or production in-house, right? We are manufacturing production in-house. So here we will be having some additional parameters which will be differentiating from our basic EOQ model. Okay, fine. Chalo, let's do one thing. Let's try to draw the graph, because we already know the basic EOQ model graph. You already know the basic EOQ. This is time. This is inventory. Okay. Now what happens here? We are manufacturing the inventory in-house. Okay. So definitely what will happen? We won't be manufacturing for the one complete cycle. Like let us suppose if your demand rate is let's say 6 units per day. So what will be the product? P is the production rate. Production rate. So can you tell me production rate will be more than 6 or less than 6? Anyone? consumption, daily consumption rate is 6 units. So how much will be manufacturing? More than 6 or less than 6? Anyone? Definitely, sir. It will be more than 6. It will never ever will be less than 6. The reason being, if you are keeping less than 6, then what will happen? Requirement is 6 units. You are only manufacturing 4 units. So every day will be having a shortage of 2. So in order to remove that possibility, we always have more than this. Let us suppose I am keeping this as 10 units per day. Okay, I will be using the same value to understand this graph also, right? Now, let us suppose production will be happening from starting day from 0, right? So it will be increasing, and it will be going on till the requirement, right? So definitely I'll be manufacturing whatever is being required for one cycle. Let us suppose in one cycle I require 30 units. I require 30 units in one cycle. Okay. So definitely I will be 30 units, so 3 दिन में खत्म हो जाएगा. Let's go for 100 units. That will be much more beneficial for us. Okay, now okay. So tell me, if you are manufacturing 10 units per day and the requirement is 100 units, this is the requirement. So can you tell me, I need to stop the production by how many days? This is 100. Because 100 is required. So I'll be doing production for how much number of days? Quickly. Time of production will be simple, sir. 10 days we have to manufacture. 10 days we have to manufacture, right? So we can say, or let us do it, let us take it as 60, because that will be much more easier to analyze. Anna? So it will be now 6 days. So can we say this is the production time, small tp, this is the time of production. TP is the time of production or production time. That means I have to manufacture for 6 days, then my problem is solved. Chalo 100 ही ले लेते हैं. Let's take it as 100 because that will be much more convenient for us. Chalo 100, 10 units because we are taking 10 now. Right? So for 10 days I have to manufacture. After that, whatever surplus is there will be carried forward and it will be consumed. So now this is the production rate and this is the time of production. So this is the maximum value. Now consumption will be happening like this also, right? So this is the consumption rate D, right? D. Okay, can you tell me after 10 days, because this is 10 days, right? This is 10. After 10 days, how much production, how much consumption is being done? Anyone? After 10 days, how much consumption is being done? 60. Very good. 6 units per day, 60 is being consumed. So how much inventory will be there with me? Over here 40 will be there with me. 100 was total, 60 consumed at a rate of 10 units per 6 units per day, 10 days. So can we say 40 will be there? Perfect. So that 40 that was being left out will be consumed in the next. So this particular point, from this point to this point is one cycle. From this point till this point is one cycle. Are you able to see this? 1 second. Yep. Now I think you're able to see this, right? From this point to this point is your one cycle. Okay, fine. Chalo. Right? Now, every day, how much unit is being stored? Can you tell me? Every day, how much unit is being stored? Sir, 10 is being manufactured, 6 is being consumed. So on daily basis, how much we are storing? Can anyone who can tell me? 4 units we are storing daily basis. Right? So after 10 days, how much will be left out over here? After 10 days, sir, 4 per day. So 4 into 10, 40. I think that same calculation we have done in an opposite way also. Okay. So this is P minus D. This is P minus D, right? So actually, in reality, I don't have to store 100 units. Maximum inventory level will be quite less than that of 100, which is 40 in our case. In basic EOQ, we have to start off from 100 to 0. Now that is not our problem. Now we have to store only this, right? So I can say that if I say this is your maximum, this is your actual inventory level. Okay, this is your Q, this is your maximum inventory level that you have to store. Okay, this is the total value that we have to make, that we have to produce, total that we have to produce, right? Okay, is this clear? So now if I try to remove everything and if I try to draw only that triangle, will it be easy now? Because the background, what was happening, we have already discussed this. Okay, so we are having this as the storage, then we are having the consumption. This is one cycle. Okay, next cycle. Okay, so this is one cycle, then next cycle. This way the cycle will be going on. This is P minus D, this is P. This is the maximum inventory level, right? This is QM, let's take it as Q maximum. Okay, the maximum inventory level, maximum inventory level, Q max, right? Is this clear? This is your TP, right? This is your TP, and let me draw it over here. Okay, clear, right? Half an hour. Done. Now we have to analyze what will be our formulation for this, right? Now we have to analyze what will be the formulation of this, right? Okay, clear hai? One second guys, some background. Done. Which one? Please do have a look. Oh, this one is one second. This one is D, not PE. This one is D, because that is a consumption rate, right? I think the same I have written over here. D and D, right? Is this clear? This is D only, consumption rate. Any other doubt you are having, please have a look, because now we'll be going for how we can calculate the your ordering cost, your holding cost, right? It is very important because that's the only thing being left out. Rest everything is being done. Okay, chalo. So now let's try to understand how we can get the formulation. Now we know that this is Q maximum. This is, let us take it as Q. This is Q. I think we have taken it as Q. No, this is QM. That is Q max. This is Q. Right? Take it as Q only. Because in reality, 100 units is required for one cycle. Okay, chalo. Now, if I try to talk about the purchase cost, it's still remaining the same, annual demand into unit price. There is no change in that. Purchase cost, no change in that. What is the ordering cost? Here we are not having an ordering cost, we are having setup cost. So this is one setup, this is one cycle, then we are having the next cycle. So every cycle we are having, we can say number of cycles will be repeated, will be this one. This is one cycle, right? So we can say the setup cost, I am denoting it as OC, number of setup, right? So D by Q into CO, we are having exact same formulation. CO now resembles the cost per setup D is the annual demand, and in one cycle we are actually consuming Q units. In total, in reality, we are consuming 100 units only, because 100 units being manufactured, we are consuming in one cycle, right? So D by Q into Cu is the ordering cost. Perfect. Now we have to understand what will be the holding cost. Okay. Now, what is the holding cost formulation? Sir, holding cost for T period, same formulation, but here now some changes will be there. T period will be equal to average inventory into cost per unit per time, holding cost per unit per time. Okay, fine. Now here, are we holding Q by 2? Are we holding Q units? Yes. Or are we only holding till Q max? In reality, in one cycle, the maximum inventory that we are holding is Q max, not Q. In basic EOQ, Q max and Q are same, so no problem with that. Here, the actual, in reality, we are only holding this much of level of inventory, which were in our case was only 40 units. Which in our case was only 40 units, right? We are not, 100 units is not required to store. We only need to store only 40 units, and that is self-sufficient. So here also we can say it is QM by 2 into CH into T. QM by 2 into CH into T. Okay, average is 0, maximum is Q, minimum is 0. Exactly. But here QM and Q are not same. I have to create a relation between QM and Q. Now here can we say Q is equal to, this is your production rate P, right? So Q is equal to P into TP. Can we write it like this? Q is equal to, production rate is P into TP is the production time, that will be landing up with the capital Q value. Simple formulation, there's a straight line, P is the production rate. You can use this formulation over here also. Q is equal to P into TP, right? P is how much? 10. TP is 10. So maximum production level is 100. We are getting 100 only. Okay, fine, exactly. And if I want to calculate QM, QM is equal to P minus D into TP, will be giving you the maximum, this one. If I take the ratio of this, I can say QM is equal to P minus D by P into Q. Yes, if I take the ratio, I can say the maximum inventory level is equal to P minus D by P into Q. Yes or no? है ना? So let us try to place this value over here. So this is equal to Q by 2 into P minus D by P into CH into T, right? This is for one cycle. So if I want to calculate the annual holding cost, that means for n number of cycle, and we have already seen n into T is equal to 1. So annual holding cost will be equal to Q by 2 into P minus D by P into CH. This is the annual holding cost. Okay, n into T is equal to 1. So I'm skipping up that particular step. So this is the annual holding cost. So now I can say for any order size or any production size, the total annual cost is equal to purchase cost plus order setup cost plus Q by 2 into CH into P minus D by P. This is the total annual cost for a production based model. Right. Now, if I want to calculate for EOQ, for economic order quantity, the total cost, if I try to differentiate with respect to Q, make it equal to 0. If I try to differentiate, we are getting Q star is equal to exactly same 2dCO by CH root of this into one more factor is coming, that is P upon P minus D. This is the economic order quantity for a production based model. P upon P minus D. Is this clear? This is the economic order quantity for a production based model. Clear? 2dCO by CH into P upon P minus D. You can differentiate, you can cross check. Right? Similarly, we can calculate what is the, this is being done, total inventory cost at EOQ. That is also coming out to be 2dCOCH under root of this into under root of P minus D by P. Okay, fine. Now you will be having some doubts when how to remember the formulation. Dekho, definitely production model will be better than that of basic Q. That is the reason they have formulated, or they could have been discarded this particular model. Now if I rewrite this Q star, okay, let me do one thing. Let me write for production for basic EOQ. Let me write for basic EOQ. Okay, and you will be able to visualize what is the basic difference. Your Q star is equal to 2dCO by CH, and your TIC star is equal to 2dCOCH. There's a way to remember this, right? For production model, I can say Q star is equal to 2dCO by CH into P upon P minus D. Now tell me, P upon P minus D is greater than 1 or less than 1? This value is greater than 1 or less than 1? Tell me. P upon P minus D will be having a value greater than 1 or less than 1? Definitely this will be greater than 1. And we know that if you're having a larger order size at low cost, that is much more beneficial. Okay, so definitely we can say the Q star for production for all the same values is more than that of Q star for basic EOQ. Right? That is the reason we have formulated, or else we could have been discarded this particular model. Okay, same goes with the TIC also. 2dCOCH. Acha, tell me one thing, that cost should be less or more? If I want to have cost should be less or more, definitely should be less. So I have to multiply with a factor which is less than 1. That's it. This is a way to remember the formulation. So TIC star is equal to 2dCO by CH into P minus D by P, a factor which is less than 1. And this factor we call it as production factor. This factor we call it as production factor. This is a way to remember TIC star for production is less than that of TIC star for basic EOQ. This is a way to remember the formulation, or else what will be, there are lot many formulas you won't be able to recall. So a simple trick to remember the formulation. Okay, fine. Is this clear? Understood the production model? Okay, fine. So we are left out with one shortage model in inventory. Then we'll be going for the next topic. So let us take a break of let's take a lunch break, right? Then we'll be starting with the shortage model. Okay, fine. So how much time you require? Now we're going for the lunch break. Okay, and the class will be resumed 15. Okay, let's take 20 minutes. 20 minutes more than sufficient. Let's take a lunch break of 20 minutes, and we will be resuming at 2:50 p.m. Indian Standard Time. Okay, right? Okay, so let's Meet at 2:50 with more energy, and let's have a quick recap also, right? Fine. Okay, so we have just given break at 2:30. We'll be meeting at 2:50 p.m. Indian Standard Time. I think after break we'll be continuing for 4 hours at least. The reason being, we are having one big topic, linear programming. It take at least 1.5 hours, minimum 1.5 hours, because simplex is gonna take slight time. Okay, so we'll be resuming at 2:51. 1 minute is being consumed. I guess let's precise. Okay, fine. Chalo, let's take a break and let's resume our classes. No problem. I'll be having quick revision for the 9 minutes, and it will be resume exactly at 3 p.m. Okay, don't worry about that. Right. Thank you. Let's have a quick break. Then let's meet at, okay. Chalo, 3 p.m. Let's round off this value. Let's meet at 3 p.m. Okay. You can also take a break and let's try to meet. Right. Chaliye, bye guys, and let's resume our classes at 3 p.m. Thank you. Okay, I think let's continue with our discussion. है ना? Okay, let me check from my end. All good. Please do. Could you please let me know all good with audio and video? Yes, I think all good, right? Chaliye. Let's continue with our discussion. Thank you, Arikesh. Let's continue with the discussion. Till before the lunch break, we have completed the production model. And we have completed the production model. Now let's continue with the next, the last topic of the EOQ model. That is your, we can say, shortage model, right? Okay. Before starting the session, please do clarify. All good? Yes, all good. I think, right? One second. Let me place my mobile over here so that I see the comments. All right. Chaliye. So let's continue with the discussion. Now let's talk about the next model, that the fourth model, I think, that is a shortage or stock out model. Shortage or stock out model. Now, till the last model, we were not discussing anything related to shortage, what will happen if you're having some shortages also, and that is not being essential or required also, right? So now we will be providing some shortage to our inventory, and what will happen if you're having some shortage. So definitely, just like in production model, we are having one additional parameter, that is the production rate, that is small p. Rest all the parameters were the same as that of the previous BOQ model. So here also in shortage model, we'll be having one parameter, we call it as the back order model, that is CB, that will be used. Rest all the parameters will be saying, and again I'm repeating, it is almost the similar of that of basic EOQ. Almost similar. Okay, even the graph is also similar, slight difference in the x-axis, rest all the things are same, right? So let's see what is the shortage or stock out model or whatever. This is basically similar to whatever we are having. Okay, so let's do one thing. Let's try to draw one graph. Let's try to see what is the meaning of this one. Okay, so we are having one inventory level, that is Q, and it is going on till it is becoming 0. This is the x-axis, right? That is time, right? And after that, we'll be having some shortages. Then again, it will be going back to the maximum level, that is Q. Then again, we'll be having the shortages, and this way, this particular graph will be going on repeating, right? So here, if you try to visualize, this is your capital Q. I'm assuming this to be capital Q from this point to this point. Okay. Now, if I try to see, this is the point where the inventory is becoming stock out, and this is the duration of time till which the inventory is remaining in the stock out or the shortage, right? This is the time duration in which I am holding the inventory, right? And this is one complete cycle, that is TC. So we are saying that this is entirely similar to that of the basic EOQ. Only thing is x-axis is being shifted, right? So here the inventory will be holding will be taking place, and here we'll be having a shortage of the inventory, right? Let us suppose the level of inventory which is being short, I am assuming this to be capital S. Let us assume this to be capital S, right? Okay. So can we say the maximum inventory level? What will be the maximum inventory level? Maximum inventory level, I'm denoting it as capital M, that is equal to Q minus S. Yes, can we say the maximum inventory level, that is capital M, is equal to Q minus S, right? And we are holding the inventory only for that T1 duration. Let me write it over here also. T1 is the duration the inventory is holded. Inventory is holded, right? And T2 is the duration where shortage of inventory is happening. Shortage of inventory is happening. Okay. Fine. Now, if I try to see, this is the consumption rate, that is small d, that is the consumption rate, and there is one complete cycle, and after that, the next cycle is being started, and this will process will be going on. So here also will be having same as the purchase cost will be same, that is the annual demand into your unit price, that is C, and annual demand into C. Your ordering cost will be exactly same, that is D by Q, because one cycle is starting from this point and till this point, and I'm assuming this to be capital Q. So D by Q into CO will be giving you the ordering cost. These two are remaining the same, right? But here there are one more additional cost is coming into picture along with the holding cost, that is a shortage cost, right? Okay, now if I try to see, the inventory is having stock over here, so here we are having a shortage, that is capital S and that is capital Q, and this is your M is equal to Q minus S, right? Exactly. Now here if I try to write the holding cost, let us first of all calculate the formation for the holding cost, because only change will be observing in the holding cost. Now here if I try to see what was the holding cost formulation, it was equal to the average inventory, right, into cost per unit per time, right? Okay, the holding cost was equal to average inventory for let's say T1 duration into this. Now if you try to visualize our inventory, the maximum inventory that we are getting over here is how much? That is Q minus S. The maximum inventory that is being stored, that is equal to Q minus S. So I can write this is Q minus S by 2 into CH into, now we are holding only for T1 duration, into T1. In the previous case, we are holding for the entire duration, that is capital T, but here we are only holding for the duration, that is T1. We are not holding for the entire duration, because after T1 in T2 we are having actually the shortage, so we will be only holding from 0 to T1, right? Okay, so I can say that Q minus S into CA, this is the holding cost for T duration, for T1 duration, right? Or D, or we can say T1 period. Right? Hello? Any doubt in this? We are just having just exactly replica what we have discussed in the previous one. That's it. Now I want to remove this T1 and I want to write in terms of capital T, that is cycle time. Now if I try to see over here, let's say this is T1 and this is T2, right? Can we say that this is the your consumption rate? Can we say Q minus S is equal to D into T1? Q minus S is equal to D into T1, and Q is equal to D into capital T. Let's say this is capital T, right? From this point to this point is your capital T. Okay. If we're trying to take the ratio of this, so I can say T1 is equal to Q minus S by Q into capital T. Capital small T1 is equal to Q minus S divided by Q into capital T. So if you try to place it over here, so I can say this is Q minus S whole square by 2Q into CH into capital T. Because capital T, why we have to convert from small t1 to capital T? Because capital M into capital T is equal to 1, not T1 into T, or T1 into N. Capital N into capital T is equal to 1, right? So this is for T1 period. Now if I want to calculate annual holding cost, so I can say this is Q minus S whole square by 2Q into CH into T into N, because N number of times this cycle will be repeated, and we know that this is always equal to 1. So holding cost is equal to Q minus S whole square divided by 2Q into CH. So this is the holding cost that we are getting. Okay, approach is same, only thing we are now having the differences with the formulation. Right. So here also one more cost will be coming into picture, that is shortage cost. Shortage cost, that is SCH. Okay, or S, let me write it like this, shortage cost. Okay, so I can say here also shortage is depending upon time. If you try to remember what was the formulation, this was equal to the average inventory short into your shortage cost per unit per time, right? Okay, now if I want to calculate shortage cost, so shortage cost for T2 period, so what is the average inventory short? Anyone can tell me what is the average inventory short? Here the inventory short is 0, the maximum is S. Can we say average inventory short will be capital S by 2? Yes. Here the average inventory that is equal to the inventory that is short, that is equal to 0. Here it is increasing and it is going till S. So can we say the average inventory will be equal to S by 2 into CP into T2, where CB resembles the shortage or back order cost per unit per time, right? So here also we have to convert this T2 from T2 to capital T. So we can say over here capital S is equal to small d into T2. If you take the ratio, we can say T2 is equal to S by Q into capital T. So placing this value over here, I can say this is S by Q. So you'll be getting the shortage cost is equal to S square by 2Q into CB into capital T. So I can say shortage cost or annual shortage cost will be equal to S square by 2Q into CB into T into N. N into T is equal to 1, so no need to write. So this is the shortage. So I can come to a conclusion that the total cost that is equal to purchase cost plus ordering cost plus holding cost plus shortage cost, right? So I can say this is D into C plus D by Q into CO plus Q minus S whole square by 2Q into CH plus S square by 2Q into CB. So this is the total cost associated with a shortage model at any lot size. This is at any lot size. It's not at EOQ. For EOQ, we'll be differentiating with respect to Q and make it equal to 0. When you differentiate, differentiation will be slightly complicated. So I'll be giving you the direct results. So economic order quantity at economic order quantity, that is equal to, now easy way to remember, just like we have remember for the production model, here also we will be taking one very basic understanding, that is 2DCO by CH. One second guys. Under root of this into CB upon CB plus CH. Okay, one second. CB plus CH by CB, root of this, right? So just like we had in case of production model, we had P upon P minus D, a value which is greater than 1. So here also we have to multiply with a factor which is greater than 1. CB upon CB plus CH, right? And the TIC star is equal to 2DCOCH. This value should be less than that of the basic EOQ. So this is CB upon CB plus CH. Okay. So this way we are able to come to a conclusion. In GATE examination till date, I think they have not yet asked a single question from this topic, but yes, you can have a basic understanding. That's it. because that is in your syllabus, so we are discussing this, right? But usually they won't be giving you this much of complicated. If they're asking, then you have to have this formulation. This formulation must be remembered. And that too, they'll be asking you the basic EOQ. They'll be asking you the economic order quantity for a shortage based model. That is, this formulation will be they could ask you. Okay, is this clear? Understood? Now here, one more parameter that we can identify, what is the optimum number of units that should be short, because definitely if you're making a shortage, right, so I have to identify what should be the optimum units that should be short. So we can say, what is the optimum units short? That means I have to calculate the value of S star. Just like we have calculated what is the inventory level, that is Q star. So here also we have to identify what is the optimum units being short. So for identifying or for calculating this, it's a very easy technique. Now, can we see Q star minus S star into CH? This will be your approximate holding cost. If I divide by 2, this will be the holding cost, and is equal to S star into CB by 2. 2 and 2 get cancelled out. So by using this formulation, I'll be able to calculate what is the value of S star, right? So if I try to divide with this one S star, so it will be having Q star minus S star divided by S star is equal to CB by CH. So this is Q star by S star is equal to plus 1 CB plus CH by CH. So from here I'm getting one very interesting formulation, that is S star is equal to Q star into CH upon CB plus CH. So this is the formulation to calculate the optimum units that need to be back ordered, need to be short in order to get a maximum profit. Okay, so this much of units should be short. If you are going for the shortage model, this is the optimum units that must be short, that must be stock out, right? So if I want to calculate what is the maximum inventory level, so M star is equal to Q star minus S star. So placing it over here, you will be getting CH will be cancelled, that will be equal to Q star into CB upon CB plus CH. So this way I'm able to calculate the value of the optimum maximum inventory level, right? So these are the two formulations to calculate. Really, once in like in 2001 question was asked from this particular formulation. Okay, so after that they have not yet asked, but still definitely it's ISC Bangalore, so they can expect some unique pattern of questions in their paper. Okay, fine. So this is all about the inventory model, the basic EOQ, production, very important, production, basic EOQ. These two are mandatory. You have to revise at least one question from each, and all rest of the inventory models is more than sufficient, right? Only overview knowledge is sufficient enough. Okay, so this is all about the shortage model that we have discussed. So now let's begin with the next topic, very interesting and important one, that is linear programming. Okay, right? So shall we begin with the linear programming? Chaliye. Now linear, the word linear means it won't be having any quadratic equation or a hyperbolic or cubic equation. Linear means we'll be having to the power 1. Okay, so here what is a basic objective of using the linear programming is, remember one thing, industrial engineering basically means optimization, best solution, highest profit, least cost. So these are 3-4 objectives that you always need to remember. Okay, so linear programming, what we are basically doing, let us suppose if you are having some set of solutions. There is one problem and we are having some solutions present in the linear programming problem. Out of these solution, my question is, which solution is the best solution? That particular approach is being discussed under linear programming. Okay, if you're having various, let's say we're having 8 solutions with me, or 8 or 9 solutions with me, out of this 8 to 9 solution, which solution will be best solution? If I want to analyze, let's say this is the best solution. So how we can identify this best solution? For that only we are using this linear programming problem. And it is having a wide range of applications. It is being used in supply chain management. This is a very important concept we are using in supply chain management, okay, which is a very important topic for any management candidate. Right. Even I can say that we are using this in to make a diet chart. Like if you want to make a diet chart, right, which nutrient, how much amount should be there, how much will be the best combination, we can definitely use this linear programming to plan a diet chart, right? Okay. Or if you are talking about a transportation problem, if you are having multiple ways to transport a product, what could be the best possible way to transport an item to the different states, we can definitely go for this linear programming, which is basically we have already discussed, that is supply chain, right? Okay, fine. So understood what's the basic idea. So here the only constraint or only problem with this linear program is your functions, whenever you are creating any relation between the two unknown parameters, it should always follow a linear variation or linear variable. It should not be having a quadratic equation. It is only being restricted to linear programming. And you will be surprised to know that linear programming we are using in different analysis, like data analytics also we are using linear programming, regression analysis. These are the different commonly used tools which is being used to optimize the results. Okay, so definitely if you are studying this linear programming, you can definitely have a better understanding to other topics also, right, if you are planning to go for a management side. Okay, but if you see this year data analytics and AI paper is being introduced, so they are much more inclined towards optimizations. You can expect a question from linear programming this year. Surely we can expect one problem, and that too definitely, you know, it will be coming from Graphicon only. Okay, so linear programming problem, it is an optimization tool that we are using whenever we are having limited resources. Okay, so it is used for the optimization of the limited resources when there are number of alternate solutions possible for a problem. We are having less resources. Among the less resources, we are having, let's say, 10 solutions possible. So definitely I need to identify the best solution, because already I'm having the lack of resources. Among that lack of resources, if I'm able to identify the best solution, that is the best possible way to increase or best possible way to optimize our results. Okay, and linear programming problem is one of the tool to optimize our limited resources when the many solutions are possible. Okay, fine. Now in linear programming problem, there are basically 3 requirements to create any LPP problem. We call it as LPP, linear programming problem. To create any LPP, we always require 3 inputs, or 3 basic requirements are required. What are the requirements? The first one is objective function, which is denoted as capital Z. Now objective function, what do you mean by this? Now either you will be maximizing the profit, okay, either you will be maximizing the profit or you will be minimizing the losses or cost, hai na? Are you gonna go for any tool which will be maximizing the loss? Definitely you will be going for the opposite of that. Okay, you always want the profit to be maximum or the loss to be as minimum as possible, right? So objective function is one of the requirement to create a linear programming problem, which is basically denoted as capital Z. Okay, so here now you are getting a basic idea. Either we'll be dealing with a maximization problem or a minimization problem. LPP either will be discussed a maximization or minimization, that's it. Okay, fine. So once we are dealing whether it's a maximization or minimization, and objective function is that function which we need to optimize. This is the function which we will be optimizing. Okay, this function will be optimized, right? Now because we are talking about in this case we are having x or y or even z also, right? These are the different variables that we are having. Okay, so in order to have these variables, there will be some constraints or limitations will be there. Let us suppose if I want to manufacture this pen, definitely will be having some constraint with some of the resources. It's not like this, we will be having the abundance of resources. You will be procuring limited resources because every resource is gonna have some cost associated with that. So you won't be able to procure all the different raw materials. We will be having some limited resources. So among that limited resources, what could be the best possible way to optimize our results? So that is basically we are using LPP. And the second requirement is to create the constraints. What is the limitations? What is the conditions? Constraints means we are talking about restrictions or conditions, right? Okay, let us suppose in order to make this pen, one of the raw material is required is an IC, integrated chip. So a restriction is you can only procure 3 chips in a day. You can only use 3 chips in a day. So the maximum limitations is you can only manufacture 3 pens. If I am using 1 chip in 1 pen, so definitely we are bound to restrict the manufacturing of a pen by 3. So this is one of the constraints that we are having, right? And the third and the final one is all the variables that is being used in the objective function, it should be definitely a linear and a non-negative. That means x or y or z should always be greater than equal to 0. It should always be a positive value, right? It's not like this, today I will be consuming minus 10 calcium. Not possible. Either 0 or greater than 0, right? Or they'll be saying that to manufacture this pen, I'll be using minus 1 IC. How you can use a minus 1? Okay, either 0 or 1 or 2, 3, 4, a positive value, right? Okay, so these are the 3 requirements for creating any linear programming problem. Right? Now, there are 2 different ways to solve any linear programming problem. There are 2 ways to solve linear programming problem, right? One of the way is graphical approach. Important hai exam ke liye, graphical approach, a graphical method. And second one is a simplex method or simplex approach, right? Graphical and simplex. Now, if I want to make a graph on a piece of paper, how many variables will be required? If I want to go for a graph on a piece of paper, how many variables will be required? 3, 4, 5, 2, 1. If you want to make an 2D graph, how many variables? 2, x and y, or x1, x2, y1, y2, like this. So only restrictions that we are having with the graphical approach is we are bound to use only up to 2 variables, because graphical means we have to make a graph, so only we can use 2 variables, that's it. You cannot go for more than 2. If you are going for 3 variables, let us suppose, you cannot make a graph of x, y and z on a piece of paper. It's very difficult. Yeah, by using softwares we can go for that, using MATLAB you can go for that, but by using a piece of paper you cannot plot a 3D curve, you cannot plot a 3-dimensional graph. So in graphical approach we are bound to use only up to 2 variables. Simplex method, definitely the disadvantage that we are having in graphical will be solved in simplex. In simplex we can use n number of variables, there is no restriction. We can use 10, 15, 20. And simplex method is an iterative approach. That means we'll be using softwares in order to run the coding, right? Okay, but definitely we'll be using some basic examples in order to understand simplex by using 2 variables, so that you can have a better understanding, or 3 variables also. Okay, so more than 2 variables if you're having, so we are bound to use simplex. If you're having 2 variables, then you can use graphical also, simplex also, but definitely you'll be using graphical, because simplex is slightly tedious approach. It takes time to solve. So 100% you won't be getting any question from simplex. If they're gonna ask you any question from simplex, it will be some intermediate steps in the iteration, right? So don't worry, I'll be solving one question in the live session, so that you can understand what are the different steps being associated in the simplex method, so that if they are asking any question in between the steps, you can easily solve it. Because there are some parameters from where they can directly ask, they could ask you what is a exiting variable or inlet variable, or what is a pivot element. This kind of question they can expect. And they'll be giving you a table, they'll be asking you whether this solution is optimized or not. You can expect that. Okay, Fine. So before going for simplex, we have to understand what is a graphical method. So it's quite easy. Here you'll be having two restriction is two variables, and we'll be having one objective function, and based on that we'll be plotting a curve, and we'll be able to identify the feasible region. And the corner points of the feasible region will be giving you the multiple solutions or different solutions, and among this which is the best solution will be able to analyze by putting this individual values in the objective function. That is the best way to understand the graphical method, right? Let us take one example. Let us take one example. We are having a maximization problem. Okay, we have to maximize 2x1 plus 5x2. Two variables are there. These three are the constraints. These three are the constraints, and this one is a non-negativity criteria, right? This is our objective function, right? So you can clearly see that all the three requirements being fulfilled. We are having an objective function, we are having a constraint, we are also able to fulfill the non-negativity criteria, which was the three requirements to frame any LPP, right? Okay, so now to understand this graphical approach, it's very easy. You have to just convert our linear equation, the constraints, into an intersect format. Okay, fine. Now let us suppose if I'm having a equation like this, x plus 3y is equal to 9. So I can write it as x by 9 plus y by 3 equal to 1. I can easily plot this graph over here. This is 9, this is 3, join this. That's it. This is x and y. Very easily we are able to identify. But linear programming problem always deal with inequalities. You can clearly see it is less than equal to, less than equal to. Whenever we are dealing with maximization problem, maximum chances are that we will be getting a less than equal to function. Okay, right? So what we'll be doing, we'll be converting this into an intersect format. So we'll be having x1 by 40 plus x2 by 40 by 3 will be 13.33, less than equal to 1. First constraint, right? We have written this first constraint. Second constraint can be written as x1 by 8 plus x2 by 24 less than equal to 1. And third constraint can be written as x1 by 10 plus x2 by 10 less than equal to 1. So we have written all the three constraints in the intersect format. So once you are done with this, now you will be plotting the graph between x1 and x2 at the different regions and try to identify the feasible region in this. Okay, so let's try to draw this diagram. And you have to go for the rough diagram, right? You don't have to use a scale or pencils to draw this. You can go for a rough sketch only. Now, this is your constraint number 1, which is having an x1 and x2 intercept as 40 and 13.33. Let's say this is 40 and this is 13.33, right? So if I try to plot the first curve, it will be something like this, a straight line. And because this is less than equal to means all the values which is closer, which is near to origin, towards origin, will be values that we have to take. Okay, all the values. This is, and always write the constraint number in order to, because sometimes we will be going for the intersection of the points. So if you are going for more than 3 constraints, now it's very difficult to identify which is the intersection of which line. Right, so this is one. Second is 8 and 24. 8 and 24. This is 8 and this is 24. Okay. Okay, so 8 and 24 somewhere around here will be the constraint number 2. Okay, the last one Let us use a different color. Yeah, let's go with this one. 10 and 10, somewhere around here we are having 10. This is 10, so 10 and 10. Okay, and always we have to take only the first quadrant, because x1 and x2 will always be having a positive value, non-negativity criteria. X1 and x2 will always be having a positive value, right? So we'll be only talking about this region. So if I try to visualize, can we say this is the region which is able to fulfill all the conditions? This one, right? And take the corner points. This is the 4 corner points of this particular region. This is A, this is B, this is C, this is D. Now if I try to visualize, if I try to remove constraint 1, will the feasible region is gonna change? If you are removing the constraint number 1, will my feasible region is gonna change? Answer is no, because you can see already if I try to remove 1, still this region will be remaining same. So the type of constraint which is not, even if you are removing that constraint, there is no change in the feasible region. This type of constraint we call it as a redundant constraint. This type of region we call it as redundant constraint, right? Is this clear? Okay, now graphical method states that you have to identify this is the feasible region. You identify the feasible region over here, feasible region, right? Once you identify the feasible region, now you have to see the corner points. So A, B, C, D, 4 corner points. A is having a coordinate of 0, 0, B is having coordinate of 8, 0, C we have to calculate, D is having coordinate of 0, 10. So what will the coordinate of C? It's an intersection of constraint 2 and constraint 3. Constraint 2 and constraint 3. So what is constraint 2 and 3? This is constraint 2 and this is constraint 3. 3x1 plus x2 is equal to 24 and x1 plus x2 is equal to 10. Right, subtract these two, you will be getting x1 is equal to how much? 2. This is 14, that is 7. X1 equal to 7, x2 is equal to 3. So we are getting the coordinates as 7, 3. Point C is having coordinates of 7, 3. Okay, what's the objective function? You have to maximize 2x1 plus 5x2. 2x1 plus 5x2. So let's place all this value 0, 0, ZA is equal to 0. ZB will be equal to 8 into 2, 16. ZC will be equal to 7 into 2, 14 plus 3 into 5, 15. That is 29. And ZD is equal to 5 into 7, 40. Z is equal to 5 into 10, 50. Okay, and we are talking about maximization problem. So the maximum value we are getting at point D. So this is our optimal result, optimal solution, right? So we can say the maximum value of the objective function is equal to 50, and at which point we are getting? At 0, 10. Very good. It's 0, 10. That means at x1 equal to 0 and x2 is equal to 10, I am getting the maximum objective function is equal to 50. What was that? 2x1 plus 5x2. That is equal to 50. Right? Now, if I try to visualize here, even if you are having, okay, you can see the optimal solution is not depending on x1. The optimal solution is because x1 equal to 0. x1 equal to 0 means your final optimal result is not depending on the x1 variable. So this kind of solution where the basic variable, or we can say your decision variables or simply variables is not depending upon the value, or we can objective function is not depending on the basic variable, this kind of solution we call it as degenerate solution. Okay, when your variable is having, one of the variable is having a zero value in the optimal solution, when the variable is having a zero magnitude, this kind of solution we call it as a degenerate solution. That means our final result is independent of x1. It is not depending on x1. It is only depending on x2. If I want to have the maximum result, the 50 value, we are only getting when x2 equal to 50 and x1 equal to 0. That's it. So this kind of solution we call it as a degenerate solution. Sometimes you are getting questions like this also from graphical perspective. Okay, right? Perfect. Now, clear? Now there are some additional parameter that you need to understand. What is the binding constraint? And second is the non-binding constraint. What is binding constraint? Binding constraint is basically, we are having three constraints with us. This one, and this one, right? So if you place the optimal results in the different constraints, if LHS and RHS is exactly equal, we call it as binding constraint. When LHS is not equal to RHS, we call it as a we can say non-binding constraint. You can clearly see the optimal result is getting at 0, 10. Let me write the three constraints. x1 plus 3x2 is equal to 40. Then we are having 3x1 plus x2 is equal to 24. Okay. 3x1 plus x2 is equal to 24. I think we are not able to see x1 plus 3x2. And it automatically is getting deleted. 1 second, guys. I think whatever I'm writing is getting deleted. Okay, so let me check what has happened. Keep. Now please check all good. First constraint is x1. x1 plus 3 x2 is equal to 40. x2 is equal to 40. Then we are having 3x1 plus x2 is equal to 24. 1 plus x2 is equal to 24 or less than equal to basically. And third is x1 plus x2 is less than equal to 10. Right? Now, if you try to place this optimal solution in this one, so if I try to place it over here 0 and 10, that is 30, that is less than, so I can say this is a non-binding constraint. This is a non-binding constraint. Why? If you try to place this optimal result over here, your LHS is not equal to RHS. That is the reason we are calling the first constraint as non-binding constraint. Okay. Now, if I try to place in the second one, second constraint, x1 equal to 0, x2 equal to 10. So again, it is LHS is not equal to RHS. This is also a non-binding constraint. Third one, because LHS is exactly equal to RHS, this is a binding constraint. Binding constraint because LHS exactly equal to RHS, right? Okay. Chali. Now, there are some special cases from where you can 100% get questions. If they're asking question from LPP, they're gonna surely ask question from these special cases. What's the special cases? The first one is infinite or multi-optimal solution. Okay. Now, let us suppose you are getting one region. Let's say I'm getting one region over here, right? Let me use it over here. So we are getting this as a feasible region, right? This is A, B, C and D, right? It is being observed that ZA is equal to 0, ZB is equal to 10, ZC is also equal to 10 and ZT is equal to 8. Okay, so here let's suppose, and the question is maximization problem, right? So here we can see we are getting the maximum values at multiple points. So whenever the maximum value is we are getting, if we are the we can say the optimal results, if we are getting at multiple points, this kind of solution we call it as the multi-optimal solutions. Okay, because I'm getting the optimal results at multiple points. So whenever the optimal results we are getting at multiple points, this kind of solution we call it as infinite or multi-optimal solution. Okay, is this clear? Simple way to understand. Second one is no solution. Very easy. Let us suppose I'm getting a region like this. This is constraint number 1 and the second constraint is like this. Okay, so here what is happening, we are getting no feasible region. Whenever we are getting no feasible region, this kind of solution we call it as no solution. Whenever we are getting no feasible region, here we can see this is a, both the constraints are not intersecting at any intersection point, we are not having a common intersection region. So this kind of solution we call it as no. That means this does not have any optimal results. It is not having any optimal solution. Okay, next one, unbounded solution. Let us suppose I am calculating the minimization problem. Normally you will be visualizing this in minimization. Okay, you're calculating Z minimum, right? And this is the constraint number 1 and this is constraint number 2. Constraint number 2 is constraint number 1. So if I try to visualize what is the feasible region that we'll be getting, the feasible region that you will be getting will be somewhere around here. Okay, this is the feasible region that we are getting, and which is not having any boundary, right? It is an unbounded solution. So it is not like this, you won't be getting an optimal result. You can get an optimal results, but it is unbounded. But the maximization problem, unbounded solution is not defined because it will be tending to infinity. The last maximum value will be infinite. So you won't be getting a solution, defined solution for a maximization problem. Yes, for a minimization problem, you can get unbounded solution to be defined. Okay. These are the extreme points. We'll be checking the solution at these 3 points. Right? Graphical method. Okay, clear? I told you it won't be taking much time for graphical, but yes, simplex will be taking slight time. So now let's talk about the next one, that is simplex method. Acha, anyone having any doubt in graphical, please do ask, because simplex is exactly similar, but slightly the approach is different, but the concept is exactly same. The multi-optimal, no solution, unbounded solution, all good, all perfect. Yes. Right, chalo. Now let's talk about the simplex method. What is a simplex method? Simplex method is basically an iterative method. Iterative method. Asha, can you tell me what is iteration or iterative method? Anyone? What is the meaning of this word iteration? Yes, Harikesh, Vinay, Shreyas. Iterative का क्या मतलब है? What is the meaning of this word iteration? Not that important, but yes, they have asked in the previous 5 years once a question was asked, so let's better have a basic understanding. Trial and error, repetitive, modification, repeating. Okay, iterative means we won't be saying repeating. Iterative means step by step calculation, like you might have done some programming in first year or second year, where we try to run the code. Okay, and let us suppose sometimes what happens was the code was running in an infinite loop because it was not able to get the optimal results, right? So iterative method is unless and until I'm not getting the final result, this particular code or this particular steps will be repeated again and again, right? So repeated steps to calculate the best possible solution, we call it as iterative method or iterative solution. So simplex method is one of the iterative method in which we will be using to get the optimized results, right? Okay, fine. So here also we will be using some examples in order to understand, because basic three requirements will be fulfilled: objective function, constraints, and non-negativity criteria. Okay, fine. So let's go with the first one. Let's take an example. This is the objective function, right? And please try to listen to this carefully. Only one question is more than sufficient enough, because it will be giving you a easy or better understanding. Now, there are three constraints. Now, the first step in the simplex method is we have to remove this inequalities. So if you want to remove this inequalities, I have to, now if I say constraint number 1, it is x1 less than equal to 4. If I want to remove this inequalities, can you tell me a variable must be added on the left hand side or on the right hand side? Where I need to add the variable so that I can remove this inequality, only equality term will be there. Yes. Where I have to add that new variable in constraint number 1. This is x1 is less than equal to 4. So where you need to add the variable, left hand side or here to remove this inequality? So definitely it is less than equal to, I need to add a variable on the left hand side. Okay, so this will be plus s1. Similarly, we can write 2x2 plus s2 is equal to 12. Then 3x1 plus 2x2 plus s3 is equal to 18. So we have added the three variables. Here x1 and x2 are called main decision variables. Okay, x1 and x2 are called main decision variables, and s1, s2 and s3 is called as slack variables. Okay, s1, s2 and s3 are called as the slack variables, right? Okay, fine. 1 second guys. Okay, yeah. Clear? Now, once you have removed that inequality, now is, if you try to visualize, what is the number of equations? The number of equations is equal to 3, and number of unknown parameters, a number of unknown variables. How many unknown variables are there? Yes, anyone? Number of equations is 3 equations are there in front of me which we can solve, and number of unknown variables are x1, x2, s1, s2 and s3, that is 5. Right, we are having 5 unknown variables, 3 equations. Is it possible to calculate? Is it possible to calculate, or can we calculate the best solution over here, or can we calculate the exact solution over here? It is not possible. If you want to calculate or identify the 5 unknown variables, I need to have 5 equations. 3 unknowns, 3 equations, 2 unknowns, 2 equations. So here we are having 5 variables, 3 equations, not possible. So that means we are having an extra variables. How much? We are having an extra variable of 2. 2 are the surplus or extra variables. We are having 2 as the extra variable, right? Okay. So let us suppose, if I'm assuming those extra variable to be equal to 0, let's say x1, x2 or s1, s2, right? If I assume this, any of the 2 variables, we are having total 5 variables. How many? We are having x1, x2, s1, s2 and s3. These are the 5 variables that we are having. Among these 5 variables, if I am assuming that any 2 random variables to be equal to 0, then problem will be solved, because then we are only left out with 3 variables, 3 equations. Problem solved, है ना? Right? So can you tell me, if I am taking at a time two variables to be equal to 0, how many number of solutions will be possible? Number of solutions possible will be, number of possible solution, number of solutions possible will be equal to how much? Anyone? Exactly 5C2, that is equal to 10 ways. 10 ways I will be able to identify the solutions. So among this 10 possible solutions, I have to identify the best solution. That is the objective of LPP. Now we have identified there will be 10 solutions or 10 ways I can get the solution. Among these 10 solutions, I have to identify which solution is the best one. So I have to go for some iterative process. That is your simplex method. That is your linear programming problem. The problem is, here the problem is which one? Acha, 1 second guys, 1 second. Okay, fine. Now we were discussing, where were we? Now we were talking about out of 10 possible ways. 1 second, are we having this? Out of 10 possible ways, which solution will be giving you the best solution? To identify, for using that we have to go for the simplex method. Right? Okay, now our topic is, our agenda is how to proceed with that. So it's an iterative process, right? And one more thing, because we have introduced slack variables in the constraints, I have to introduce over the objective function also. Because if I'm showing S1, S2, S3 over here on my constraint, so I have to show it over the objective function, that is 3x1 plus 5x2. So here we are not having any slack variables. So how we can go for that? Sir, it's quite easy. What we can do, let us have this one. Let's have the coefficient of the slack variables equal to 0. That means even if you are getting the value of slack variables after solving, it won't be creating any impact on the objective function, because slack variables is being added in order to remove this inequalities. Okay, slack variables is only being introduced to remove this inequalities. But if you are introducing the slack variable, it should be shown in the objective function. So we have done one very simple way, just have a 0 as a coefficient of the slack variables in the objective function, so that even if you are getting the value of slack variables as the final optimal solution, no problem, our final solution won't be having any impact on this. Okay, perfect. Now what we'll be doing is we will be identifying the results step by step. Now we know that there are two surplus variable. So if there are two surplus variable, can we say we will be out of this 5 variables, I have to make 2 variables to be equal to 0. Now, we're having x1, x2, s1, s2, s3. Out of this 5 set of variables, I have to make 2 variables to be equal to 0. Then only I'll be able to get the first solution. right? And that is our main objective. That is our main objective, and this way we'll be able to get the final results, right? Okay, fine. Chalo. So now let's do one thing. Let's put x1 equal to 0, because now our possibility is we always try to take the decision variables, may decision variable to be equal to 0 in the first solution. So if you take x1 equal to 0 and x2 equal to 0, if you put x1 and x2 equal to 0, can you tell me what is the value of s1, s2 and s3? Quickly. Yes. If you put x1 and x2 equal to 0, then quickly, what will be the value of s1, s2 and s3? If you put x1 equal to 0, s1 equal to 4, x2 equal to 0, s2 is equal to 12, right? And if you put s3 equal to 0, we'll be having, sorry, x1, x2 equal to 0, s3 is equal to 18. So are we getting as the first possible solution 4, 12 and 18, which is nothing but the RHS of the three constraints, right? Which is nothing but the RHS of the three constraints. Okay, fine. Now, what we'll be doing is, now tell me one thing, our objective function is this one. If you try to place these set of values, what is the value of objective function? What is the value of z? If you try to place these 5 values in our final solution, you will be getting the z value to be equal to 0, right? And this is basically, we call this as the first solution. This we call it as the first solution. The first solution or the first table, because we will be making the table now. So first table is also considered as the worst table or worst solution. Worst table, or we can say worst solution, not table. We'll be calling it as worst solution. Okay, right? We'll be calling this the first solution as the worst solution. Is this clear? Understood? The first or the first solution or the first table will be called as the first solution. Why? Because our objective function, always we are getting the value to be 0. Objective function to be value is equal to 0. That is the reason we are calling this to be the worst solution, right? So now let us try to draw the table. Now let us try to draw the table. We are having x1, we are having x2, we are having s1, s2, s3. Now here the variables which we are assuming to be 0, this is called as a non-basic variable. Okay, and the variables whose values we are calculating by placing the non-basic variable to be 0, this we called as basic variable, or simply called as basis, right? Okay, fine. Like if I say over here, let me have one slide, 1 second. Let us suppose if I'm having x1 and x2 equal to 0, I'm having some set of value of s1, s2 and s3. This is one possible solution, right? When getting 3 values. Let us suppose in the next iteration I am placing x1 equal to 0 and s2 equal to, or s3 equal to 0. Let us suppose. Then I'll be getting some set of values of x2, s2 and s1, right? Okay, so every time I will be placing 2 variables to be 0 and 3 variables, I'll be getting the value. So whenever I'm placing any variables equal to 0, that is we called as non-basic variable. Okay, and these particular variables we called as basic variable, or simply we can call it as basis. Here also in the second solution, x1 and s3 are is equal to 0. That means this is non-basic variable, and this particular solutions we call it as the basic variable or basis, right? So in the first iteration we are getting x1 and x2 are the non-basic variable, and these 3 are the basic variable. So we can say this is basis, its corresponding value, right? So what are the bases? We are having s1, we are having s2, we are having s3. The values that we are getting is 4, 12 and 80. Okay, now we have to fill up this table. We have to fill up this table, right? These are the different. Now, in constraint number 1, what is the coefficient of x1? Sir, it is equal to 1. What's the coefficient of x2? There is no x2, definitely it is having a coefficient of 0, because I can write this equation as x1 plus 0x2 plus s1, right? S1 is having a coefficient of 1. There is no s2, that is 0 s2. This is 0. There is no s3, so 0, right? Second equation, if I want to see, x1 is not present, so it is having 0 constraint, 0 coefficient. What's the coefficient of x2? That is equal to 2. What's the coefficient of s1? There is no s1, we can place it equal to 0. S2 is 1, there is no s3. Third equation, x1 is having 3, x2 is having 2, s1 is not present, s2 is not present, s3 is, right? So this way I have filled up the table completely. My table number 1, this we called as table number 1. This we called as table number 1. Okay, fine. This is basically we called as table number 1. Understood? Right? Clear? Any doubt you were having? Okay, done. Fine. Now, there is one more coefficient that we need to understand, that is Cj, that is coefficient in the objective function. What is the coefficient of x1? That is 3. Coefficient of x2 is 5. Coefficient of s1 is 0. This is 0 and this is 0. Now, if you try to visualize the basic variable is s1, s2 and s3. Is it not forming a unit matrix? 1 0 0 0 1 0 0 0 1. Please have a look over here. Please have a look over here, this one. In the same sequence, S1, S2 and S3 is making a unit matrix, that is 1 0 0 0 1 0 and 0 0 1. Yes? है ना? Everyone? And it always make a unit matrix. That is the best way, because sometimes when you are writing now, whenever you are making the table number 2, it will take some time, right? So to ease off your effort, I'll giving you a direct simple techniques, and there is one more technique also to fill up the table. One is, it will always form a unit matrix in the same sequence. S1, S2, S3, 1 0 0 0 1 0 and 0 0 1, right? Okay. Now similarly, I'll be writing the Cj values over here also, that is 0, 0 and 0, S1 and S2 and S3. Now, I have to identify, because this is the worst solution, this is not the best solution. I have to see among S1, S2 and S3, one of the variable I have to make it 0, and among X1 and X2, I have to make one variable to become basic. That means among S1, S2 and S3, I have to make 1 to be 0, and among x1 and x2 I have to make this non-basic to a basic, because in the second iteration two variables that will be 0, x1 or s1, x1 or s2, x1 or s3, or x2 or x1, x2 or x2 or x2 or s3, right? Two variables I have to make it 0, and which one will be the two non-basic variables, that will depend upon some few steps that we have to do it right now. Okay, what you have to do is, now if you try to visualize, we'll be calculating the Zj value. What is Zj value? You have to multiply the Cj value 0 into corresponding value, 0 into 1 plus 0 into 0 plus 0 into 3, that is equal to 0, right? If able to see this, let me hide myself. Okay, now if you're able to see this one, this is 0, right? Over here, one second, let me use a pointer. Now I think it's quite visible. This is 0. So 0 into 1, 0 into 1 plus 0 into 0 plus 0 into 3. If you try to write, we'll be getting 0. Right? Is this clear? Okay, fine. Now let me use a pen. Now 0 into 0, 0 into 2 plus 0 into 0, it will be also 0. So ultimately you'll be getting a 0 value, because the Cj values for the S1, S2 and S3 are 0. Multiply 0 with anything, and if you try to add, it will be always landing with 0. Now there is one very most important parameter, that is delta. What is delta? That is Cj minus Zj. Now Cj value is 3, Zj value is 0, that is your plus 3. This is plus 5. This is 0, 0 and 0. Now here what we have to do is, among all the variables, you have to see only the delta value of the non-basic variable. This is the non-basic, this is also non-basic. Okay, let me do one thing, let me write it over here also. I think you are able to see this one now, right? So I'm writing the delta value, that is plus 3, plus 5, 0, 0 and 0. Right? Now this is the non-basic variable. This is the non-basic variable which is outside the system, because our final solution is being governed by S1, S2 and S3. For this particular table, S1 and S2 and S3 are the basic variable or basis. X1 and X2 are the non-basic variable, right? So I know that this is not the best solution, but one thing I know, that among X1 and X2, one should be in the basis. Okay, one should be in the basis. Now which variable I have to select? For that you always need to select that non-basic variable, because I'm talking about maximization problem. Okay, now if X1 is becoming basic variable, it will increase the objective function by plus 3. If X2 is becoming basic variable, it will be increasing the objective function by plus 5. So tell me, among X1 and X2, which variable you will be selecting? Which variable you will be selecting between X1 and X2? Because X1 is going into the system, it will increase the objective function by plus 3. X2 is going to the system, it will increase objective function by plus 5. So definitely we have to maximize the results. I have to select the best way, that is X2 will be the variable which will be entering the system. This is the entering variable. This is your entering variable. Right? So once entry variable is decided, that means X2 will be going and becoming basic variable. So among S1 and S2 and S3, one should be going outside the system or becoming a non-basic variable. How we can identify? For that we have to use a replacement ratio, that is theta minimum. What is theta? Theta is equal to value divided by the corresponding key column. Okay, because entry variable is also known as key column. Right? How we can calculate? Now for row number 1, the value is 4. 4 by 0 is infinity. 12 by 2 is 6. And 18 by 2 is 9. Right? So among these three, theta we call it as replacement ratio, because it is helping us to replace the value. Replacement ratio. Okay, infinite, 6 and 9. So among this we have to identify the minimum most value. Minimum is 6. Minimum is 6. So I will be selecting S2 as the exit variable. I will be selecting S2 as the exit. That means in the next iteration, X1 and S2 are the non-basic variable. S1, X2 and S3 are the basic variables. Is this clear? Understood. It's very important. These steps are very important, and ultimately you will be able to understand in very easy way. Okay. Fine. This is the exit variable, this is the entry variable, and the intersection of exit and entry variable, this is basically we call it as a pivot element. This is we call it as pivot element. Okay, this is called as pivot element. Is this clear? The intersection of the entering variable column and exit variable, this is also called as key row. This is also called as key row. Okay, so this is called as pivot element. Now I have to make the table number 2. I have to make the table number 2. How we will be able to make table number 2? Sir, very easy. What we can do is same way, X1, X2, S1, S2, S3, right? And the value, the basis, right? Now here basis has changed. S1 is remaining at the same position. Instead of S2 we are having which is the entry one, X2 is the entry variable, and S3, right? Now we know that bases always form a unit matrix. already we know that's S1, X2, S3. It will be forming unit vectors 1 0 0 0 1 0 0 0 1. So let us write it in the same sequence over here also. We'll be having S1 is 1 0 0, X2 is 0 1 0, S3 is 0 0 1. Okay, table number 2, at least we have able to identify some values. And the second way to fill up the table is whatever is the exit variable, the values, you have to divide this with the pivot element. That means 12 divided by 2 is 6, 2 divided by 0 is 0, 2 divided by 1 is 1, already we have written, 2 divided by 0 is 0, already we have written, 2 divided by 1 is 1 by 2, and 2 divided by 0 is 0, already we have written. Now we are left out with 1, 2, 3, 4, 5, 6 places we are left out. Let us remove this. We are left out with 6 places, right? So now we have to fill up this 6 places. Now what we have to do is, to fill out this 6 places, there is a simple formulation, that is new element is equal to old element minus key row into key column divided by pivot element. Now here also there is one more simple technique. What we can do is, now if I talk about this particular value, right, this one, so its corresponding key row and key column, one of the value is 0. If you place it over 0, so new element will be exactly equal to old element, so we can say this is exactly equal to 4, right? If you place it over here, if I write for this particular 18, so 18 is the old value minus corresponding key row and key column 12, and 2 are the corresponding key row and key column, that is 12 into 2 divided by pivot element is 2, so this is equal to 6. So we'll be writing it as 6. Over here we'll be writing it as 6. Okay, now let us suppose I want to write the value over here. In this particular cell, right? So old value is 1, corresponding key column is 0. So if one of the value is 0, we can directly write the new value to be 1, because if this is 0, 0 into something by something is definitely 0 only, right? This entire value will be 0. So old element will be equal to new element. Now if I want to write this value, that is S2, corresponding is already 0. So old value is equal to new value. This is 0. Now let's try to calculate for this one. Corresponding key row and key column is 1 and 2, right? So we can write it over here. That the old value is 0 minus key row is 1, key column is 2 divided by 2, that is equal to minus 1. So I'll be writing here as minus 1. Okay. Now the last value is this one. Corresponding key row is 0, so we can write it as 3. So we have completed the table. Over here with the values also, right? Fill out the table. Now we'll be writing the CJ values. X CJ value is 3500, 35000, and CJ value over here is this is 0, this is 5, and this is 0. That's it. Now the next iteration will be, this is table number 2. Okay, this one is table number 2, right? So I have already written the table number 2 over here, right? Now again the same iteration will be doing. That. This is table number 2, right? 1 by 2 minus 1, everything we are getting. This is your table number 2. This is your table number 1, which you have already taken as a first solution. Now in table number 2, again we'll be doing the same process, right? Now S1 is having a CJ value of 0, X2 is having a CJ value of 5, S3 is having 0. So let us calculate the value of CJ. Okay, CJ value is 0 into 1 plus 5 into 0 plus 0 into 3, that is equal to 0. 0 into 0, 5 into 1 plus 0 into 0, that is equal to 5. 0 into 0, 5 into 0, 0, that is equal to 0. 0, 5 by 2, 0, 0, 0 and 0, right? So delta value, let us write delta value, right? So we'll be having Cj minus Zj, Cj minus Zj, that is equal to 3 minus this is 3, this is 0, this is 0, this is minus 5 by 2 and this is 0, right? So among these, because I'm talking about maximization problem, here we have to see the delta value of the non-basic variable. So what is non-basic? X1 is non-basic and S2 is non-basic. So among X1 and X2, let me see, is there any value? Among X1 and X2, which one will be the entry variable now? I hope you are able to see. One second, you are not able to see. One second, yeah. Now you are able to see this one. Among X1 and X2, among X1 and S2, which is having a larger value delta? If S2 is becoming a basic variable, it will decrease the objective function by minus 2.5. Okay, this is, oh sorry, Zj. Cj is already written, huh? This is Zj, this is Cj minus Zj. Okay, Ajay? This is Cj minus Zj, right? Fine. Huh? Now, if I try to take S2, it will decrease objective function by 2.5 value. But if I try to take X1 as the entry variable, it will increase the value by plus 3. So definitely this will be your entry variable. Okay. Fine. Plus no, Cj minus Zj, right? Cj is 0. Zj is 5.5 by 2, that is 2.5 basically. So it is minus 2.5. Ajay? Minus 5 by 2. Delta is Cj minus Zj. Cj is, okay, clear? Fine, perfect. Right. Now, we have identified X1 will be the entry variable. Then which one will be the exit variable? Theta value divided by your corresponding key column. So 4 by 1 is 4, 0 by 0 is infinity, 6 by 0 is infinity, 6 by this is 2. So you will be having which one as the exit variable? Very good. S3 is the exit variable. S3 is the exit variable. Is this clear? This is our exit variable. Very good. S3 is our exit variable. In the question, in the GATE examination, they have asked question from this topic. They have given you the table and they have asked which is the entry and exit variable for 2 marks. Okay, they have asked one question from this topic. Okay, fine. Now I think we are able to clear hai? Fine, chalo. So now we have identified. So again, we'll be going for the same iteration. I'm not going for repeat that step. So we'll be having the same steps will be repeated, right? So we are having, let me draw the table. We are having X1, X2, S1, S2, S3. We are having value. This is basis. Now we are writing table number 3. Now we are writing table number 3, right? So we are getting, I'm doing the same operation, right? S1, X1 and X2. I've solved it for you guys. So you'll be getting 2, 6 and 2. This is 0, 0, 1, right? And we are having this as 0, 1, 0. This is X2 and this is X1. Uh, 1, 0, 0. S2 is 1 by 3, 1 by 2 and minus 1 by 3. And S3 is minus 1 by 3, 0 and 1 by 3. Okay, I'm writing the direct values because we are short of time, because just now I got a call that you are having the aptitude class also, right? You're having aptitude classes from I think 5 p.m. Oh sorry, 5:30 or 6. So I need to wind up by 5 o'clock. I just now got a message. Okay, chalo. So now let's try to check whether the solution that we have got is optimal or not. Okay, so again the same process. This is Cj value, that is 3, 5, 0, 0 and 0. So let's calculate the value of Zj. So this is 0, this is 5 and this is 3. So 0, 5 and 3, 0, 5 and 3, 0 into 1, 0, 5 into 0, 0, 0 into 0, that is 0, 0, 5 by 2 and minus this. So this is 2.5 minus 1, that is 1.5, 0, 0 and 1, right? So Cj minus Zj, Cj minus Zj, that is 0, 0, 0, minus 1.5 and minus 1. We only have to see what? We only have to see the non-basic variable. Here the non-basic variable is S2 and S3. These are the non-basic variable. Now, if S2 is going into the system, is becoming basic, it will decrease the value of objective function by minus 1.5. If S3 is going into the system, it will decrease by minus 1. So, which one you will be preferring? S2 or S3? Our objective was to maximize. Very good, Ajay. Won't be selecting anything. Why? We have to get the maximum value. So in the next table, we'll be getting the decreasing value. So we have reached that maximum limit. That means this is the solution is optimal solution. This solution that we are getting is an optimal solution, right? So now we can see that your x1 is equal to how much? X1 equal to 2, x2 is equal to 6, s1 is equal to 2, right? And s2 equal to 0 and s3 equal to 0. So by using this set of solution, we are getting the optimal result, optimal solution. Solution is optimal, and what is the objective function that we are getting? 3x1 plus 5x2, right, plus 0s1 plus 0s2 plus 0s3. This was the objective function, and which we need to maximize. Now if you try to place this, the maximum objective function, the maximum value that you will be getting is z max, that you will be getting is how much? 36. If you place this value over here, the z value, maximum value that we are getting is 36 exactly. And believe me, if you are using, let us suppose you want to solve the same problem by graphical, it will hardly take 3 minutes or 2 minutes to solve this question. It will hardly take 2 or 3 minutes. So that is the reason, if you are getting a question from the LPP, you are definitely gonna get question from using the graphical approach only, right? Don't worry about that. Simplex, you only get a question from the intermediate steps, or they'll be asking you what is the entry variable, exit variable. They'll be giving you the direct table, and they'll be asking you what is the value of the objective function in the next iteration. Okay, yes, definitely I'll be going for the queuing model only, right? Because that will be the last topic, because of the constraints in the time. Sequencing transport is assignment, it's slightly on the easy side, and possibility of getting questions from these 3 topics are slightly lesser. I'll be going for the queuing model, don't worry about that. Okay, is this clear? Fine. Okay, now here also we need to identify how we can go for identify the optimal solution, or we can say infinite solution, no solution, unbounded solution. In case of simplex, it was easy to identify in graphical approach, but how we can analyze or how we can identify in this one, we can say simplex method, it's slightly on a tedious task, slightly. Okay, now in case of your infinite optimal solution, let us suppose I'm getting some random table, right? So you're having x1, we are having x2, we are having x1, we are having x2, we are having s1, s2 and s3, right? Let us suppose, and in x1, let's say we are having this as value and this as basis. Let's say x1, s1 and x2, right? Let us suppose. So can you tell me, by looking at the table, which one is the non-basic variable? by looking at the table, can you tell me which variable is the non-basic variable? Quickly. Definitely. I think we have taken one question also, Faninder. We have taken one problem also from graphical. Okay, don't worry, I'll be taking one more question. The same question which we have solved by using simplex, na? Same problem. Very good. So you can see clearly x1, x2 are the basic, these are basic variable because it is having some value, right? And s1 also. S2 and S3 are non-basic variable, non-basic variable. Okay, fine. Or let us take one more example. Okay, let us take this as a scenario. S2, x2 को ले लेते हैं. Let us say this is S3. Okay, this is basic and this is non-basic, right? Okay, fine. Now try to visualize this. I'm getting some 0 over here, basic variables. I'm getting the z value, the delta value to be equal to 0. Let us suppose. Okay, fine. Now if I try to solve, and you're getting the non-basic variable this to be negative and this is also negative. Tell me whether the solution is optimal or non-optimal. First of all, tell me this. Question is maximization. You have to maximize the result. The non-basic variable is getting a negative value. It is optimal because if non-basic this is going into the system, it will decrease the optimal solution. If this is going, this will decrease. So definitely this is an optimal solution. Let's suppose I'm having one more scenario that this is equal to 0. This is equal to 0. Now what is the meaning of this? If this x2, because x2 is also the main decision variable, x1 and x2 are the decision variables, right? If a non-basic decision variable is having a delta value equal to 0 in an optimal solution, then if x2 is going into the system and becoming basis and one of the bases becoming a non-basic, still I'll be getting the objective function to be same value, but the set of solutions will be different, right? That means let us suppose if this is becoming non-basic, this is becoming basic, and among this one of the becoming is becoming a non-basic. What has happened that for the two different set of values I'm getting the same objective function, something like this. So that means whenever a non-basic decision variable is also getting a 0 value of delta, then this kind of solution we call it as multi-optimal solution. This kind of solution we call it as multi-optimal solution. Okay, is this clear? Fine. Away, because if they are asking you from the simplest perspective, you should be knowing how to identify the this one. Okay, chalo, next one, how to identify. Let us take one example. Like I think Faninder is getting some variation in the answers. Let's see. Question was, what was the question? Let me write the question over here. X1 is less than equal to 4. After this only. X1 is less than equal to 4. 2x1 is less than equal to how much? I think 12. No? 2x1 is less than equal to 12. And 3x1 plus 2x2 is less than equal to 18. Let me cross check. 3 to 18 to 12. Okay, let's try to solve this by graphical also. So we can get this as, let me draw it over here. X1, X2, X1 equal to 4. This is 4, somewhere around here. First constraint. Second is we can write x. This is x2, na? X2 is equal to 6. Second constraint less than equal to 6. So this is 6. second constraint. Third constraint is x1 by 6 plus x2 by 9 less than equal to 1. Let me use different color, that will be easy for us. Okay, x1 is 6 and this one is 9. Okay, so this is the feasible region that we are getting. Okay, this is the feasible region that we are getting. So let us say this is point A, this is point B, this is point C, this is point D. This is not required. A is having a coordinate of, let me write it over here. A is having a coordinate of 0, 6. B's you can calculate intersection of 2 and 3. x2 is equal to 6, place it over here. This is 12, that will be 6, that is 2. This will be 2, 6. C will be 4, this is 12, 6, that is 4, 3, and D will be equal to 4, 0, right? Okay, so now you can calculate Z max. You have to calculate at 3x1 plus 5x2. Place it and tell me. I think you will be getting at this point. You will be getting the maximum value at B. You can cross check. It will be 36. At A you are getting 30. At C we are getting 12 plus 15, that is 27. At D we are getting 12. So definitely at B we are getting maximum value. Hana? So that entire problem that we are used by using simplex, we are able to solve within fraction of minutes, like 2 or 3 minutes, by using the graphical. That is the reason graphical is very important from examination perspective. Okay. Chalo. Now we are talking about no solution. Now it was very easy to identify using the graphical approach, but how to identify by using the simplex method that the solution is having no solution? So here what we can do is, if your we can say, let me write it like this. Let us suppose I'm having a minimization problem. We're having a minimization problem. Z min is equal to some set of values, and there is one constraint as x1 plus x2 or x1 plus 2x2 is greater than equal to 3. Okay, let's suppose we're having some equation. So if I want to remove the inequality signs, can you tell me where will be the slack variables need to be introduced, LHS or RHS? Can you tell me? If I want to remove this inequality sign, I will be introducing the slack variables on the RHS, because right hand side is small, or we can say x1 plus 2x2 minus s1 is equal to 3. Okay, fine. And if I'm placing, let us suppose x1 equal to 0 and x2 equal to 0, what is the value of s1 you are getting? The value of s1 will be minus 3, which is not possible. Why? Even though we are talking about slack, this one, decision variables or the slack variables, these all variable must always be having a positive value. This always must be having a positive value, but here we are getting negative value. This is not possible. This is not possible. So here what we'll be doing, we will be introducing a concept of artificial variable, and here we will be using the concept of big M method. Okay, basically it's not in your syllabus, but we need to understand the no solution. Okay, how we can identify the big M method? What we'll be doing, we'll be writing x1 plus 2x2, right, is greater than equal to 3, is greater than equal to 3, right? So we can say x1 plus 2x2 minus s1 plus a1 equal to 3. Okay, this a basically resembles the artificial variable. Artificial variable. Okay, now if I try to write because there is only one equation for unknown variables, so three variables are surplus. So replacing x1, x2 and s1 equal to 0, right? So when you place this value equal to 0, we are getting a1 equal to 3, which is a positive value, So now we can solve this by using the same way which we are using the simplex. But here, let us suppose the objective function was z minimum. It was minimum of z. So whatever equation we are having at the end, we will be adding one m1a or ma, because here we are having only a1, so m into a1. If we are having two equations a1 and a2, we will be having ma1 plus ma2, right? Okay, so whenever we are dealing with minimization problem, you have to add this ma1. Whenever we, because in objective function also we need to introduce, let's say we are having objective function as 3x1 plus 2x2 plus 0s1 plus m times of a1, and this m is having a larger magnitude. Okay, fine. Big M method is basically whenever we are dealing with minimization problem or a greater than equal to inequality, there we need to introduce the artificial variable. Okay, fine. Now coming back to why we are discussing this, over here, because we are having we have to introduce no solution if in the final optimal solution, artificial variable is present as the basic variable, then solution is termed as no solution. That simply means if artificial variable is present as a basic variable in the final solution, something like this, let's say x1, x2, s1, a1, okay, and base, this is value, and we are having some bases, and we are having x1 and a1. Let us suppose this is the final solution, right? And we are getting the delta value to be, let's suppose this is 0, this is 0, this is positive, and this is positive, and we are having some minimization problem. Okay, so definitely this is an optimal solution, but because in the optimal solution the artificial variable is present, due to that we can say the solution not optimal. Why? Because here just like slack variables, a is not having 0 coefficient, a is having some finite value. So if a is present in the final optimal solution, that will result in a we can say undefined value that will be having in terms of m, which is undefined. So that means our solution is not possible. So we can say if an artificial variable is present as a basic variable, then the solution will be called as a no solution. Clear? Fine, then the solution will be called as a no solution. Done? Understood? Clear hai? Chalo. Next, the last one, unbounded solution. How we can identify the solution is unbounded? In this case, if the replacement ratio that is theta minimum is either having all value negative or infinity, then solution is termed as unbounded. That means the theta value, definitely, either you are having negative or infinity, this is infinite, okay, then the solution all value either negative or all the value are infinite, then the solution will be termed as an unbounded. You'll be getting the PDF of this, don't worry about it. Okay, I'll be sharing on my Telegram channel also. Fine. Perfect. Next is a duality. Next, it is a duality. Now, duality is basically helping us to identify a very important aspect, because in duality, we'll be able to calculate the dual of a primal function. Let us suppose I'm having a primal. Primal means the question that we are getting, we're having some maximization problem. This will be called as primal LPP, primal linear programming problem. If you want to calculate the dual of this, then the maximization problem will be converted into a minimization problem. The number of rows will be converted into number of columns. Okay, that means we'll be having a complete transpose. But the best part is the optimal solution that we are getting in the primal will be exactly equal to the optimal solution that we'll be getting in a dual. Whatever optimal solution will be getting in the primal, the same value you will be obtaining in the dual. That is a speciality of duality. Let us take one example to understand this in more detail. Let us suppose I'm having a question like this. Here the primal is to maximize 4x plus 6y, and the constraint that we are having is 3x plus 2y less than equal to 6 and 2x plus 3y less than equal to 6. I have to calculate the we can say the dual of this. So if I want to calculate the dual of this, now maximization will be converted into minimization problem, z minimum. Now this is 4, 6 in row, this is 6 and 6 in column. So this will be transpose. We will be having 6. Now here we are having x and y. We won't be using the same variables. We'll be using, let's say, u1 and u2. Okay. So 6u1 plus 6u2. Right. We can write this as 3, 2, 2, 3. This one. We can write this as in a matrix format. You have to take the transpose of this. Take the transpose of this. This will be shared. So 3, 2, 2, 3. So we'll be having 3u1 plus 2u2. 2u1 plus 3u2, 4. This is less than equal to, greater than equal to 4, greater than equal to 6. So this way we have identified the dual of this. This way you have identified the dual of this LPP. That is this one. This is the dual of the LPP. Dual of this linear programming. Okay. Fine. Chalo, let's now move to queuing model, because queuing model is slightly important. Then if time is present, then we'll be going for forecasting, or else I'll be giving you why z minimum. One second. Yes. Sir, why dual, sir? Dual means just we can say a way to represent the linear programming problem. Okay, the initial problem we call it as primal. Dual means just the opposite way, but the final result, the best way, the best we can say objective of using the duality is we can get the same value. Let's say if I'm solving this, I'm getting the z maximum is equal to, let us suppose I'm taking an example, is coming out to be 36. Let us suppose here also if you want to calculate the z minimum, it will be coming out to be 36. Okay. Fine. That means the objective value is same. I'm taking rough value, right? This is a rough value. I'm writing initially. This is rough value. 6u, that is z minimum, is equal to 6u1 plus 6u2. This is the objective function. Okay. This one will be shifted over here, and 4 and 6 will be shifted over here. Row will be converted into column, column will be converted into row. This will be transposed. So 3u1 plus 2u2 and 2u1 plus 3u2 greater than equal to 4 and greater than equal to 6. Okay. Right, clear. Faninder, I'll be taking, but there's some time constraint. There is like I think one more class is going to happen at 5 or 5:30. So let's see, whatever it's possible. A major topic is being covered. Now let's go with the queuing model. Then we'll be going for the forecasting if the time is there. Okay. Sequencing, I think it's very easy. And if you are having a doubt, you can do let me know, right? So let's go with the queuing model now. Yeah, queuing theory. 15 minutes. Okay, now let's go with the queuing model and then we'll be proceeding with the forecasting. Okay, because students do have a doubt in the queuing theory. Now, what is this queuing theory all about? In this case, we are going for the optimization of how much queue or how much counter should be present. Now, if you go to any food counter, let's say if you are going on a weekday, right? If you're going on weekdays, you might have seen that if there are 5 counters in a food court, let's say there are 5 counters, not all the counters will be operational. Out of 5 counters, might be 2 counters will be operational on weekdays, let's say in afternoon. But on weekends, you might have seen that all the 5 counters will be open. Why this is happening? We could have been opening all the 5 counters on weekdays also. Why we are not assigning executives to the different counters, right, on the weekdays also? Why? Yes. Anyone having any idea? Why we are not allocating all the 5 executives or the 5 counters on weekdays? The reason being, on weekdays, the customers that will be arriving in the mall and the food court will be definitely much more lesser as compared to that on the weekends. On weekends, the arrival of the customer will be very higher as compared to that on the weekdays. And that is the reason we are bringing all the 5 executives. Now, let me tell you one thing. If you are assigning all the 5 executives, you have to pay all the 5 executives. Let us do one thing. On weekend also, you are not bringing all the 5 executives. You are only having this 2 executives. All the 3 executives, you are saying you are on leave. What will happen? You only have to pay for the 2 executives, right, at the counter. All the 3 executives will be saying no need, we can manage with the 2. What will happen? You are investing less amount of money. You only have to pay the salary of 2 executives. So definitely it should be more profit oriented. Yes. What will happen if you are only allocating 2 counters, if you are only opening out of 5 2 counters on weekends? Basically, the queue that will be created now, that will be high. The length of the queue that will be created will be very high, and that is a problematic scenario. The reason being why it is problematic, what will happen if length of the queue is more, whenever, let us suppose you are going to a mall and you are going to a food court and you see that there are like 10 customers standing in front of you for having French fries. Okay, if you want to eat French fries, there are 10 customers. So definitely you won't be going to that particular line. You'll be saying, you either will be skipping this particular counter, or you'll be saying that better come next day. Better you come on next day, that is much more sufficient enough, right? Okay, so basically queuing theory is associated with how much you are investing. As a, let us suppose you are the shop owner, how much you are spending in order to provide service and how much you are getting in return. Okay, that particular optimization is basically your queuing theory. So basically the aim of queuing theory is to achieve an economic balance between the cost of providing service and the service time. Okay, fine. And it is always applied to service oriented organization, like already we have seen a workshop, a repair shop, a food chain, a ATM bank or production shop or food counters. We have seen this kind of analysis in the different service based organization, where customers will be coming in line one by one and be taking the service from the organization. Okay, fine. Now the question is how you can create queuing theory. So here there are some different terminologies that we need to understand. Okay, the basic terminology is 2 things. One is your arrival rate and one is your service rate. Okay, fine. Let me see. Now if you see this particular scenario, this is an example of a bank line in SBI bank specifically, and this is in an ATM. And you might have seen this kind of scenarios definitely during demonetization. We have seen this kind of scenario. Okay, now let us suppose there is one more bank which is, there is one more bank which is closer to your home and it is quite empty, so definitely you will be going for that. Or there is one ATM which is 5 minutes away from this ATM, so definitely you will be proceeding over there. You won't be standing in a queue for more than 5-10 minutes, because it is you'll be saying that better I'll be coming next day and I'll be taking the cash in the next day, unless it is important. Okay, so here what we are doing, we are creating an economic balance between the cost of providing the service and cost of having the service time. Okay, cost of getting the service and cost of providing service, we always try to, or we can say we are creating a economic balance between the service time and the cost of providing the service. Cost of providing service, because if you are going for a lesser service time, that means within 1 minute the next customer will be coming, so the cost of providing service will be very high. All the 5 counters will be open. If you are going for a high service time, then the cost of providing service will be very less. That means only 2 counters are open, but the service time is very, very high. So always need to have an economic balance between these two. That is your queuing model. That particular thing is a queuing model. Is this clear? Okay, understood the basic objective of using the queuing modeling or queuing theory. Okay, now here also what we are doing, we are having 2 basic parameters, and all the entire queuing model is defined by using these 2 parameters. One is your arrival rate, that is lambda. Okay, one is arrival rate, one is service rate. We'll be going in a very crisp manner. Service rate, that is mu. What is arrival rate? It is a arrival of customers per unit time. Okay, that is the customer arriving per unit time, right? Service rate is the service how many customers will be served per unit time. Let us take an example. The arrival rate is 2 customers are arriving every minute. Let us suppose every minute 2 customers are arriving, and the service rate is you are able to serve 5 customers every minute. And always remember that your service rate will always be greater than that of arrival rate. The reason being, if let us suppose arrival rate is high and service rate is less, then the system will be unstable. You won't be able to maintain the system, because the length of the queue will be constantly increasing and it will be going unstable. Let us suppose the arrival rate is 10 and service rate is only 2. That means after 10 customers is arriving after every minute, and only 2 customers you are able to serve after every minute. So in that scenario, you try to imagine the length of the queue will be gradually increasing and the system will be unstable. So we always try to do the analysis that we are doing it over here is only for the stable system. This is basically the stable system, because for unstable system your lambda will be higher, and lambda higher means you won't be able to maintain the system. Okay, fine. So over here we have to understand now, service rate is always exponentially decreasing. Okay, service rate or service time is always having a negative exponential. It's always having a negative exponential. Why it is, one second guys, why it is negative exponential? Okay, let us suppose you are going to a bank at morning 10 a.m. and at 10 a.m. you are going to a bank and you are the only customer in the bank. So definitely the executive, the person who is present, he will be offering you tea, he'll be offering all the additional we can say features that is being provided by the bank. At least half an hour or 40 minutes he will be investing on you. But let us suppose you are the first customer and beyond you there are 100 customers waiting. So I can surely say the executive won't be investing more than 5 or 10 minutes on you. He will be only able to solve the basic problem that is being faced by you. Okay, so if the number of customers is more, the service time will be very high, but as soon as the number of customers is decreasing, the service time will be decreasing. Okay, as the number of customer is increasing, the service time will be decreasing, and that is the reason we are calling the service rate or service pattern is always negative exponential. And if I talk about arrival rate, because it is complete random, so it always follows a Poisson's distribution curve. Okay, fine. Now here there are some terminologies that we need to understand. The first one is rho, that is utilization factor, or we can say this as we can say the traffic intensity. There are different nomenclatures, but utilization factor is the basic nomenclature that we'll be using. So rho is equal to lambda by mu, that is arrival rate by service rate. What is the physical significance of rho? It tells about the probability, because this all are probabilistic approach. We won't be getting a deterministic value. It's a probability that the percent of time our server is busy. Server is busy. Let us take one example. Let us suppose your arrival rate is 2 customers are arriving after 1 hour, and you are having a capability of serving 4 customer, or let's say 8 customer per hour. So can you tell me what is the value of rho? Rho is equal to 2 by 8 or 0.25. That simply means only 0.25% of the time our server will be busy. Rest the server will be idle. Okay, I can say for 0.25% of the time the server will be busy, or we can say that if a new customer is coming, it does not have to wait. Can we say like this? It has to wait. Okay, can we say rho also indicates that it's a probability or probability percentage that a new customer has to wait. This is basically the significance or objective of using rho, that is utilization factor, right? That means for 0.25% of the time, for 25% of the time, if a new customer is coming into the system, our that new customer has to wait. So can you tell me what's the percentage of the probability that the server is idle? Can you tell me? If 25% is the time the server is busy, what is the percentage or probability that the server is idle? Can we say that is nothing but 75% of the time? Exactly. So we can say the probability that server is idle is equal to 1 minus rho. 1 minus rho, that is 0.75%. Or we can say it is the probability that new customer does not have to wait, right? Or we can say it is the probability that there are 0 customer. So all are having the same meaning. So I can say P0 is equal to 1 minus rho. P0 is equal to 1 minus rho. Is this clear? Okay, P0 is equal to 1 minus rho. Understood, everyone? Okay, perfect. And this is the most important one. Many number of times they are asking questions from this topic, this particular parameter, that is rho. Okay, now we have seen probability that the system is idle or 0 customer, that is equal to 1 minus rho. Now if I want to calculate what is the probability that are exactly n customer in the system, that is Pn. So that is equal to rho to the power n into P0, direct. That means if I want to calculate what's the probability there are exactly 3 customers in the system, rho to the power rho cube into P0, because lambda and mu value will be given. One thing you have to understand that you have to always check the units, because sometimes they'll be giving you in minutes. Let's say arrival rate is given in minutes and service rate is given in hours. So you have to see, or sometimes they're giving in per minute and service time given in hours. Right, so you have to see the units carefully, because if you are not assigning the same units, you'll be landing up with the wrong answer. It's very important. Okay, fine. Let us take one example. Let us suppose there are 5 customers arriving after or there are 5 customers arriving in 1 hour, in 1 hour, and the clerk is taking, let us suppose, 5 minutes to serve a customer. First of all, tell me what is the value of lambda quickly. By reading the question, can you tell me what is the value of lambda? There are 5 customers arriving in 1 hour, so can we say it is equal to 5 customer per hour? Arrival it is equal to 5. They are giving that the clerk is taking 5 minutes to serve. That means service time is equal to 5 minutes for one customer. So can you tell me what is the service rate? What is the service rate? That is mu. If 5 minutes you are taking for one customer, how many customers will be served in 1 hour? How many customers will be served in 1 hour? Can we say 1 upon 5 into 60, that is equal to 12. Okay, do not take mu equal to 5. That is the service time be given. It is not service rate. So mu is equal to 12, lambda is equal to 5. Now you can use this formulation and get the value of rho. Rho is equal to lambda by mu, that is 5 by 12. Problem solved. Probability of 0 customer, probability of 2 customer, 3 customer, you can easily calculate whatever they are asking. Okay. One more thing, let us suppose, one more thing that we can add to this. Let me use this space. Yeah. Now, let us suppose they are saying that what is the probability that at least 5 customers are present, are there. What would be the probability that at least 5 customers, that means 5 or more than 5. So can we say that it should be P5 plus P6 plus P7? Very difficult. It is will going on till infinity. Anna? But we know that P0 plus P1 plus P2, this value will be always be equal to 1. The probability of all the possibility will always be equal to 1. So can we calculate, if I want to calculate P5 plus P6 and get them equal to 5, will be simply 1 minus P0 plus P1 plus P2 plus P3 plus P4. P0, P1, P2, P3, P4 we can calculate. So this is going to give me an information about what is the probability that at least 5 customers are there. If they are using, what is the probability that at most 5 customers are there? At most means max to max 5 customers. So we can say probability of n less than equal to 5. That simply means that is equal to P0 plus P1 plus P2 plus P3 plus P4 plus P5. Okay, fine. So this is basically the probability that at most 5 customers are present in the system. Okay, P0 we can calculate, that is 1 minus rho. P1 we can calculate because Pn is equal to rho to the power n into P0. P0 we know 1 minus rho value we already calculate, n value we know according to the question. Exactly. Very good. Very good. Okay. Now, the next very important parameter that they're going to ask you is what is the average number of customers in the system? Every number of customers in the system, that is we can say the length of the queue, that is equal to length of the system, that is LS. So LS is equal to rho upon 1 minus rho. Queuing model is always about the different empirical formulation. Okay. Remember that there are only a few set of equations that you have to remember. And what's the average length of the length of the queue? That means in this case the customer who is getting served is not being included. So average length of the queue is equal to rho square upon 1 minus rho. Or we can write this is rho times LS. Both are having the same meaning. Okay. Rho value we know, that is lambda by mu. Lambda by mu. Very easy, right? There are a lot many questions we have solved by using queuing model in app also. In last 2 months we have taken dedicatedly questions from these topic also, right? So that you can have more practice, right? Now the next one is Little's law. What is Little's law? It says that the length of the system is equal to lambda times the waiting time of the system, right? Or we can say the length of the queue is equal to lambda times the waiting time of the queue, right? This is the Little's law. Lambda into WS, lambda into WQ. WS is the wait time in the system and WQ is the waiting time in the queue. Now, normally we are using this Little's law to calculate the waiting time in the system. Waiting time in system, average waiting time in the system, that is equal to WS is equal to LS by lambda. Similarly, the average waiting time in queue, that is WQ is equal to LQ by lambda. LQ by lambda. Okay, fine. Is this clear? Up till this point, majority, like 95% of your queuing theory is done. There's 5%, there are some empirical formulation that we need to understand. There are 5 additional formulation. That means what is the probability that T time is required to serve a customer? It is e to the power minus mu into T. Already we have seen that a service rate is always negative exponential. Already we have seen that our service time is having negative exponential, right? So this is e to the power minus mu into T. What's the probability that the waiting time of the queue is greater than that of T? The waiting time of the queue is greater than that of T. That is equal to rho times e to the power minus T by mu s or WS. WS is the waiting time of the system, average waiting time of the system. Instead of this TQ, we can write what is the probability that system there is n arrivals in the system during a time period of T. So we can use e to the power minus lambda into T, lambda T into n by n factorial. Once there is only one question till date asked from this formulation. That's the reason we have included this. E to the power minus lambda into T into lambda T to the power n by n factorial. Okay. Clear? Fine. And the last one, the probability that the weight of the system is greater than that of T, that is only rho is not present. If you try to visualize, here we are having rho times e to the power minus T by WS. Here we are having only e to the power minus T by WS. This one. Okay, clear? Let us take one question and try to understand what is being given and how we can calculate. Now, there's a railway reservation block having 20. There are 20 counters in a railway station. There are 20 counters and arrival rate is 50 per hour. The service time is exponentially distributed with a mean time of 5 minutes. They are saying that the service time is equal to 5 minutes per customer. So can you tell me what is the service rate? Anyone? Quickly. What is the service rate? That is mu. It is equal to in hours you have to tell me, that will be 12 customers per hour. 60 by 5, that is 12 customer per hour, right? Now they're saying that if the waiting time is limited to 15 minutes, determine the number of counters to be kept open. There are total 20 counters. There are in total 20 counters. Out of this 20 counter, how many counters should be kept open such that each waiting queue will be having a waiting time of the queue will be 15 minutes. Okay, so let us suppose out of this 20 counters I am opening n counters. Okay, let's say this is capital N as the total number of counters which is present. So let us suppose n is the number of counters to be kept open, right? To be kept open. So here we are having we can say 150 customers per hour as a total arrival rate. So can you tell me what is the arrival rate per counter? Arrival rate per counter, anyone? because they are saying that assume equal distribution of customer to all the counters. If two counters are present, equally distributed. 5 counters are present, equally distributed 5. Okay, so we can say 150 by n will be the arrival rate, not 7.5, 150 by n, because I'm assuming 20 is the total number of counters, I'm only opening n, and that n we have to calculate. Okay, so this is the value of lambda. Now, waiting time of the queue is given in minutes, you have to convert into hours. So, waiting time of the queue is equal to 15 by 60, that is 1 by 4 hours. Okay, now what is waiting time of the queue? That is equal to LQ by lambda, that is equal to we can say rho square 1 minus rho square upon 1 minus rho by lambda. If I write this in terms of lambda and mu, we'll be having lambda upon mu into mu minus lambda. You can cross check. Please try to expand. This is lambda square by mu square. 1 mu will be cancelled out, 1 lambda cancelled, so we're having lambda upon mu minus lambda, right? So now we can say that waiting time of the queue is equal to lambda upon mu into mu minus lambda. Waiting of the queue is 0.25. That is 1 by 4 basically. We can write it as 1 by 4. This is 150 by n. Mu value is given, that is 12. We can take it as 1 by 4, better. 1 by 4. So mu value is 12, and this is 12 minus 150 by n. So this will be 3, this will be 50. So we are getting 12 minus 150 by n is equal to 50 by n. So this will be how much? What is the value of n you are getting? It will be 12n is equal to 200. N is somewhere around, yes, 350. 50 by n. So 12n, 150, 200, 17 and 120. 17, approximately 17. Approximately 17, huh? It will be 100 by 6. 100 by 6 is somewhere around 16.66. 17 we can take it. That means out of 20 counters, if you are opening, that means out of 20 counters, if you are opening 17 counters, then average waiting time per queue is how much? 15 minutes. Is this clear? This is the importance of using the queuing model. You might have seen that if you have visited Delhi Metro, if you have seen any metro station, during morning office hours, almost every counter will be open. And during the off time, that is in afternoon, not all the counters will be open. And in the evening, again, all the counters will be open. Same goes with the railway station. You might have seen whenever the Tatkal booking is done, at that time, almost every counter will be open in the railway station, right? And after that, when the Tatkal duration is being over, during around afternoon, all the counters won't be open. Only a few counters will be open. How you are deciding how much counters will be present? In New Delhi station, we are having this much of counter. In a very small station, we are having only 2 or 3 counters. How you are deciding this? It is decided upon what is the total arrival rate. How much is the arrival rate, how much is the capability of a customer to serve, what should be the average waiting time of the queue. That is a deciding factor to decide how many counters will be present. You might have seen that in some places there are two ATM machines in a particular same ATM, this one, okay, in same ATM bank. Sometimes we are having 5 ATM machines. I have seen some places we are having 5 ATM machines of same bank. In some places we have only 1 ATM machine, that too non-operational sometimes. How you are deciding? Some places we are having 5 ATM machines and some places we are having only 1. It depends upon the arrival rate, the number of customers who are present in that locality. That are the governing factor, and there also we are using the concept of queuing modeling. Okay, is this clear? Understood? Okay, so this completes your queuing modeling. right? So now we are left out with only 3 topics, your transportation, assignment and forecasting. I will be providing you one link, right? And definitely you can do watch that also. It's very easy, not difficult one. So because majority we have already been covered the topics. Okay, so only 3 topics being left out. Don't worry, I'll be giving you one link. You can do watch that, right? Or else you can do let me know. We'll be covering in some separate sessions. Okay, fine. So that is almost we have covered 90% of our industrial is being done. 90 kya, more than 90 from gate examination, almost 94-95% is being done. Transportation, very less chances because lengthy calculation. Assignment, very easy. Forecasting, very easy, right? So I think majority difficult portions we are completing. Okay. Definitely you can go for that also. Faninder, you can go for that also. I think in that I have covered transportation also, assignment also, forecasting also. That is also being included. Actually, I was planning till 6 o'clock because you are having one aptitude class now. I've got one more call from Rakesh sir. So I think it's time to now end the session. Perfect. Right? Okay. Clear? Definitely, Sevi. I'll be sharing this one on my Telegram channel. You can do watch that. You can do download that for your reference. And if you have any doubt or difficulty, you can ask me tomorrow also. We'll be coming tomorrow live in the mechanics. Mechanics won't be taking much time, right? We'll be taking the important because easy topics you definitely can go for very easily. I'll be going for an overview. Only difficult portion which is slightly difficult for some students will be going for that. Lagrange's will be taking that into discussion in detail. So it's almost very easy. Some examples will be taking and you can ask that out tomorrow also, right? Okay, chaliye, thank you guys for joining with me. Let's meet now tomorrow at 10 a.m. Tomorrow we'll be discussing with the mechanics subject. Mechanics is very easy. Only thing is some concept need to be revised. That's it. Okay. Link will be I will be providing the link on my Telegram also. You can download on my Telegram channel, that is Mechanical by Suraj. You can do connect there. I'll be sharing the link. This class PDF will also be floated. Thank you, Faninder. Thank you all of you, and happy festival. There is many festivals going on. Try to invest some time to your studies also. I know festival may slightly difficult to invest time, but still you are consistently being there in the last till end. All of you, right? So thank you. Bye bye. Take care. I'll be sharing the PDF on my Telegram channel, and let's meet tomorrow at 10 a.m. mechanics. And if you have any doubt in the industrial, you can ask me tomorrow also. Okay. Okay, thank you guys. Bye bye. Thank you.